Hello there and welcome to the AWS Advanced Networking course. This is Rahul. Before we jump into the course, I would like to put a disclaimer over here that this course is a little longer course. So I will put all the topics onto the screen, which we are going to cover throughout this session. And this is a part 1 of this AWS Advanced Networking. And soon I will come up with the part 2 of this particular Advanced Networking series. And for those who are just getting started with the AWS networking, so I would highly recommend for you to just start with the chapter 1 and go all the way till chapter 12, because each chapter is necessary to understand these concepts. And one more thing, the last 2 chapters of this particular course are really important, because in those last 2 chapters I have covered the concept of a Route 53 and AWS Certificate Manager. So with those topics, you will be able to know like how to configure your own domain, how to set up your Route 53, and how to deploy your own website onto your AWS cloud. So those 2 chapters are really important once you cover all the previous or the initial chapters. So without further ado, let's jump into the chapter number 1. In this chapter, we are going to focus more onto the networking concept. And when we are talking about the networking concept, then I'm talking about the VPC, public subnet, private subnet, how to create your internet gateway, how to create your route table, and how to provision your resources, for example, EC2 or any other resource inside your public as well as into your private subnet. So I would highly recommend to pay careful attention onto this networking concept, because these networking concepts are gonna used quite a lot when we will move ahead into another chapter and another topics. So without further ado, let's jump into the topic and start setting up your own whole VPC network. To begin with, here you can see this is our targeted setup which we want to achieve once we start setting up our VPC, public subnet and private subnet. So here onto the screen you can see the first box which I have denoted as a AWS. So this is our AWS cloud account, or you already have signed up for AWS account. So that's the boundary of our AWS. Inside that AWS you will find another rectangle which is a VPC. So this is our virtual private cloud. So consider this VPC as a data center. So you're trying to set up a data center on an AWS account, and this VPC, in this VPC you're just gonna create all the resources, whether you're just gonna create a EC2 instance, whether you're just gonna create a Lambda, whether you're just gonna create a ECS service, Kubernetes. So everything we will fall inside this VPC. So that's why we are calling it as a VPC, or in other words we can also call it as our data center, or we can say it as a virtual data center also. Now inside the data center you just need to create more networking, and in the terms of networking what I mean to say is we need to create our public subnet where we will put our resources which is publicly accessible via internet. So that's why we are just going to create our public subnet, which you can see over here. And for example, I have just put a EC2 instance over here. And on the right hand side you will find another subnet which is our private subnet, where we will be putting more resources, but these resources are a little bit specific which we don't want to expose to the internet. So that's why we call it as a private subnet, and we want to create those resources inside that private subnet. And so what's the example of a private subnet and why do we need it? So for example, if you are having a web application, so any web application, the web pages or the web part of that application will reside onto your public subnet on our EC2 instance. This is just an example I'm taking over here. So anything which is accessible to a public will be put onto our public subnet, and anything which is not accessible to public or a client, then we will put onto private subnet. So I'm taking again the same example of our web application. So any web application, if you are just trying to create, then it will have a database. So we are just going to create our database into the private subnet, because database doesn't need to be accessed to by another person. So this database will only be accessible by our web application. So the web application front end part will reside onto our public subnet, but the database side will always reside onto private subnet, because we don't want to expose our database to internet or to the other person. So that's why we need to keep our database inside our private subnet. So that's the basic difference between our public and the private subnet. Apart from that, you might see over here there are IP ranges which I have created. So here at the bottom you will see that is 12.0.1.0/16. So that's the IP range I'm just going to assign for my VPC. And once I assign that IP range, then all the public subnet and the private subnet which I'm just going to create should fall under that particular range. So here I'm just going to then again assign the range 12.1.0.24 for my public subnet, and then 12.0.2.0/24 will be my private subnet IP. So these are the CIDR IP ranges. So just read about the CIDR. So these are the CIDR range we will assign inside my VPC. So those are necessary because any instance which you will create inside those public subnet and private subnet will fall under those IP ranges. So that's a key thing which you need to keep in mind when you are working with this VPC and when you are trying to set up the public and the private subnet. Now talking about the next concept, which is an internet gateway, which you can see over here. So internet gateway, as the name suggests, it's a gateway for accessing the internet. So any resource which is present onto your public subnet will have an access to internet, although you can configure like which resource you want to provide an internet access or not. But in general, any resource which is present onto public subnet should have an access to internet gateway. And for that purpose, we just need to create an internet gateway into your AWS account, which needs to be associated with your public subnet, so that this any resource which will be created inside this public subnet. So here an example which I am taking is EC2, but if you create another EC2 instance, then that will also have an access to the internet. So that's the main reason which we need to create an internet gateway, and we need to associate that internet gateway with our public subnet. Alright, the next important thing which we need to know before we begin on to the demo side of this particular chapter, which is a route table. So route table is common, and these route tables, it's not common, but we need to create a route table for our public subnet as well as our private subnet. So these route table will be able to route the traffic or route the request between our internet gateway and into our public subnet as well as into our private subnet. So these are the key component which we need to set up for setting up our VPC or our virtual data center, so that we can place our resources inside those public as well as private subnet. Alright, so now we know what we need to do. So let's first start with our first block, which is our AWS account. So this is our AWS boundary. And if I go back to my AWS console over here, then you can see this is my AWS account. So that's our first building block. You need to have an AWS account. Secondly, we need to create a VPC. So this is our VPC boundary. So how to create a VPC? So go back to your AWS console over here, and in the search box, just type VPC, click on this VPC link. And here you will find quite a lot of options, but don't just get confused over here. So here you will find a create VPC button, and if you don't find that create VPC button, then here is a link for creating the VPC. So click on this VPC, and here you will find there is one VPC which is already existing. So these VPCs are created by default when you create your AWS account. But for this chapter, we are just not gonna use this default VPC, but we are just gonna create our own VPC. So here onto this AWS console or AWS UI, you will find this orange color or yellow color button for create VPC. So click on it. And here we need to enter the details about our VPC. So here I'm just gonna enter the details. So first thing which I'm just gonna put over here is test, let's say test VPC. Here we need to specify the IP range for my VPC. So for that, I'm just gonna copy my IP range from my notepad and put it over here. So this is the IP range which I'm just gonna assign, so which we also call it as a CIDR. And here we need to choose other options. So for tenancy, I'm just gonna keep it default. I just don't wanna use the tenancy. And after that, the tag we can check over here. So the tag name is this, and we are just gonna use the value which is test VPC. So that's the minimum thing which you need to provide for creating the VPC. Once you fill in those details, then just go here and click on create VPC. And here you can see our VPC has been created, and you can check again by clicking over here. And now you should see there are two VPCs. So click on this VPC, and here you can see this is the default VPC which has been provided, and this is the test VPC which we have just created. Moving further, the next resource which we need to create is the internet gateway, so that we can associate that internet gateway with the public subnet and private subnet. But first of all, let's go to our AWS console and create our internet gateway. So go back to your VPC or the AWS console, and here on the left hand side you will find an option to create an internet gateway, which is just below the route table. So click on this internet gateway over here, and here you will see that there is a one gateway which has already been created. So you don't need to use that internet gateway, or maybe I have just created in past, so that's why it is there. But I'm not going to use that internet gateway, but instead I'm just going to create a new one. So here click on this internet gateway button, and here you can just type I am just gonna put internet gateway. This is a short abbreviation for test. Yeah, that should be quite okay. Internet gateway test. Just click on create internet gateway and just go on to internet gateway and verify that you have created. So here you can see internet test has been created. Internet gateway test has been created. After creating the internet gateway, the key thing which you need to look over here is this internet gateway is not associated with your VPC, and how will you know? So here this is the internet test gateway which you can see, but here in the straight column you will find an option which is detached. That means this is an internet gateway which we have created, but it is not been attached with any VPC. So for that we need to attach this particular internet gateway. So for that, what I'm just going to do, I'm just going to click on this internet gateway ID which is present over here. So click on here, go to actions, and here you will find attached to VPC option at top. So click on it, and here you need to select the VPC. So as you know, we have just created our test VPC. So just click on this test VPC and click attach internet gateway. And here you can see our internet gateway is now attached with our VPC which we have just created, and which you can verify again. Just click on internet gateway, and here you can see this test internet gateway has been now attached. Now moving back to the slide, the next resources which we need to create after creating the internet gateway is the public subnet and the private subnet. So now we have the VPC, we have the internet gateway, and internet gateway is now attached with our VPC. But now we need to create our public subnet and the private subnet. So again, I'll go back to my AWS console, and I will just go into my VPC section, and here you just need to click on the VPC dashboard. And here we will find an option for subnet. So either you can click over here in this particular tiles, or you can on the left navigation you can also click on the subnet. So I'm just going to click on subnet, and here you will find the 3 subnet which already exist. So I'm just not going to use those 3 subnet. Those are the default subnet which has been assigned to you from AWS when you have signed up for AWS account. So here we just need to create our own subnet. So click on this create subnet button over here. And here you just need to select the VPC. Now you might get the feel of VPC here. So here if I go back to the slide, then here you will see now we are working inside the boundary of VPC. So any resource which we are going to create, we need to attach, or we need to create within that particular VPC, and which is going to be our virtual data center. So here I'm again just going to create this select the same VPC which I have created earlier. So here I'm just going to go over here, and I'm just going to select test VPC. And here we just need to enter the private subnet or public and private subnet details. So first of all, let's create the test public subnet, and I'm just going to put 1A. I'm just going to show you why I'm putting it 1A. So we need to put the availability zone. Since I'm in Europe, so that's why I have choose like a Europe Central region. But in case if you are present in any other part of the world, then just select the that particular region. And in that region, you will find a multiple availability region. And why we need to choose this availability region is because of high availability, so that you will not have many downtime, and you will have a maximum availability of resources from AWS side. So here I'm just going to choose Europe Central 1A. Here we need to specify the IP range, and again remember we need to specify the IP range of our VPC which we have created. So we have created 12.0.1.0 for our VPC, so we will work on that same IP range. So we are just going to assign 12.0.1.0/24. So I'm just going to copy this particular IP range, go back to my console and paste it over here. So this is going to be the public subnet IP range, or the CIDR block. Alright, so we have the tags, and the tag name is test public subnet 1A. That's fine. So now this is the first public subnet we have created. Let's add one more subnet, and now we are just going to create a private subnet. So here I'm just going to copy the name as it is, and I'm just going to rename it and make it as a public instead of public. I'm just going to put it as a private. Availability zone, I'm just going to choose 1A again, because we can create a multiple subnet over here. We can create a public and private subnet in one EU Central 1A, and then we can create another public and another private subnet inside EU Central 1B, which you can see over here, which is present over here. You can see 1B or 1C. So with that, what you will have a maximum availability. But for the demo purpose, I'm just going to create a one subnet, one which is public and one is private subnet. Okay, so now we have specified our private subnet also. I'm just going to specify the private subnet range. So I'm just going to put, let's say 3.0 over here. All right. So now in the tag section, you can see it has already created the tags for me. And after that, you can just verify all these details for VPC, public subnet, private subnet. And once you are satisfied with these details, just click on create subnet. And here you can see these are the subnets which has been created right now. So we will go again to the dashboard over here. And here, if you are like confused, like how to navigate between these options. So what you can do, the good option would be on the left hand side, you will find an option for a VPC. So here just select the test VPC, and all the resources which are present into this VPC will be visible over here. So just go to subnet, and here you can see the subnet which are created only into this test VPC. So now we have created the subnets. Now after creating our internet gateway, public subnet, private subnet, the next thing which we need to create is the route table. So here you can see this is the route table which we need to create, and we are just going to create a route table for our public subnet as well as for our private subnet. So let's go back to our AWS console, and here just click on this VPC dashboard, because all the options are available here into our VPC dashboard. So here on the left hand side, you can click on this route table. And here you will find a one default route table, but we are not going to use that default route table, but instead we are just going to create a new one. So click on this create route table, and here I'm just going to put the name. So first of all, I'm just going to choose an abbreviation RT for route table, and here I'm just going to put test public for our public subnet. Here again we need to choose the VPC. So the VPC is our test VPC, because all the resources we want to create inside the test VPC. So that's the reason. Okay, so here again just verify the tags. The key is name and the value is RT test public. So just click on create route table over here. Alright, so now our route table, public route table has been created, which we will be used for our public subnet. But creating a route table is not sufficient enough. We need to provide a route so that it can access the internet. For that, what we need to do, we just need to click on edit route. So remember, we are into this test public route, which will be associated with our public subnet, and public subnet needs an internet access. So for that, we need to create a route, and for that you just need to click on this edit route option over here, and here you will see this is the IP, which is our internal IP. So right now this route table doesn't have a internet access. For that we need to create a route. So click on this add route and just enter the IP, which is 0.0.0/0, which means it can be accessed over internet, and it has an access to internet. Alright, the next thing which we need to put is target. So target is like from where it's gonna get the internet. So for that we are just gonna choose the internet gateway which we have just created. So just click on internet gateway over here, and here you will find the internet gateway test which we have just created, which will be responsible for providing all the internet access. So I'm just gonna click on this one. So now you can see we have created a route table, and this was our default route which was internal, but now we have created a internet route with this IP address. Alright, so now that's been done. Just click on save changes, and here you can verify the routes once again. So this is our public route for internet access, and this is our private route. So this route table has an access to internet as well as internal access. Let's take a look onto the diagram once again and try to see what pieces are missing. So now we have the VPC, we have the internet gateway, and that internet gateway is now assigned to our route table over here. But one thing which you see over here, our route table is not associated with our public subnet yet. So we need to associate our route table with our public subnet. We have just created a route table and we have just associated with our internet gateway with routes. So what we need to do, just go back over here into our public route table, go to your subnet association. Into the subnet association, you will find an option for edit subnet association. So click on edit subnet association and here you will find the subnets. So we have created one public subnet and one private subnet. But since we just want this route table to be associated with our public subnet so that it has an internet access. So I'm just going to select only one subnet over here, which is our public subnet. Click on save association. And now you can see we have our public subnet which is associated with this particular route table. Now we have just finished our public route table. The next route table which we need to create is for our private subnet. So here in the diagram, so here you will see, although I have just mentioned the route table, I have not specified whether it's a public or private, but we need to have a two route table. So one route table for public subnet, which we have already created. Now we are just going to create for a private subnet. So go back to your AWS console, click on this route table, and here you can see we have already have a public route table. Just click on create route table for creating our private. So I'm just going to paste the name and change the name to the private. Again, we need to select the VPC under which VPC we want to create. So here I'm just going to select test VPC, and then I'm just going to click on create route table. And here you can see our route table has been created. The next thing which we need to do, we need to create a subnet association. Remember, this is our private subnet. This is our private route table which will be associated with our private subnet. So we don't need to provide an internet route, which we have done previously for our public route table. But this is going to be a private route table with private subnet and it doesn't need an internet access. So we are just not going to create any routes over here. We will directly jump to the subnet association, click on subnet. Click on edit subnet association, and here I'm just going to choose only the private subnet this time. Click on save association, and here you can see our subnet is associated, our private subnet is associated with our route table test private. So that's how you're just going to create a route table, and then you're just going to associate the private subnet with our route table. Okay, so now our basic skeleton networking setup is ready, and the next thing what we need to do over here, we just need to create a resource inside our public subnet. So here you can see we are just gonna create an EC2 instance into our public subnet, and we are just gonna SSH from my local machine into my EC2 instance. So that's gonna be the next step which we are gonna perform. And for that, what we need to do, we just need to go back to our AWS console over here. Go to AWS homepage because we are done with our VPC setup and all the networking setup which is needed. So here we need to click on the EC2, or you can just go to search box and type EC2 over here. Click on EC2, and here you can see this is our EC2 dashboard, and here you can see no instances are running. So click on this instances, and here you can see nothing is running. So either you can create a instance or EC2 instance from here, or either you can go back and click on launch instance. So I'll just gonna go over here and click on launch instance over here. So here you first of all need to put the name or assign the name for your EC2 instance. So I'm just gonna put test EC2 public subnet instance. So that's just a name I'm just gonna put for this particular demo. I'm just gonna choose Ubuntu. I'm just gonna stick with my free tier because I'm doing it for the demo purpose. So I'm just not gonna use some higher or more powerful CPU. Okay, so I'm just gonna keep the things default over here, 64-bit, that's okay. T2.micro because I'm just gonna stick with a lower bare minimum CPU. The key pair. So here I have already created the public key and the private key, and if you don't know like how to create a public key and the private key, then just check my previous chapter where I have explained like how to create your public key and the private key, which will be used for your EC2 instance. So that's a key thing which you need to keep in mind. And in case if you haven't created the public key and private key, then you can just simply click on this create a new key pair, and that will create a public key as well as the private key. So I'm just going to show you briefly over here. So if you click on create new pair, so here you will put, for example, test key pair, and then just click create key pair. And once you click on this, then it will just download you the private key, that test key pair.pam. This is the private key which will be downloaded onto your local system, so that you need to keep it with you. And the public key is already being created over here. So here you can see test key pair. So this public key has already been created, and that is present onto your AWS console. So that's how you're just gonna create the public key and private key. So since I have already created and I already have a copy of that key with me, so I'm just gonna use this AWS EC2 Terraform pub. This is the public key which I generally use. But in case if you're creating a new key, then just select that one. That's absolutely okay. So just in case, that's the only change you will see over here. So here I'm using my own key, but in case you are creating a first time, then just use that particular key, which is test key pair, and which might be different for you. So I'm just going to select this one, go further, and here you will find the network settings. So here you need to pay careful attention, because all the networking setup which we have done previously, we need to use it over here. So click on edit over here. So here you need to choose the VPC. So this is not the VPC we have created. We have created a test VPC. I'm just going to select that one. Here we need to choose the subnet. So I'm just going to choose the public subnet, because here if you take a look onto the slide, so we are just creating EC2 into our public subnet. So I'm just going to select public subnet over here. Go again further, and then auto assign the public IP. Since this EC2 instance is going to be available publicly, so that we can access or we can SSH into this particular instance, so we need to assign a public IP. So we need to enable this option so that we get a public IP. All right. So here the next thing is the create security group. That's one more important thing. So I'm just gonna name the security group test EC2. I'm just going to put test EC2 security group, and in this security group, I'm just going to keep the same into description. That should be okay. So here we need to put more attention onto the SSH part, because we want to SSH into this EC2 instance using the public IP. So for that, we need to enable the type SSH port 22, and source type can be accessed from anywhere. So I'm just keeping it anywhere so that I can access, or anyone with the IP and the private key can access this particular EC2 instance. All right. So now we have done the security group also. Then next we are just going to check. I'm just not going to check any advanced networking configuration. We are just going to skip that part, which is not needed at this point. Configuration storage, so I'm just going to go with the 8 GB of memory, 8 GB of our disk space over here. After that, into advanced detail, I'm just not going to choose anything over here. We don't want spot instances right now. And once we are done with these many options which we have filled in already, then we can just go ahead and click on launch instance. So I'm just going to click on launch instances, and I'm just going to click on this this is the instance ID which generally generated from the AWS. So click on it, and here you can see the state is in pending. So you just need to refresh it, and it will be in a running state. And here you can see the instance is now into our running state. Alright, so now we have created our whole VPC with our public subnet, private subnet, internet gateway, route table, and also we have started an EC2 instance onto our public subnet. The next thing which we need to do is we need to SSH into our EC2 instance. So this is the EC2 instance which is running. So just click on this instance ID so that we can see the details. So here we need to pay careful attention onto some of the IP addresses. So we will be mostly interested into this public IP which is generated by AWS. So I'm just going to copy this public IP address, and here you will find all other detail like the host name, the private IP, the public IP for DNS, elastic IP if you have created any elastic IP, the instance type. So all those details are available over here. So in the networking also you can see the details associated with our EC2 instance, which is a subnet and your VPC. So all those details you can see over here. But let's copy the public IP address from here, and we just wanted to SSH from my local laptop. So in case if you are using Windows, then you can use put putty, and since I'm using Mac, so I have a terminal over here, so which is just similar to the putty. So here I need to first of all check onto my private key. So I'm just going to run the ls and lart commands to see my private key. So my private key is AWS EC2 Terraform. This is the private key which I have already created. And while I was creating an EC2 instance, I showed you that there is a test key pair which I have created. So in case you are creating the keys for the first time, then this is the key which you need to use, test key pair.pam. So that will be your private key for this SSH utility. All right. Now we have copied the public IP address. We have our terminal ready. We already have our private key which is present over here onto the same directory. So I'm just going to clear this terminal. But how to SSH into this EC2 instance? So what you need to do, you just need to go to connect over here, go to SSH client, and here you will find the instructions. So locate your private key, which is this one, which we have already located. In this case, this name will differ because you might have created some different key with different name. Then we need to change the permission of that particular key, which is 400, because whenever you create a key, then you will have a very bigger permission or very broad permission. So what you need to do, you just need to run the command. I'm just going to copy this command, chmod 400, and the key name, which is this one. This is my private key, but in case you will have a .pam also, that's absolutely fine. That's not a problem. So just hit enter. After that, you just need to follow the next instruction to SSH into your Ubuntu or your Linux machine. So here, this is the command, just copy, paste it over here, but you need to modify this particular command. So here, I'm just going to change. I'm not using the PEM file, but I'm just using a simple private file without any extension. And then you need to remove all this part. So in case if you are having a PAM file, then just put .pam extension at the end. Otherwise, it's just okay. So here, this is the command which you need to create to SSH into your EC2 instance. And once you have created this command, just simply hit enter. Are you sure you want to connect? Type yes. And here you can see, now we have entered into our Linux machine. And here you can see, this is the IP address, which is 12.0.1.27. So that's the IP which we have got. And this IP belongs to our public subnet, and which I can show you from our slide. Here you can see 12.0.1.0.24. So this is the IP range we have assigned, and what we have got the IP address, that is 1.27. So that's belong to our public subnet. And also you can verify the details. So that's the usage, like the disk, and this is our Ubuntu, which is running on a 22.04. So that's how you are just gonna create an EC2 instance, and you're just gonna set up your whole VPC with public subnet, private subnet, and then you can access that EC2 instance from your local machine. So that was the session which I have planned for today. And once you are done with this whole setup, and if you're doing it for the demo purpose, then what I would recommend is just to clean up all these resources. Otherwise, it might incur some cost to you. So for that, what you need to do is you just need to exit from here, go back to your EC2, click on to the instances, select the instance, go to instance state, then click on terminate instance. If you are just using it for learning purpose, then I would recommend you to terminate the instance once you have done the setup, because it will start costing a little bit of money if you don't stop or don't terminate your EC2 instance. So I'll be back shortly once this instance is completely terminated. Alright, so here you can see our instance has been terminated. So now we need to clean up all the route table, our public subnet, private subnet, and our internet gateway along with our VPC. So go over here into AWS, click on VPC over here, select VPC. Then what we need to do over here, we just need to go to the route tables first, select our private route table, go to action, select delete. And you will find an error message over here. Route table is still associated and cannot be deleted. So what you need to do, you just need to cancel this one. Click on this subnet, edit subnet association, deselect this one, save association. So now we have we have unregistered our private subnet with this particular route table. And now again go back to actions, click on delete, and now you can delete this route table. Click on delete. So now we have deleted our private route table. Just refresh it once again, and that is gone. Then go to public, go to subnet association, edit association, uncheck that one, save association, go to action, go to delete, and type delete over here. Refresh it and your route table is gone. So now we have deleted our route table. The next thing which we need to delete is public subnet and the private subnet. So click on this subnets, go to private subnet, click on action, click on delete, and here you can just type delete, refresh it, and your private subnet is gone. Just click on public subnet, click on action, click on delete, type delete over here. Alright, refresh the page, and now our subnets has been deleted. The next thing which we need to delete after that is internet gateway. So go on internet gateway, click on this internet gateway, and this internet gateway is still attached with our VPC. So let's check that one. So internet gateway is there. Go to action, detach from VPC, because that's necessary before you delete your internet gateway. So I'm just click on detach, go to action, click on delete, type delete over here, and now we have deleted our internet gateway. Refresh this one, and you can see this is our default gateway which we have got when we signed up for AWS. So now our internet gateway has been deleted. Now we finally need to delete our VPC. So click on this, your VPC. This is our test VPC. Select this test VPC, go to action and delete VPC. Type delete over here, and that has been deleted. So that's how we have set up our whole networking. We have tested our EC2 instance, and finally we have cleaned up our whole demo. Today we are going to set up the NAT gateway for our private subnet. But why we need a NAT gateway? So here is the setup where we are having a VPC with public subnet and private subnet. So any resource present inside the private subnet will not be able to download any new package, or neither it will be able to download any new updates. So to solve this issue, AWS provides a NAT gateway. With the help of NAT gateway, EC2 instance can communicate with the internet, and it can download certain packages and updates which is needed for EC2 instance. But other way around, where a user trying to access a NAT gateway to access a EC2 instance present into private subnet is not possible. So NAT gateway is always a one-way route where an EC2 instance or any resource present into the private subnet can go out and access the other resources. Let's start with the demo, and let's go step by step, and let's start with the first thing, which is the VPC. Here is my AWS console. In the search, type VPC. Click on VPC over here, and here you can click on create VPC and select the VPC only. Type the name of the VPC. So here I'm just going to put test VPC. CIDR range, I'm just going to put 12.0.0.0/16. Tenancy, I'm just going to stick with default. Tags, I'm just going to keep the default one, and click on create VPC. And here you can see our VPC has been created, which is our test VPC. Let's move ahead, and the next resource which we need to create is the subnet. Now we are going to create a public subnet and the private subnet. So let's go back to our AWS console, and in the left navigation menu you will find the option for a subnet. Click on it, and these are the default subnet, but we are not going to use those. Click on create subnet, select the VPC, which is the test VPC which we have created, and here we are going to enter the name of our subnet. So I'm just going to put test subnet. I'm just going to put public. First of all, I'm just going to create a public subnet and 1A. So 1A is the availability region. So here you can see I'm just creating it into Europe Central 1A. That's why I have suffixed it with the 1A. IP range, I'm just going to put 12.0.0, and I'm just going to put 10/24. So that we will have 256 IPs. So I'm just going to copy this IP address. I'm just going to need it for a private subnet also. So click on add one more, and here I'm just going to put test subnet private, and here I'm just going to put 1A. Availability zone, I'm just going to select 1A over here, and here I'm just going to paste it, but here I'm just going to change it to 2, so that we have the differentiation between the public subnet and the private subnet. And after that, I'm just going to verify the details. So here you can see test subnet public, test subnet private, and then click on create subnet. And here we have both the subnets ready. Let's move ahead, and the next resource which we need to create is the internet gateway, and this internet gateway we are going to attach it with the public subnet so that any resource present inside the public subnet can access the internet, as well as any resource outside of this whole AWS and VPC will be able to access the resource present inside our public subnet. So let's go back to our AWS console and create internet gateway. So here in the left navigation menu, you will find an option for an internet gateway. So click on it, and here this is the default. We are not going to use that one. Click on create new internet gateway. So I'm just going to create test pub internet gateway. So this is the abbreviation I'm just using, IGW for internet gateway. Click on create internet gateway and just go there, and here you can see test internet gateway has been created. Now we need to attach it to our VPC first of all. So I'm just going to go into action, click on attach VPC and select the VPC which is test VPC, and click on attach internet gateway. Alright, so if you take a look onto the diagram once again over here, so we have created the VPC, we have created the internet gateway within the VPC, but we have not still attached with our subnet. So what I'm just going to do, I'm just going to create a route table so that we can attach this internet gateway to our subnet. And we are going to create a two route table. So here you can see in the diagram, in the public subnet, we are just going to create a one route table for public subnet, as well as we are going to create a one more route table for our private subnet. So let's go back to our AWS console, and in the left navigation menu, you will find an option for a route table. So click on here, these are the default, we are not going to use one. So I'm just going to click on create route table. So I'm just going to choose the first route table. So I'm just going to use test route table, that is RT for route table. And here I'm just going to put public. Then I need to select the VPC. We have only one VPC, that is test VPC. So I'm just going to select that one and click on create route table. Okay, so now my route table has been created, but this route table is still not public. We need to attach internet gateway to that. So click on edit routes over here and click on add routes, and here you need to enter the IP address range. So this is the 000, which means it will have access to the internet from anywhere. So this is the meaning of this IP address, and here we need to choose the internet gateway so that it can access the internet. So this is the internet gateway I'm attaching, and click on save. So now our route table has been updated with the internet gateway, but still we need to attach the subnet also. So for that, go to the subnet association, click on edit subnet, and here we need to choose the public subnet and click on save association. So now our public route table is ready. So here you can see this route table, and in the route table we have internet gateway for getting the internet access, and now we have also attached the public subnet to it. Let's go back to our diagram once again. So here, this part is done, and now we are into the private subnet. So we are going to create a one more table, but in this route table, we are not attach internet gateway because this is a private subnet and private route table. So go back to your console. In the route tables, click on create route table, and here I'm just going to type test RT for route table, and I'm just going to put private. And the VPC, we are working inside a single test VPC. So I'm just going to select that one, click on create route table. And here, after creating the route table, which is a private route table, we need to click on subnet association. Go to actions over here, click on edit subnet association. And here we are going to select the private subnet and click on save association. And remember, in here we have the private subnet associated with this private route table, but in the routes, we are not changing anything. We are not attaching any internet gateway. So now both the route tables are ready. So our public as well as private. Moving ahead in the setup, the next resource which we need to create is the NAT gateway. And this NAT gateway will be associated with our public subnet with the internet gateway, because internet gateway is only available inside our public subnet. And NAT gateway will provide a route to the private subnet to get an internet access. So that's the reason we attach this NAT gateway along with our public subnet. So let's go back to our AWS console. In the left navigation menu, you will find an option for a NAT gateway. So click on NAT gateway. And here you can see there is no NAT gateway I have created. So click on create NAT gateway. And here put the name. So I'm just going to put test NAT gateway. And here we need to select the subnet. Now here you need to think like which subnet has a internet access. So here if you take a look onto the diagram, so it's only the public subnet with internet gateway. We already created the internet gateway with our public subnet. So this public subnet we need to attach. So here in the drop down, just go the subnet and select the public subnet, which is this one, test subnet public. So click on it. And here the connectivity type. So there are two types of connectivity, which is the public and one is the private. So what's the difference between the public and the private? So let's say if you have chosen the public connectivity for your NAT gateway. So what will happen? So here is an example I am taking. So this is an AWS account in which you have a multiple VPCs. So let's assume this EC2 instance present into this private subnet have a public connectivity, which means this private subnet can make a request for internet, which is I'm just putting an icon for internet over here in the blue color. So this EC2 instance with the public connectivity type can access the internet for downloading the certain packages and software update. But in case if you choose the connectivity type to be private, then what will happen? So here in the diagram, so this particular EC2 instance present inside this private subnet will not be able to access this internet. It will only be able to access the other VPCs present inside this particular AWS account. So it can go out of the VPC, but it will not go and access the internet. It will just reside within this particular AWS account. And if you have a multiple VPCs, then it can be able to communicate with those VPCs. So that's the basic difference between the connectivity type when you create a NAT gateway. Anyway, now you know the difference, but here in this demo, we are going to select the public because we want to curl the Google page when we are testing this particular whole setup from our private subnet EC2 instance. Or we are just going to download certain packages to perform our demo and validate our theory. Alright, so the next thing which we need to do is we need to create an elastic IP for our NAT gateway. And this elastic IP, you can either create it from here also, or you can have a pre-existing elastic IP. So here I have not created any elastic IP, so I'm just going to click on allocate elastic IP. And here you can see this, it has created an elastic IP for me. So I'm just going to choose that particular elastic IP. So here in the drop down, you can see it has already selected that elastic IP. So I have selected this elastic IP, and in the tag section, I'm just not going to change anything, and I'll just click on create NAT gateway. And here you can see the state is pending. So it might take a couple of minutes for this NAT gateway to get ready. After a couple of minutes, my NAT gateway is ready and the state is available. Okay, so let's get back to our diagram once again. So now we have created the NAT gateway, but after creating the NAT gateway, you also need to update the route table of our private subnet. We only created the route table and associated with our private subnet. So I can show you that. So go back to your AWS console, go to the route table and click on this private route table. So here, and this is the default route for our private subnet, and in the association, you can check this is our private subnet. But now, since we have created our route NAT gateway, so here you can see this is the NAT gateway we have created, but this subnet is not aware about it. So we need to update this route table and we need to attach this NAT gateway to this route table so that this private subnet knows that I have the NAT gateway with me. So go to your AWS console over here, click on this private route table, which we have already selected, click on edit route. And here click on add routes. So that destination is internet. So this is the IP address for internet, and how I will reach to that internet via the internet NAT gateway. So here select the NAT gateway, and here you will find the NAT gateway which we have just created. So click on NAT gateway and click on save changes. Okay, so here you can see the difference. So this is our private route table, and here we have the NAT gateway inside our route. And if I can show you my public route table also, so if I go to public, and here you will find the internet gateway, that is IGW, which is our internet gateway. So that's the basic difference between our route table, which is present inside our public and the private subnet. Now moving ahead, the next resources which we are going to create is the EC2 instances. So now we are going to create a EC2 instances into public subnet as well as into our private subnet. So go back to your home page of your AWS console over here. I'll close other tabs over here. Click either you can search over here the EC2, click on this EC2 and click on launch instances. Here put the name. So I'm just going to put test EC2. And I'm just going to put it public because I'm just going to create into my public subnet. Here I'm just going to choose Ubuntu, and I'm just going to stick with t2.micro as my instance type. Key pair, I'm just going to create a key pair, and I'm just going to use the same key for my private EC2 the EC2 instance present into my private subnet, which we are going to create soon. So I'm just going to use the same key for that one also. So I will choose the name of the key, that is NAT Gateway Demo Key, and then click on create key pair. And here you can see it has downloaded me the private key and the public keys associated with our EC2 instance, which we are just creating. Network settings, just go there, edit, and here first of all we need to choose the VPC. So we have created a test VPC, so select that one. Subnet, we are just gonna select public subnet because we want to create this EC2 instance into our public subnet. So select that one. Public IP assigned, so enable that one so that we get a public IP for our EC2 instance. Then security group, so by default it has a SSH 22 security group already enabled. I need to enable one more security group, and that will be HTTP request and port 80, and I'm just going to select it anywhere so that I can make a HTTP request for this EC2 instance. All right. Memory capacity, I'm just going to stick with 8 gigs of memory. And in the advanced detail, I'm just going to install one small package, although it's not necessary, but just for demo purpose, I'm just going to install the Apache 2 as a part of a user data script. So what will happen when I'll boot this EC2 instance, or I'll start this EC2 instance, then it will update the package, it will install the Apache, and it will update the index.html page where I'm just going to printing the host name, and then after it's just going to restart the Apache. So that's simple. Click on launch instance, and it will take a few minutes to start the public EC2 instance present into the public subnet. Meanwhile, we can again go to EC2 dashboard, and it will take some time to reflect it over here. Meanwhile, we can set up another EC2 instance present into our private subnet. So again, click on launch instances, and here choose test EC2, and here I'm just going to suffix it with the private. And I'm just going to again choose Ubuntu as my base operating system, and T2.micro again I'm just going to choose, and here from the drop down I'm just going to select the key, that is NAT Gateway Demo Key. I'm just going to stick with the same key which we have just created in the previous step. Then click on edit network settings, select the test VPC, and the subnet I'm just going to select, it is already selected the private subnet, so that's okay. Public IP, we don't need to assign public IP because this is our EC2 instance present into our private subnet, so it should not have a public IP. And the security group rules, I'm just going to enable the SSH, as well as I'm just going to add one more security group, and that is going to be from anywhere, and the type should be HTTP and port 80. Okay. And in the advanced, I'm just going to install the Apache here as well, and then click on launch instances. And I'll be back once both of my instances are up and running. Here you can see my both instances are running. So let's verify those instances. So I will just start with the public instance because where we have installed our Apache, and it should be accessible via public IP. So click on this instance ID, copy this address, go to the new tab and enter over here. And here you can see my home page of Apache is up and running. So I will zoom in over here. So this is the private IP of my public EC2 instance. Let's take a look onto the request flow once again. So here we have already created both the EC2 instance, and now we have just accessed the home page of my public EC2 instance. So now what we are going to do, we are just going to first SSH or log in into my public EC2 instance using the private key which we have just created for this EC2 instance. And once we are logged in into that EC2 instance, then from there we are going to log in into our private EC2 instance present into my private subnet, because this EC2 instance we cannot access directly from anywhere or from my local laptop. I just first need to go into my public EC2 instance, and from there I need to access the private EC2 instance present into the private subnet. Let's go back to AWS console and check the instructions. So this is my AWS console. I'm just going to close this tab and go to our EC2 dashboard, click on instances running, go to our public instance, click on connect, and here you will find the instructions. So first thing we need to do is we need to change the permission of the key. So copy this command, go to your terminal, So here I have opened the two terminals. So first let's work on to our public EC2 instance SSH. So let's check the key. So here you can see this is the key, but I need to change the permission. Right now this has a read and write permission, which you can see over here. So I need to change it. So I will use chmod 400 command to make it as a read only. And now I have changed it. So let's verify it once again. And here you can see now it's only read only. I'll clear it. The next command which we need to do is we need to SSH. So copy this command from here and go to your terminal and paste that command. And it will ask, are you sure want to connect? Type yes. And now we are into our public subnet EC2 instance. So clear it. Alright, so next thing which we need to do is we need to access our private EC2 instance running into private subnet. So for that we need the private SSH key, which we need to copy to our public EC2 instance. So here on the right terminal you can see this is my local terminal. I'm not logged into any EC2 instance. So let's run the ls command, and here you can see the key. So what I'll do, I'll just run a cat command over here to copy the content of this particular key. So from here I will just copy this key, and on the left navigation menu this is my EC2 instance into public subnet. So here I'm just gonna create a file, and then I'm just gonna open into the VI mode and then paste the content, and then after that I'm just gonna save and quit. Let's check the permission of this file. And it also has a read write permission, so I just need to change that one. I'll just clear the screen. So I'm just gonna make it chmod 400, and then I'm just gonna choose NAT Gateway. So now I made that permission, or the permission of that particular SSH key as a read only. So again verify it. So here you can see the permission has been changed. So now we will SSH into our private subnet. So to do that, I'll just close this terminal over here because it's confusing. So right now I am into my public EC2 instance and I have the key with me. So what I'll do, I'll just go to my EC2 dashboard and go to click on instances, click on private instance, click on connect, and here you will find the instruction to connect to your private instance. So copy this command, and here you can see this is the private IP address. So this is not a public IP address. So I can show you. I'll open this instance into new tab. So here you can see this is our EC2 private instance and there is no public IP address. That's why I was not able to access it outside of my public EC2 instance. So that's why I SSH'd into first my public EC2 instance, and now I will use the private IP to connect to my private EC2 instance. Alright, so copy this command from here, go to your terminal, and I'll clear it and paste it over here. And here you can see now we are SSH'd or we are logged into our private EC2 instance. So I'm just going to clear this screen over here. Also, you can verify the IP address. Here you can see this is the abbreviation or the name, which you can see over here, 12/0/2/98, and this is the private IP address of my private EC2 instance. So if you go to the details over here, so here you can see the details. So this is just an identification check to verify your private EC2 instance. Alright, so next thing what I'll do, I'll just try to curl the Google page. So let's do curl www.google.com, and here you can see the output, although it's just a random code which is being presented over here, but I'll just clear the screen. The next thing which I can do is www. and ping the google.com. And here you can see the request is going through, which means now our private EC2 instance is able to access the internet and with the NAT gateway. We'll do few more testing. So what I'll do, I'll just try to remove the route entry from our private route table so that we can verify once we remove that particular route, then we should not be able to ping the google.com or ping any URL. So let's go to our homepage of AWS console and type VPC over here, go to VPC. And here into the route tables, select the private route table and edit this route and remove this NAT gateway, because now we just don't want the NAT gateway. We are just doing the demo and we're just testing the other scenario as well. So I will just remove it and click on save changes. So now my route table has been updated. So let's go back to our EC2 instance, which is a private EC2 instance, and again run the same command. I'll just ping the google.com, and here you can see Now my request is not going through at all, which means now we have removed the route for our NAT gateway. Although NAT gateway is there, but there is no route which allowing our EC2 instance to go through that particular request. So this is how our NAT gateway works, and with the help of NAT gateway you should be able to provide internet access to your EC2 instance or any resource running or present inside your private subnet. One additional thing before we conclude, I also have a YouTube membership program for my YouTube members. So if you are a member of that particular group, then you will also get an access to some premium content where I'm using Terraform to provision all those things, and also some behind the scenes and some more raw sessions where I try to experiment with some projects. So I will be uploading those sessions, but that will only be for my YouTube member. So if you like the similar content which I have already uploaded onto my channel, and if you want to learn more onto the DevOps and cloud, then consider being a member to that particular YouTube membership program. Before we jump into the details of our Bastion host, it's really important for you to understand the concept of our Bastion host. And for that, I have taken a very simplistic example which is really easy to understand. So here onto the screen, you can see the three objects. On the top right corner, you will see a castle. In the middle, you will see a tunnel, which is like an entrance for this particular castle. And on the left hand side, you will see an intruder or a trespasser. The idea over here is anyone who wants to access to this particular castle has to go through this particular tunnel. And this is not an ordinary tunnel. This is a heavily guarded tunnel with an armory. So anyone with a valid access to this particular castle will not have a problem. But anyone who is an intruder or who doesn't have a valid access to this particular tunnel, a necessary action will be taken against him. And he will be prohibited from entering into this particular castle. Now you might be wondering that how it makes sense when we are talking about AWS and I'm talking about this tunnel and this castle. So here this particular tunnel is heavily guarded, and this is a tunnel for doing all the security checks for us. So same thing applies for the Bastion host also. So in AWS context, we will be calling this tunnel as our Bastion host, where everyone who wants to access our AWS network or AWS resources has to go through this particular tunnel. And this particular castle on the right hand side will be our AWS environment where our resources will be running. Compare our castle example with this AWS setup which I'm showing to you right now. So here on the left hand side, you will see a user which has access to internet gateway so that he can access our AWS network. But here we are having public subnet and the private subnet. So whenever we talk about the Bastion host, then Bastion host is always available into the public subnet so that any user can access that Bastion host. And if that user has a proper access, then he eventually will be able to access the resources into our private subnet. So if we compare these both example, which is our castle example and this AWS setup, then here you will see the tunnel will sit over here into the public subnet where it will be safeguarded and any access will be screened over here. And this EC2 will be the area where our castle will sit in. So here any user who is coming to our AWS network has to go through our Bastion host, and if the access has been granted to that particular user, then he will or she will be able to access our resources into our private subnet. And the private subnet, I mean the castle, which the example I have shown you previously. We know the concept of a Bastion host, so let's jump onto our AWS console and start setting up this whole environment so that we can see how the Bastion host work in actual AWS environment. So let's start with our demo, and here onto the screen you can see this is my AWS console. So let's jump back to our slide and start with our first element which is needed for this whole setup. So here onto the screen, you can see this is the architecture, or this is the desired environment which we want to implement. So here the first block which you will see is the AWS boundary. But this AWS boundary means you need to have an AWS account. So here onto the screen, you can see I have an AWS console, so which means I have a proper AWS account. So let's take a look again onto this diagram. So the second boundary which I see over here is the VPC. So we need to create a VPC. So VPC is a virtual private cloud. So it's actually a physical data center if you compare with our physical world scenario. So VPC is just like a virtual physical data center for us, so that any resource which we create will be residing inside our VPC. So let's go back to our AWS console over here, and in the search bar type VPC, click on this VPC, and here you will find an option to create an VPC. So click on create VPC. So here you need to click on VPC only. There are one more option, VPC and more, but we are gonna stick with our very basic option, which is VPC only. So here you need to enter the name. So I'm just gonna put test VPC. Here you need to enter the IP range, because any resource which you want to create inside the VPC need to have the IP addresses. So for that, we are just going to define the IP ranges. We are not going to define a single IP. We are defining a IP ranges so that any resource which you create inside the VPC will get the IP address out of that particular range. So here I'm just gonna, for this demo, gonna keep this IP ranges, which is 12.0.0.0/16. So this is a CIDR block which you need to pay careful attention when you are creating an VPC. Alright, so now we have entered the VPC name, IP ranges we have assigned. So here, this is the tags which it has generated automatically, which is name and the value. So I'm just gonna stick with that, and I'm just gonna click on create VPC. Alright, so here, just go back to the VPC link over here, and here you can see there are two VPCs. So click on it, and here you can see I'm just going to refresh it. So here you can see this is a test VPC which I have created, and this is the default VPC which you generally get. So I'm not going to use any default VPC, but I'm just going to stick with my own VPC which I have just created. So now we have created our VPC. The next item which we need to create from this diagram is to create an internet gateway so that any user can access our AWS network with the internet gateway. So again, go to AWS console over here. In the search bar, you can either type VPC, because we have the internet gateway option available inside our VPC. So here you will either find from the left hand side, here you will see internet gateway option, or either you can see this internet gateway tile, which is a rectangular tiles which is present onto our VPC dashboard. So I'm just going to click on this internet gateway, and here you can see this is a default gateway which has been created previously, but we are not going to use that one. I'm just going to click on create internet gateway, and here I'm just going to type IGW for internet gateway abbreviation, and I'm just going to type test over here, and that's it. And then just simply click on create internet gateway, and we can verify it. Just go over here, and here you can see this is our test internet gateway which I have just created. The next thing which we need to do over here is this internet gateway is not attached with our VPC. So if you go back to our diagram over here, then you can see this VPC and this internet gateway has to be attached. So what I'll do, I'll just click on this internet gateway ID over here, click on action, go to attach VPC, and here you can see the option of a test VPC which we have just created. So select this VPC, attach internet gateway, and that's how we create our VPC and we attach our internet gateway. So now after creating the internet gateway, the next item which we need to create from the diagram is to create our public subnet as well as our private subnet. So these are the two elements which we are going to create. So again, go back to our AWS console, and you can click on this VPC dashboard over here, and here you will find an option for a subnet. So click on it. And here you will find some default subnet which has been already created by AWS for you, but we are not going to use those one. We are just going to create two subnets. One is public and one is private subnet. So click on this create subnet, and here you can type, or here you need to select the VPC, because if you take a look onto this particular diagram, then everything happening inside the VPC. So these subnets also exist inside our VPC. So here, first of all, you need to select the VPC. So we will gonna select this test VPC because that's the one which we have created. So select this one, and here we need to enter the name of our subnet. So what I'm just gonna do, I'm just gonna put the name of my subnet. So here I'm just gonna put test public subnet. And here I'm just going to put 1A. I'm just going to show you why I'm putting 1A. So here you need to select the availability zone. So since I'm based in Europe, so that's why I'm just going to choose the nearest region. So I'm just going to choose Central 1A. That's why I have chosen a 1A, so that I know like in which region my subnet exists. So that's the one thing which you need to keep in mind. Otherwise, it's not a problem. If you just keep a test public subnet, that's also up to you. That's absolutely fine. The next thing which we need to do over here is we need to specify the IP range for that particular subnet. So if you create an EC2 instance inside that particular subnet, then it will get the IP address from that particular range. So that's a key thing over here. Okay, so I'm just going to put the IP address, so 12.0.1.0, which is similar in the range of our VPC. In the VPC, we have defined a 12.0.0.0. So here I have chosen the value which is 12.0.1 for this particular public subnet. Okay, So here we have created our public subnet. Then we are going to do one more thing. We are just going to create the private subnet at the same time. So click on add subnet over here, and I'm just going to copy this name. I'm just being a little lazy over here, so I'm just going to put it as a private availability zone. I'm just going to select 1A, and here I just need to specify the IP address. Sorry, I will just remove this one. I'll just copy the IP address from here, but here this time I need to select a different IP range for this private subnet. So I'm just going to paste it, and I'm just going to choose, let's say, 3 over here. Okay, and then the tags, I'm just going to stick with the default one, and after that I'm just going to verify the details. So here we have the VPC. Inside that VPC we have a public subnet, we have the IP range for that one, and we have a private subnet with the IP range and the tags also created. So just click on create subnet over here, and here you can see our subnets has been created. So let's take a look onto the diagram which we are trying to achieve over here into our AWS environment. So here you can see we have created VPC, we have created internet gateway, public subnet, and private subnet. The one thing which I forgot to tell you in the initial example is the route table. So we need to have a route table so that our request which is coming from our internet gateway can be routed to our public subnet as well as to our private subnet. So for that we need to create a route table also. So for that what we need to do, we just need to go back to our AWS console, click on this VPC dashboard, and here there is an option for a route table. So click on route tables and then click on create route table. But before that, you can see there are some default route table which has already been created. So you just don't need to use those default route table. I'm just gonna close this successful messages. So I'm just gonna click on create route table over here. And here you need to enter the name of your route table. So I'm just going to copy that name which I have already pasted into my notepad. So this is the name of my route table, and this route table is for public subnet. So that's why I'm adding the keyword public over here so that we can use this route table only for our public subnet. Alright, next thing, again we need to choose the VPC, which is our test VPC, because as you can see into the diagram, everything we are doing inside our VPC. So that's why I'm choosing the VPC every time whenever I'm creating any new resource. Alright, so that's been done, and the tags I'm just gonna keep as it is, the default one which has already been created, that is test public RT for route table. Click on create route table. And here you can see our route table has been created, but this route table has not been associated with our public subnet. So if you take a look onto this diagram, then if you create a route table, which you can see in the middle, has to be associated with the subnet. Since this route table is only for public subnet, so I'm just gonna associate with our public subnet. So again, go back to AWS console over here, click on this subnet association, and remember I'm inside my route table. So if you are confused, then again go back to route tables. This is my route table which I have created, test public RT, click on this ID, then go to subnet association, click on edit subnet association, and here I'm just gonna associate the public subnet and then save association. So here you can see our public route table has been associated with our public subnet. Important thing over here in the route table is whenever you're working with the public route table which is associated with a public subnet, then you need to provide an internet access. Right now you have just defined the routes, and we have just defined the route table and we have associated with our public subnet, but we have not provided an internet access to that particular route table and internet gateway. So what I'm just going to do, I'm just going to define a route so that we can access the internet, or that particular subnet can have an access to internet. So for that, what you need to do, you just need to click on routes over here. Again, I'm just going to start from the first step. So here, these are the route tables. Here, this is my route table. I'm just going to click on this route table ID, and here you will find an option to routes. Subnet we have already associated with our public subnet, so we don't need to do anything. Click on this routes, click on edit routes, and here you need to select add routes. So here you need to enter the IP address. So for providing the internet address, internet access, you need to choose the IP address which is 0.0.0.0. So which means anyone can access this particular route table, or at least this internet gateway, and this route table has an internet access. Next thing is the target. In the target, you need to choose the internet gateway which we have just created. So select the internet gateway over here, and here you will find the option automatically which is internet gateway test. So select that one and then click on save changes. So now if we go back to our diagram, so you can see, so now we have the VPC, we have the internet gateway, we have the route table for public subnet, and this public subnet needs an internet access so that a user can access this Bastion host. So for that purpose, we have just defined the public route or the internet access for that particular route table. We have created the public route table. So similarly, we also need to create a private route table for our private subnet. So again, go back to our AWS console. And here you just need to click on the route tables, click on create route table, just enter the name, that is test private route table. And once you select the name or enter the name, then you need to choose the VPC. So here the VPC is test VPC, which we have just created. And the name and the tags, I'm just gonna keep as it is. I'm just gonna click on create route table. And now our route table has been created. And remember, this is a private subnet route table and it doesn't need an internet access. So I'm just going to stick with the default route with this IP address, which means that it will not have an access to internet, but it will have an internal access within the VPC. So which means if we take a look onto this particular diagram, then this EC2 or any resource which is running into this private subnet can access a public subnet, or it can be vice versa. So anyone which has a public subnet or any resource which is present into the public subnet can access the private subnet resources as well. Alright, so let's go back to our AWS console, and here we need to associate this route table with our private subnet. So I'm just going to click on subnet association, click on edit subnet, select the private subnet and save association, and that's been done. So now we have also created the route table which is public as well as private. So now we have created the route table, we have created the public subnet and the private subnet. Now it's time for us to create our Bastion host as well as our EC2 instance in our private subnet. And if I compare with the example which I have taken for a castle, so we just need to create this tunnel which is a Bastion host, and we also need to create a castle which is an EC2 instance running into private subnet. So we'll be creating two EC2 instances. And then we will see how this Bastion host can access this EC2 instance which is running into our private subnet. So here is my AWS console, and I'm onto the dashboard homepage of my AWS console. In the search box you need to type EC2. We are just gonna first create our Bastion host EC2 instance. So click on EC2 and click on launch instance. And here you need to enter the name of your Bastion host, or which is present, which we will be creating inside our public subnet. So here I'm just gonna enter the name, that is test EC2 public instance. After that, I need to choose the operating system which I want to get installed onto my virtual machine. So I'm just going to choose Ubuntu. I'm just going to stick with the free tier because I'm just doing this for demo purpose. But if you are not doing this for demo purpose, and if you want this to be an actual environment, so then just choose some suitable high performance CPU. Alright, so now we have chosen the Ubuntu. Just choose the architecture, whatever feels suitable to you. I'm just going to choose 64-bit. And here I'm just sticking with T2.micro. Here we need to select the key pair so that we can SSH into our EC2 instance. So if you don't know like how to create this SSH key pair, then you can simply click on create new key pair. So click on this, and here you can see here you need to enter the key name. So what will happen over here is it will create two keys for you. One is the public key and another one is the private key. So once I enter the name keys for Bastion host demo. I'm just doing it for the demo purpose, so I'm just going to show you like how it is going to generate the keys, but I have already generated those keys, so I'm just going to use those keys. But you can just follow these steps if in case you are doing the keys generation for the first time. So just click on create key pair, and as soon as you will click on this create key pair, it will download you the private key which you can see over here, like keys for Bastion host demo.pam. That is your private key which you need to keep with you. And it has already associated the public key with this EC2 instance which you can see, which we are just trying to create over here, that is test EC2 public instance. And here it has already associated the public key which is key for Bastion host demo. So this public key is already associated with this EC2 instance once you select from this drop down. Okay, so that's the step you need to follow in case if you don't have the keys already with you. I have already generated my key, so here I'm just going to choose this one, that is AWS EC2. That's the key I generally use for demo purpose. Okay, so that about the keys. The next thing which we need to pay careful attention over here is the network setting, because here we need to carefully assign the VPC subnet what we are going to use for this particular EC2 instance. So click on this network setting and click on edit. And let's take a look onto the diagram once again. I'm just going to open the slide. So here we need to choose the VPC, the one which we have created. So I'm just going to go over here, drop down. Here we are going to choose test VPC. Here we need to choose the subnet. Since this is a EC2 instance, Bastion host that needs to be available into our public subnet. So if you can take a look onto this diagram once again. So here you can see this is our public subnet. So I'm just going to choose the public subnet. I think I can see, yeah, here is the public subnet which is already selected. Auto assign public IP, that's really important because you need to enable the public IP so that you can access this particular machine from your remote system. So I will be accessing this machine, this particular Bastion host from my own laptop. So I'm just gonna say enable. Security group, that's also important. So you just need to assign the security group name. So here I'm just gonna use the existing name, public instance. I'm just gonna use that one, and I'm just gonna put an suffix with the SG for security group. You can put the same description over here, and here you can set the SSH type. Because we need to SSH into our EC2 instance. That's why we need to enable this SSH security group, and we need to define this particular rule so that we can open the port 22. Otherwise, we will not be able to SSH into our machine. All right, that's been done. And after that, just check how much memory you need. So I'm just using the 8 GB. If you need more, just add it more. And after that, we can just click on the launch instance. So I'm just clicking over here. So here you can see our EC2 instance has been launched, or our Bastion host has been launched, which you can verify from here. So here you can see test EC2 public instance. So that's the EC2 instance which is in a pending state. So it will be started pretty soon. It will get started pretty soon actually. I'm just going to refresh it. It might take a couple of minutes. So just wait for it. And here you can see our state, it is in running state actually. So if I go back to here, click on EC2, there is a filter also where it only shows the running instances. So here you can see I have a filter running, and now you can see the EC2 public instance, which is our Bastion host, now is running. One thing which came into my mind, I would like to rename this instance to suffix it with the name like a Bastion so that it's easy to identify which is our Bastion host. So that's the change I would like to do it. The next thing which we need to do right now is to create an EC2 instance into our private subnet. So if I take a look onto this diagram once again, so here we have done with creation of a Bastion host. Now we need to create an EC2 instance which is into our private subnet. And if I compare with my example, then that's our castle. So again, what we need to do, we just need to go to EC2 dashboard, click on launch instances, and select the name over here. So I'm just going to copy the name from my notepad. So that is going to be our test EC2 private instance. So here, this is the private instance. I'm just going to select Ubuntu is my base operating system. I'm just going to select the key pair, which is the one which I have already created. In case if you are just creating, then choose that the key name which you have just created for you. Alright, I'm just going to edit the network setting. Here I'm just going to select test VPC. I'm just going to select the private subnet over here. And yeah, I'm just making sure that I'm selecting, yeah, that's correct. And auto assign public IP. I don't need a public IP. This is an EC2 instance into my private subnet. That's why we don't need a public IP. After that, here I'm just going to create the security group. So I'm just going to suffix it with the SJ private. Same thing over here. Now we need to define the security group roles. That's really important. Here we need to SSH. We need to access that particular private EC2 instance. That's why we are just going to enable the SSH for port 22. But source type. So from where you need to access this private EC2 instance. So we need to access from our public subnet from our Bastion host. So we need to access this EC2 instance from our Bastion host. And this Bastion host is residing into this IP address, that is 12.0.1.0. So that's our public IP, not public, but the IP range of my public subnet. So I'm just going to copy this IP range onto the source. So I'm just going to go over here, click on custom, and here I'm just going to specify this IP range over here. Select this one. That's been done. And I think we are quite good with that. And after that, we can just verify the other settings. So other settings seems good. I'm just going to click on launch instances. And here you can see our EC2 instance has been launched. So which we can verify. I'm just going to go back to dashboard once again. Click on instance running. Just wait for a minute. I'm just going to remove this filter. So here you can see this is our private instance, which is in pending state, which should come up and running in a minute. And here you can see our both instances are running. Our Bastion host is running and our test EC2 private instance is also running. So now we have done the infra setup for our Bastion host. Now the first thing which we need to do is we need to access our EC2 instance of our Bastion host. So this is the user, and now we will try to access our Bastion host. So for that, what we need to do, we just need to go to dashboard, our EC2 dashboard. Here click on this public Bastion host, click on this ID, and here we need to copy the public IP4 address of this particular Bastion host. So that's the public IP which you can copy. But key thing over here, how would you connect to this EC2 instance, which is our Bastion host? So just you need to click on connect, and here you will find all the instructions which is necessary to copy into your terminal. So first of all, what you need to do, you just need to identify your public, your private key actually. So the private key is the one which you have downloaded when you are creating your EC2 instance. So in my case, the private key with the name AWS EC2_Terraform, that's the one for me. But in case if you have seen, like we have created a key like key for Bastion host.demo, that's your own private key, but you can keep the name of your choice when you have created. So just select that particular key. And I'm just going to open the terminal over here. So here you can see this is my terminal, and I'm just going to run the lslart command, and here you can see this is the private key of me. But in your case, that private key might be ending with the extension .pam. That's absolutely fine. You don't need to worry about it. Alright, the next thing which you need to do over here, we need to change the mode of that particular private key. So I'm just going to copy this command chmod 400. I'm just going to clear the screen. And after that, I'm just going to type AWS EC2 Terraform. That's my private key, but change this name to your private key which you have created during the EC2 launch. I have changed it. The next thing which we need to do is we need to copy this SSH command from here. That will help you to SSH into your EC2 instance of Bastion host. Okay, I'm just going to copy this particular command, and here we need to remove few things over here. So I'm just gonna first of all remove the .pub extension because that's not a public key and I don't need it, and I don't have a PAM extension at the end. So I'm just gonna stick with this simple thing. Okay, so here this is the SSH command, this is the I, and this is the private key, and this is the Ubuntu, that is user, and this is the public IP of my EC2 instance. I'm just gonna hit enter, and it's gonna say, are you sure you want to connecting? So I said yes. And here you can see we are now entered into our EC2 instance of our Bastion host. So here you can see this is the IP range which is within the range of my public subnet, that is 12.0.1.2.1.4. That's the IP address which you can verify from here also. So that's the IP address which has been assigned to my Bastion host. So now our user on this diagram, you can see already entered into the Bastion host. Now we need to enter into the EC2 instance which is present into our private subnet. So we are already into our Bastion host, and from there we will access our private subnet. So how to do that? So for that purpose, I'm just going to open one more terminal. So this is a one more terminal, and remember we have used the same SSH keys for EC2 into the Bastion, into the public subnet as well. We have used the same SSH key pair for our private subnet EC2 instance also. So what we need to do, we need to copy that private key into our Bastion host. So for that, I'm just going to go to the directory where I'm storing my SSH key. And here I will just go and copy the AWS EC2 my private key. So I'm just going to run the cat command, and after that I'm just going to copy the whole content, go to my Bastion host. This is my Bastion host. I'm just going to clear it. I'm just going to create a file, AWS EC2 instance. Let's put name as key. Okay, I'm just going to open into the VI mode, paste the content of a key, save and quit. After that, I need to change the mode of this one. So 400 AWS EC2 public key and hit enter. That's been done. So now we have copied our private key into our Bastion host. So you can see over here into this diagram. So now we have copied that key so that we can access this EC2 instance using that particular key. So the next thing which we need to have the private IP of my EC2 instance running into the private subnet. So for that, what I'll do, I'll just go back to my console. So here is my console, click on EC2, click on, I just need to refresh it. Here you can see 2 instances, click on it. And here we need to click the private instance. Click on this instance ID. And here you can see there is no public IP address because that's our private EC2 instance running into private subnet. All right. So here I'm just going to copy this private IP of my private instance. Go back to my terminal over here. And here we need to form that particular command once again. So that is SSH/I. And then we need to enter the AWS key, which is our private key. After that, Ubuntu, the name of the user for the EC2 instance, and after that we need to enter the IP address, the private IP address of my EC2 instance. Click enter, type yes. And here you can see we already entered into our EC2 instance running into private subnet. So which you can verify. This is the IP address 12.0.3.192 and which you can verify from here. So that's a private instance which is available for you. So this is how this whole Bastion setup works. So now we have set up the VPC, Internet Gateway, public subnet, private subnet. We have created an EC2 instance, which is our Bastion host. And now we are able to first access the Bastion host and then we are able to access our EC2 instance also, which is running into our private subnet. Before we jump into the demo, it's a good idea to take a look onto our targeted architecture, which we are going to implement. So at a first glance, this particular diagram might look complicated to you, but we are going to break down this whole diagram into each block. So here on the left hand side, you will see this is a user which will try to access our application load balancer, and from there application load balancer is going to share the load between the EC2 instances, and these EC2 instances are running into the public subnet, and these public subnet is present inside our VPC. Alright, so let's start with our first basic building block for this whole setup. So that is going to be the VPC. So here you can see this is the VPC which we need to create onto our AWS environment. So I'm just going to switch to my AWS console. So this is my AWS console. Type in the search box VPC, click on the VPC. Here click on create VPC. Click on VPC only because we are only interested in creating VPC. Enter the name. So I'm just going to put test VPC. Then we need to specify the IP ranges. So here I'm just going to choose the IP range. This is a user defined. You can change and you can put your own default IP range which you want to have it. Okay, so that I have a specified tenancy. I'm just going to keep it default tag. I'm just going to keep it test VPC. And after that, you just click on create VPC. And here you can see our VPC has been created, which you can verify by clicking over here. And here you can see this is the test VPC which we have just created. Moving ahead, the next block which we need to create for this targeted architecture is the Internet Gateway. So this is the Internet Gateway which we are going to associate with our VPC. So again, switch back to our console and here onto VPC dashboard, you will find an option for an Internet Gateway. So just click on here. Here you can see there is no Internet Gateway has been created. Click on Internet Gateway. Then here you can specify the name. So I'm just going to copy from my notepad and paste it over here. And this is the IGW. That's the abbreviation I'm keeping it. And the key name, the tag name, I'm just going to keep it name and Internet Gateway test. So click on create Internet Gateway. And here you can see our internet gateway has been created. But remember that internet gateway is not associated with the VPC, which you can verify from here. So this internet gateway has been created, but state is detached. So you need to click on this internet gateway, go to action, go to attach VPC, and here you need to select the test VPC, which we have just created in the previous step. So attach to internet gateway. And now our internet gateway is ready. Moving back to our diagram, the next block which we need to create over here is the subnet. So here we are going to create two subnets. Both are going to be a public subnet, and these are the IP ranges which we are going to assign to those subnets. So let's switch back to our AWS console, and here in the VPC, not VPC, but on a VPC dashboard, you will find an option for a subnet. So here you can see these are the subnets. Click on it. So here these are the default subnet which has already been created for you, but we don't need to use that. We are going to create our own public subnet. So click on create subnet over here. Then you need to select the VPC. So select test VPC because we are going to work inside our test VPC. Okay, so now we have selected the test VPC, and then we need to enter the name of our public subnet. So I'm just going to put the name test public subnet 1A. So I'm just going to explain to you why I'm using 1A, because I'm present in the Europe zone. So that's why I'm using the Europe Central 1A. That's the availability zone. So I'm just going to select that one. After that, we need to specify the IP range for my public subnet. So I'm just going to use the IP range over here. So I have just copied and pasted. So here the value which I have pasted, so 12.0.1.0/24. So I will have a 256 IPs available within my subnet. So that's my first public subnet which I have created. I need to create one more public subnet so that we can create two EC2 instances inside those subnet, and then we can load balance the traffic onto those EC2 instances. So that's just a heads up for you. Okay, so here I'm just going to copy another value. So I just going to paste the name, and sorry, this is not the correct. So I'm just going to copy the name from the top, go over here, and here I'm just going to change it to 1B. So that I can provision this subnet into another zone. And here again, I'm just going to specify the zone, that is Europe Central 1B. After that, I need to specify the IP range. So I'm just going to check what IP range I have specified. So it's a 12.0.3.0. So I'm just going to copy from my notepad, go back to my AWS console, paste the value over here, and the tags, that's fine. I'm just going to click on create subnet. And here you can see our subnet has been created. If you go back to dashboard, and if you click on subnet, then here you can see these are the two subnets which we have just created. Now, after creating the subnets, we need to create the route table also, so that this public subnet can have the access to the internet, because internet gateway and the subnets are still not connected with each other, and for that we need a route table. So here you will also find an option on the left hand side to create a route table. So click on it. And here these are the default route table, but we are not going to use that one. We are just going to create a new one. So here I'm just going to put the name of the route table. So test public RT. RT is the abbreviation for a route table. Then again, we are working in a single VPC. So the VPC which we have created is the test VPC. I'm just going to select that one. The key, I'm just going to go with the default value, and then just click on create route table. Check the route tables over here. So here you can see our route table has been created. The next thing which we need to do, we need to provide an internet access to this route table. And also we need to associate this route table with our subnet. So first of all, we are just going to associate this route table with our subnets. So I'm just going to click on subnet association, go to edit subnets. And here you can see our both the subnet which I have created. So select both of them and save association. So now this route table is being associated with these subnets. But still, these subnets don't have the access to our internet. And for that, we need to create a route. So here go on to routes. Inside the route table, click on edit routes. And here click on add route, and here you need to enter the IP. So this 0.0.0.0 means it will have an internet access, and anyone can access those public subnet, or any resource present inside that public subnet will be accessible. So that's just a heads up for you. Now we need to select the internet gateway, because internet gateway is responsible for providing the internet access for this route table. So I'm just going to select the internet gateway, and here you need to the internet gateway name will pop up, because this is the internet gateway which we have just created. So select this internet gateway, and after that you can just click on save changes. Alright, so now this route table has an internet gateway which is linked to internet, and now we are having the subnets also. All the public subnets are associated with this particular route tables. Now, after creating the route table, let's take a look onto the diagram first and check on the next block which we are going to create. So here, these are the things which we have achieved so far. We have created the VPC, we have created the internet gateway, we have created the subnet, and we have also created the route table. Now, the next thing which we need to create is we need to create the EC2 instances. So we will create two EC2 instances, one in first subnet and another one into another public subnet. So we have already created the two public subnet inside our AWS. So let's switch back to our AWS console over here and go to home page of our AWS console. Click on EC2, or either you can type over here. So EC2 over here. And here you can see there are no instances running. So click on launch instances. And here we are just going to put the name test EC2 instance 1. Second, we need to choose the base operating system. For that, I'm just going to choose Ubuntu. After that, I need to choose the architecture. So I'm just going to go with x86. I'm just going to choose t2.micro because this is just for demo purpose. Key pair, I'm just going to choose, I'll just create a new key pair. So test ALB demo key pair. All right, then create key pair. And remember, once you create this key pair, then here it is going to download this key pair for you. Okay, and also it is going to associate this public key. So here you can see in the drop down, the public key has been associated with our EC2 instance. And this is the private key which we have downloaded, which we are going to use later. Okay, so now we have created the key pair. Go to network setting. This is important because here we need to change few things. And the few things I'm talking about is we need to associate our test VPC, which we have just created. So here from the drop down, just select the test VPC, which we have created. Then from the drop down menu, you need to select the public subnet. So by default, it will populate those subnet which we have created. So first of all, for first instance, I'm just going to go with the test public subnet 1A. So that has been selected. Assign public IP. So I'm just going to say enable it. Yes. Create security group. That's important because we are just going to create some security group rules over here. So here you can see by default, we are allowing the SSH. So whenever this EC2 instance starts, so we will be able to SSH into this EC2 instance on a port 2020. But also we need to enable the port 80 so that we can access the Apache which we are going to install onto this EC2 instance. So for that, click on add security rule. And instead of custom TCP, we are just going to choose the HTTP and here port 8080, source type from anywhere. So we will be able to access this EC2 instance from anywhere in the world. So I think that's good. So remember, we need to create at least these two security groups. One is for SSH and one is for HTTP port 80 so that it is accessible from outside AWS environment. All right, so that we have done it. The default storage, we are going to go with the 8 GB. And in the advanced details, here we need to do few more things. So if you go down, then here is the user data section where you can write down the packages which you want to get it installed onto your EC2 machine. So if you don't know what is user data, then please check the previous session where I have explained like what is user data and how you can use the user data to bootstrap or pre-install certain software packages. But just to give you a brief, I'm just going to copy one of my script, which is, I'm just going to show you, which is this. So here what we are going to do, we are just going to update the package manager. We are just going to install the Apache 2. And after that, we are just going to update the index.html so that it can print the host name of that EC2 instance. So that's the simple thing I'm just trying to achieve over here. All right. So once we are done with all this thing, what we are going to do, we are just going to click on this launch instance button. So click on launch instance. Okay, so here our instance has been launched. So click on this instances and here right now it is in a pending state. So I'll be back once this instance is up and running. So after a minute or so, my instance is up and running and here you can see the status which is running. So click on this instance ID and here you will find the public IP. So first we need to verify our Apache whether it has been installed or not. So I'm just going to copy this address, go to browser and hit enter. So here you can see these are the server detail. I'm just going to zoom in a bit over here so that you can see. So this is the IP which we are trying to print over here so that we can later on verify once we provision the load balancer so that which request is going to which EC2 instance. So this is the internal IP address which you can see 12.0 142, and now this IP range you can know that this is the same IP range we have specified for our public subnet. So now we are getting the IP addresses for our EC2 instance from that particular range. Okay, so I'm just going to close this window over here and I'm just going to click on EC2. So as of now, I'm just going to refresh it again. So here you can see one instance running. So now we have provisioned one EC2 instance, but we need one more EC2 instance into another public subnet. So for that, I'm just going to click on this launch instance. And here I'm just going to put test EC2 instance and I'm just going to put 2, select Ubuntu. Then here you just need to select the architectural type. I'm just going to go with the default x86 T2 micro, and here I'm just going to choose the key pair name which I have just created. I think it is test ALB demo key pair. Network setting, I'm just going to edit it, select the VPC which is test VPC which we have just created, and here subnet I'm just going to choose 1B. Okay, and here auto assign, enable it, create security group. Yes, we want to create a security group, and for that we are just going to go with the default which is SSH22 because we want to SSH into our EC2 instance, but also we want to enable the HTTP on a port 80. So, and also I just want to exit it from anywhere. Okay, so now we have defined this security group rule. The next thing which we need to do is configure storage. I'm just going to stick with the default one, but in the advanced detail, I'm just going to go with the user data. So here, this is the section. I'm just going to copy the script to install the Apache, and that's been done. And after that, I think it looks good. So I'm just going to hit on launch instance. Okay, so click on launch instance. All right, so let's go back to instances. And here you can see it is in pending state. So I'll be back once this second instance is up and running. All right, so now my second instance is up and running. So let's verify a few things over here. So I'm just going to copy the IP address, which is the public IP address, and verify my Apache 2 page. So click on it. And here you can see, I'm just going to zoom in a bit. So this is the IP which has been assigned for this EC2 instance, and now it is 12.03 and then 160. So it's again coming from the default IP range which we have assigned for our another public subnet, and which you can verify from here also. So here you can see the same IP which is available over here. So now we have provisioned our EC2 instances, and now we have installed the Apache, but we have not yet configured the target group, which we are going to do the next. But before we create a target group, let's take a look onto our architectural diagram. So here you can see we have achieved so far like VPC, internet gateway, subnets, and also we have provisioned the EC2 instances. So now what we need to do, we just need to create our target group. So target group is just a logical units where we are going to club these EC2 instance into this single target group, so that later on Elastic load balancer can point to this particular target group. I know it sounds complicated, but let's take a look onto our AWS console, and then you are going to understand what I'm trying to say over here. Alright, so this is my EC2 dashboard. So click on this EC2 dashboard homepage, and on the left navigation menu, there is an option for load balancing, and inside the load balancing, there is an option for a target group creation. So click on target group, and here you can see this section is empty. So we need to create a target group, and inside that target group, we need to include both the EC2 instances. So first of all, let's click on create target group. Here, there are certain types of target group which you can create. But for this example, we are just going to stick with the EC2 instance or instances type target group. So just select this one. Go ahead, and here you need to enter the name. So I'm just going to put the test EC2 ALB demo target group. So TG is for abbreviation. IP address type. So I'm just going to stick with IP4. VPC, because everything we are doing into the test VPC. So we need to select the test VPC over here. Protocol version, I'm just going to stick with HTTP1. The health check endpoint, I'm just going to go with the default root, because as you can see, we are just able to access our home page and we don't have any path which is like this. So we don't need to specify anything. So I'm just going to go with the root path. Okay. Go ahead, advanced health check setting. I'm just going to stick with the default. We don't need to change it. Tags, it's optional. So I'm just not going to assign any tag name. Click on next over here. And as soon as you click next, then you can see all the EC2 instances running, which are ready to be included. So here you can see, here you can select the EC2 instances which you want to include. So I'm just going to select these, and both of the EC2 instances are running. And now I have selected both of it. Now, after selecting, you need to click on include as a pending below. So here it will be included and it will be accessible on a port 80. So I'm just going to click include as pending below. And here you can see these targets are now included, and after that you just need to click on the create target group. So click on this create target group over here, and here you can see our target group has been created. So click on this create target group, and yeah. So as of now, the health status is unused, as you can see over here, but you just need to wait for a couple of minutes and the health status should change to healthy. One correction I'd like to make over here. So here you can see the health status is unused because we have not created the application load balancer. So once we create the application load balancer, then this status will change. So now what we need to do, we just need to create our application load balancer. But before we create our application load balancer, let's take a look onto our architectural diagram. So here you can see we have come far away. So we have created VPC, Internet Gateway, public subnet, private subnet. We have provisioned the EC2 instance, and also we have created a targeted group. Now the next component which we need to create is we need to create an application load balancer. So let's go back to our application console, AWS console, and here click on EC2 dashboard, and in the left navigation you will find an option for a load balancing, and here you will find an option for a load balancer. So click on this load balancer, and here you can see there are no load balancer has been created. So click on this load balancer button, and here you will find the three types of load balancer, which is application load balancer, network load balancer, and gateway load balancer. But here we are only interested into application load balancer. So we are just going to choose this one. Okay, so click on create over here. So now what we need to do, first of all, we need to assign the name for a load balancer. So I'm just going to assign the test LB for EC2 demo. Okay, so that's the name. The scheme is internet facing. So yes, we want to have it as an internet facing load balancer. Into the network mapping, and as I have told many times, we are just working under a VPC which we have created, and the name of the VPC is test VPC. So in the drop down you will find the test VPC, just select that one. And once you select the test VPC, then you will automatically get the subnets which we have created. So here we have created the one public subnet which is in EU Central 1A and another one. We need to select both of it, otherwise our application load balancer will not work. Okay. The next thing which we need to create over here is the security group. So there is a one default security group which has been created, but we need to create a one more security group for port 80 and for accepting the HTTP request. So for that, what I'm just going to do, I'm just going to click on this create security group over here, and I'm just going to put security group for LB, ALB demo, and allow access from internet. That's the description I'm just gonna put here. We need to choose the VPC info. So here if you click on this one, then I'm just gonna choose test VPC. Inbound rule, add, click here and type HTTP, and here I'm just gonna choose the port 80, and source I'm just gonna put 000 so that anyone from anywhere can access this load balancer. Okay, so that this security group has been created, I'm just going to copy this security group name because that will be needed to add this security group, and I'm just going to click on create security group. Cannot begin with SG. Okay, so I need to change it. Okay, so let's put security group for ALB demo, and I'm just going to click on create security group. Alright, so this security group has been created. I'm just going to copy this name from here, and I'm just going to close this window. I'm just going to refresh this page over here, and here we should find that security group. So that's the security group which we have just created. Select that one. So now we have selected the default as well as the security group for allowing the HTTP request on a port 80. Alright, now here in the listeners and routing, so here we need to select the target group. So let's take a look onto the diagram once again so that it's easy to understand. So here in the green box, which is, you can see this is our target group. So this target group we need to select for this load balancer, and this target group which we have already created. So if you go over here in the target group, so here you can see, so this is the target group which we have already created, and inside the target group we have both the instances, EC2 instances running. So I'm just going to copy this name from here, And into this listener and routing, I'm just going to select. Here you can see it is by default coming because that's the only target group I have inside my AWS account. So I'm just going to select that one. And the listener tag is optional, so I'm just going to skip that one. Add-on services are optional, so I'm just going to skip that one. So here, just take a look onto this summary over here. So the basic configuration for this auto application load balancer is this is an internet facing, this is an IP4. Security group, we are allowing the HTTP/AT. This is the security group which we have created. This is the default one, so I'm just not going to change that one. So this is the VPC, and this VPC is trust VPC. And these are the subnets, the two subnet which I have created, which are public subnet. And this is the target group. So this is the target group inside where we are having two EC2 instances running. All right, so now we can just click on create load balancer. And as you can see, successfully created the load balancer. So just go on to load balancer tab once again, and here just wait for a couple of minutes because it's still into the provisioning state. So it might take a couple of minutes to provision this whole load balancer. So I'll be back once this auto load balance application load balancer is up and running. All right, so after a couple of minutes, my application load balancer is in an active state. So click on this application load balancer over here, and here you will find the details, and the detail which we are looking for is the DNS name so that we can access that application load balancer. So here you can see the DNS name which is present. So you can just copy this DNS name from here, go to the new tab and hit enter. And here you can see, I'm just going to zoom in a bit so that you can see. So now the request has been routed to the EC2 instance 2. I'm just going to refresh it once again. So here you can see the request is landing on another EC2 instance because the IP address has been changing. So again, refresh it. So here you can see the IP address has been changed, and we can verify the EC2 instances here also just to reconfirm what's the IP address. So EC2 instances. So I'm just going to open this one and this one. So the instance IP address, I'm just going to zoom in a bit if it is too small. So 12.03.160. And another one is 12.01/.142. So these are the two IP address. And if I refresh this, so the request is going to the 1/142, and then another request is going to the 3/160. So that's how we are just gonna set up the application load balancer, and that application load balancer is responsible for sharing the request between the EC2 instances which you have set up inside your VPC. So let's take a look onto the architectural diagram once again. So this was the target architectural diagram, and the last pieces were just nothing. It was just a few arrows. So here this was the user, and it is accessing the application load balancer, and the requests are being routed to both the EC2 instances. So here you can see, and the user is us, and this is the DNS name through which we are accessing the application load balancer, and then the request is getting routed to both the EC2 instances. I hope you liked today's session on an application load balancer, and if you are interested into the similar content, then please check the description section where I have posted the links of various courses like Terraform, Helm chart, Kubernetes, Docker. So those are already available onto this channel. So go and check those courses, and there are many more sessions on AWS which I have planned, which I'll be uploading into the upcoming weeks. And if you are interested into the more in-depth DevOps practices and DevOps project, then I have a YouTube channel membership which you can be a part of, and where you will see more in-depth projects which I keep on uploading onto only for the members. So if you are interested, then please consider subscribing to the YouTube channel membership for my channel also. So see you into the next session of a DevOps or AWS series. Till then, take care and bye bye. Hello there and welcome to the AWS series, and in this session of our DevOps we are going to take a look onto setting up our AWS network load balancer. Here is our target layout which we are going to implement as an end result of this session. So here we will be setting up an EC2 instance within our VPC which will have a subnet, internet gateway, route table, and EC2 instance running within that particular subnet. We'll also set up a target group where we will be adding our EC2 instance to that target group, and after adding that we are going to set up our application load balancer as well as our network load balancer. And also I'm just going to show you what are the differences between the application load balancer and when we are trying to access our network load balancer. So for this session we need to understand what's the basic difference lies between the NLB, which we call it as a network load balancer, as well as application load balancer. So this is our target layout which we are going to implement throughout this session, and there are two components which are important for this target layout. One is application load balancer and one is NLB, which is our network load balancer, and which is our key topic for this particular session. But why I have kept ALB and NLB into this implementation is because you need to understand the basic difference between ALB and NLB and when you need to use it. But don't worry about it. We are just going to break down this whole layout into bits and pieces, and we are just going to implement each component. So on a crux level, I will say that we are going to set up an VPC. We are going to set up a subnet. Inside the subnet, we will have an internet gateway, route table, and EC2 instance. And for that EC2 instance, we will be creating a target group so that load balancers can point to this target group. So once after creating a target group, then we are going to create an application load balancer, and we are also going to create a network load balancer. So any of the load balancer will have access to that target group so that it can reach to the EC2 instance. And at the end user like us, we will be using the URLs for application load balancer, as well as we will be using a URL to access our network load balancer. So let's jump into this session and start setting up our whole networking first. Let's start with our first component, and that is our VPC within our AWS account. So this is the first VPC which we are going to create, and with the IP range 11.0.0.0. So let's get over to our AWS console and start setting up our VPC. So here you can see this is my AWS console, and go to your home page and type VPC over here. Click on VPC, and here there are a couple of VPC which I have already created, but for this session we are just going to create a fresh VPC. So click on create VPC over here. And here we are going to choose the option VPC only, and here we are going to put a name for it. So I'm just going to put a demo NLB VPC. Then we need to specify the IP range. So I'm just going to put 11.0.0.0/16. And I'm just going to stick with the default setting over here. I'm not going to use IPv6, and the key and value, I'm just going to keep it default. And after that, click on create VPC. And if you go to the VPC dashboard once again, and here you can see there are 3 VPCs. Go to the VPCs and you will be able to verify your VPC, which is this one, demo NLB VPC. Click on this VPC, and here are the details related to your VPC. After creating the VPC, the next resources which we need to create is the subnet. And the subnet we are talking about is the public subnet and the private subnet. So within the VPC, we are just going to create 2 public subnet and 2 private subnet, and the range for the private and public subnet, which you can see over here, is public will have 11.0.1.0, and the another public subnet within that VPC will have 11.0.2.0. And similarly, the private subnet will have we will create 2 private subnet, and both the private subnet will have IP ranges ending with 3.0 and 4.0. So 1.0, 2.0 for public, and 3.0 and 4.0 for our private subnet. Let's go to our AWS console once again for creating the subnet, and again click on VPC dashboard over here and click on subnets. And here are some of the default subnets which I have already created, but I'm not going to use those. I'm just going to click on create new. First of all, we need to select the VPC. So if you take a look onto the diagram over here, then these subnets lies within this particular VPC. So we need to choose the VPC which we have just created. So go back to your console and select the VPC. So our VPC is demo NLB VPC. Select that one. And here I'm just going to put the subnet name. So I'm just going to put the demo NLB public subnet 1A. 1A I am suffixing it because we need to choose the region. So differentiate that. That's why I'm using the 1A. So here you will see the availability zone, and here I'm just going to deploy it inside my Europe Central 1A. That's why I have suffixed it with 1A. And IP range, as I told you, we are just going to stick with 1.0 and 2.0 for public IP. So I'm just going to put 0.1.0/24. 24 is just defining the IP ranges. So if I choose 16, then my IP ranges will increase. So here you can see 65,000. But since it's a demo, so I'm just going to choose 24 so that I have a 256 IPs, which are sufficient for demo. Okay, so this is our first public subnet. And click on add one more new subnet. I'm just going to copy this name from here, paste it over here, and I'm just going to choose 1B. Availability zone, I'm just going to choose different availability zone so that I have maximum availability. And IP range, I can copy it from here and paste it over here also. But here I will choose 2.0. Okay, and now we have created our public subnet. So let's create private subnet here as well. So click on add new subnet and paste the name. I just need to copy the name once again from the top. So I'll copy this name and paste it over here, and instead of public, I'm just gonna make it private and put it 1A. Availability zone, I'm just going to choose 1A. I'm just going to copy the IP range from the top, and for private we have chosen to go with 3.0, and that's it. I'm just going to copy this name once again because we are just going to create a one more private subnet. So go ahead, click on add new subnet, paste that one, select it to 1B, change the availability zone to 1B. And IP range, I'm just going to copy the IP range from here, put it over here and make it 4.0. And now we are done with it. So here you can see the subnet 4 of 4. So we have created 4 subnet, 2 public subnet and 2 private subnet. And if you take a look onto the diagram, so these are the IP ranges. Since I have a very limited space on my slide, so that's why I cannot create 4 different boxes because there are more components I'm just going to fit to it. So I have just mentioned over here the IP ranges so that you know that we are working with the 2 public and 2 private subnet. Okay, so once we are done with it, just verify the details once again by going up, and it looks correct to me. And then what we are going to do, we are just going to click on create subnet. And here you can see our subnets has been created. And if you want to look a very like a filtered view, so from the drop down you can select the VPC which we have created. So just select a demo NLB VPC so that it will not be so many records popping up over here. So you will see only the resources which belongs to your VPC. So that's just a quick tip for you. Let's move ahead, and the next resource which we need to add to our networking setup is our internet gateway. And internet gateway is just a route to getting an internet access. So we need to attach to the public subnet because any resource present within the public subnet will have access to internet, as well as any resource within the public subnet should be accessible from outside of our VPC so that I can access from my local laptop. Although we need to set up our route table and other restrictions over there, but internet gateway in a crux, we need to set it up with our public subnet so that it is our resources can access the internet. Okay, so let's go back to our AWS console, and here you can see these are the subnets which we have created. Let's go back to our VPC dashboard once again, and from the left navigation we can select internet gateway. So click on this one and click on create internet gateway. And here we need to put the name. So I'm just going to put a demo NLP IGW for internet gateway abbreviation. And after that, just simply click on create internet gateway. And if you go back to internet gateway dashboard and just refresh this thing. Sorry, we need to remove the filter because internet gateway is not attached to VPC yet. So here you can see this is the demo NLB internet gateway which we have created, but this internet gateway is still an open internet gateway. We need to attach it to our VPC. So click on this internet gateway over here, and here you can see the state is detached. So if you take a look onto the diagram, so this internet gateway is present within the VPC. So we need to make this attachment happen. So I'll go over here, click on actions, click on attach to VPC, and then select the VPC, which is our demo NLB VPC. Select that one, click on attach internet gateway. And here you can see our internet gateway has been attached. Alright, so now after attaching the internet gateway to our VPC, then the next resource which we need to create is the route table. And the route table we are going to create is for our public subnet as well as for our private subnet. So these are the 2 route tables which we need to create. So let's get back to our AWS console over here and go back to our VPC dashboard once again. And from the left navigation menu, you can also find the option for a routes table, and from the dashboard you can also find the route table option. So select that one, and here if you remove the filter, then you can see the other route table, but we are not interested in those. We will create our own route tables over here. So click on create route table. So first thing we are going to create is our public route table. So I'm just going to put demo NLB public RT. I'm going to use for route table abbreviation. Then select the VPC. Since we are working in the VPC, so we need to select the VPC, which is our demo NLB VPC. So from the drop down, go and select demo NLB VPC. tag, I'm just going to keep everything default and then click on create route table. And here you can see our route table has been created. I'm just going to copy this name to create our private route table as well. So click on route tables, go to create route table, then put it over here, change it to private, and the VPC, I'm just going to select demo NLB VPC and then click on create route table. And here you can see both the route tables has been created for NLB demo, which is our public route table, and our private route table. Now let's take a look onto the diagram once again. So we only created the route table, but we have not attached this route table to our public subnet. So similarly, this private route table is also not attached with our private subnet. So we need to go back and attach or make those kind of association. So let's go back to our route table dashboard. So open the public route table over here and click on subnet association. So here, click on it, and here you can see the subnet association is completely empty over here. So click on edit subnet association, and since we are working into our public subnet, so I'm just going to attach to our public and this one. So we are going to attach to our our public subnet to this particular public route table. Click on save association, and we have updated our route table with our public subnet association. So again, go back to our route tables and select the private route table. Go back to subnet association, click on edit subnet association, and then select private subnets over here, and then click on save association. Okay, so now our route tables has been attached, so which we can verify once again. So here you can see public route table, this is public route table, and these are our public subnets attached to it, associated with it. Similarly, if we go back onto our private, then here we can see our subnets for our private route table is our private subnets. Okay, there is one more thing we need to set for our public route table is our route to the internet gateway. So if you take a look onto this diagram, so here you can see this is the internet gateway which we have created, but we have not created any route inside this route table for this internet gateway. So that is important because we are working into public subnet and we need to attach this internet gateway to this particular route table. So go back to our route table, click on this route table, and we are going to choose public route table. So click on this one. And here you can see the routes. This is a default route for our subnet. So I'm just going to click on edit routes, click on add, and here I'm just going to choose the IP 0.0.0, which means this is our, we are allowing all the IP addresses for this particular route. And click on target route. So here I'm just going to choose internet gateway. And if you click on this one, then you will find a demo NLB internet gateway, which we have just created. So select that one and then click on save changes. And here you can see our public route table now have our internet gateway as well as our subnet association, which is our public subnet, and which you can compare from our diagram over here. So here you can see this public subnet is now ready with our internet gateway as well as our route table. Let's move ahead to the second chapter, and in this chapter we are going to set up our EC2 instance. So here you can see this is the same setup we are just carrying forward, and now we are going to set up our EC2 instance into our public subnet. So again, go back to your AWS dashboard, go to the home page, and in the search box you can type EC2, click on this EC2 over here, and here you can see no instances running. So I'm just going to click on launch instances. And here we are going to put the name of my instance. So I'm just going to put demo NLB EC2 and I'm just going to put 1 because we are going to spin up multiple EC2 instances over here. I'm just going to go with my Ubuntu as my default operating system for my Linux machine. And I'm just going to stick with t2.micro. And key pair, I have already created this key pair AWS EC2 Terraform.pub, but here for the demo I'm just going to create a new key pair so that we can SSH into that EC2 instance. So click on create new key pair, and here you can type demo NLB key. Click on create key pair, and here you can see the private key has been downloaded for you, and and the public key for this particular setup has been attached to your EC2 instance from the drop down, which you can see. Okay, we are just going to use that private key later, but for the time being, let's continue ahead with our networking setup. So here you can see this is the networking setup. Click on edit over here, and here we need to assign the correct networking, because we have already done the setup for networking and now we need to provision our EC2 instance into that networking setup. So if you take a look onto the diagrams, then EC2 instance is present into this public subnet under this VPC. So let's go ahead and from the drop down choose the correct VPC. So the VPC which we are using is demo NLB VPC. So select that one. And the subnet we are just gonna choose, let's go ahead and choose our public subnet 1A. So this is the one, demo NLB public subnet 1A. So I have chosen that one. Public IP, yes, I just want to enable it. And after that, security group, we just want 22, which is we are going to use for SSH. Then add one more security group, and here I'm just going to choose HTTP port, and I'm just going to use 80. And source type from anywhere, because this is just a demo, that's why I'm keeping it from anywhere so that anyone can access this port 80. And because why I'm enabling port 80, because we're just going to install the Apache and some pages, basic HTML pages onto that Apache machine so that we can access on a port 80. So that's the reason I'm setting up this security group. Okay, and after that we just need to go to the advanced detail, and here we need to set up some installation script into the user data section. Here you can see this is the user data. Here we will write some script which will be responsible for installing the Apache as well as some custom pages, HTML pages onto that particular Apache instance. Here is my script which will install the Apache. So I'll go to this script one by one. So this is going to update the package manager for my Ubuntu. Then it is going to install the Apache. Then it is going to set up this basic index HTML page. And after that, it is just going to restart the Apache 2. So this everything will happen when we are setting up or when we are starting up our EC2 instance. So it is all the startup time setup which is happening. And once the system is up and running, then we will be able to access our Apache homepage, which is running on a port 80. And if you don't know much about this user data section, then I have prepared a separate session on this same playlist of AWS where you will find the more details like how to work with your user data setup. So just go and check that session. Okay, so I have created this script. Just click on launch instances over here. And here you can see our instance is getting launched. So click on instances. And here you can see this is into pending state. These are some previous instances which I have been testing around, but those have been terminated. But we need to wait for this status to go running. And then we will verify our Apache homepage. And here you can see my instance is up and running. So click on this instance ID over here, copy this public address, go to the new tab and paste it over here. And here you can see this is our homepage of my Apache 2, where it is setting up the host name and IP address for that particular instance. So that concludes that my Apache has been installed successfully onto my EC2 machine. After installing the Apache, we need to set up a couple of more pages. So here you can see this is the instance IP, which we verified it, which you can see in the backend also, which is up and running. But we also need to set up custom pages. So one, I'm going to set it foo, and one more, I'm just going to set it bar. So that we need to set it up by going into our EC2 instances and setting up these custom pages for that particular Apache instance. We need these custom paths because we will be setting up our application load balancer, and also we will be setting up our network load balancer. So I will be able to show you the difference between how application load balancer behaves when we have a custom path and how we can set those custom rules in application load balancer. But at the same time, that is not possible with the network load balancer. So that's one more difference which we need to check when we are setting up our application load balancer as well as network load balancer. Now let's go back to our EC2 instance, and here click on connect over here, and here you will find the instructions for connecting to your EC2 instance. So first of all, you need to have the key which we have already downloaded, which you can see demo nlb-key.pam, which I have already downloaded. We need to change the permission to the 400 so that it's only read only. So I'm just going to copy this command and I'm just going to head over to my terminal, and let me open my terminal over here. So here you can see this is my terminal. I'm just gonna, here it looks good. Now I'm just gonna clear this one, and first of all I'm just gonna verify whether I have that key here or not. So here I'm just gonna type demo, and I need to put grep, and here you can see I have that particular key available into this particular directory. Okay, so I'm just gonna copy this command from here, and I'm just gonna change the permission. to 400 that I have changed it. And then I'm just going to click on SSH command over here so that I can SSH into that instance. So I'm just going to go back and I'm just going to paste it over here and then type yes to connect it. And here you can see I'm inside my EC2 instance. I'm just going to clear this screen over here. And first of all, let's verify the status of our Apache. So I'm just going to run system ctl status Apache 2. And here you can see it is up and running. Okay, let's create the directories first. So I'm just going to copy the command from my notepad and paste it over here. So first of all, we need to create the foo directory inside a var www.html. And you can find all these commands into the description section, so don't need to worry about it. So I'm just going to hit enter. And the next directory which I'm just going to create is for bar. So let's hit enter, and then we can verify that those directory has been created. So run the command lsLART and then type var w and html, and here you can see the directory has been created, foo and bar, and we have the default index html page which we have already verified from here. The next thing which we need to do is we need to create a index.html file. We have created the directory. Let's create the index.html file. So I'm just going to clear this one and I'm just going to copy the command to create an index.html. So this is the first command which I'm just going to write to index.html inside the foo directory. Hit enter. And then I'm just going to copy the second command to write inside my index.html of bar. So here you can see this is not write but create index.html. So here you can see we have created both the file, and we can verify by running the ls command also and going into the foo directory. And here you can see the index.html there, and similarly if we go to the bar, then we should also see the index.html. Okay, I'm just going to clear the screen. And the next thing which we need to do, we just need to write some content inside our HTML pages inside foo as well as inside our bar. Okay, so first of all, let's open that file into edit mode. Here you can see I have put inside edit mode. Press I to go into edit mode, and then I'm just going to copy the content and I'm just going to paste it over here. So here you can see this is the message from foo inside the foo.index.html, and then after save and quit. Similarly, I'm just going to copy the another command for bar and paste it over here, hit enter and go to insert mode, and then copy the command from here, the text, sorry, and here you can see this is bar. So save and quit. And now our index.html has been placed inside my Apache 2 foo and bar. Now the thing is we need to restart our system. So I'm just going to do sudo system ctl restart Apache 2. And it will restart our Apache 2. Let's verify those pages. So go back to the home page once again. So this is the default home page which you can see, which tells us the IP address, but now we have set up foo and bar. So just click on foo over here. And here you can see this is the foo HTML page which is showing up. And similarly, I'm just going to click on bar. And here you can see the bar HTML page is also set up. So now we have set up our EC2 instance, which is up and running. And also you can see we only set up one EC2 instance, which is into running state. So I'm just going to change it to running. So here you can see this is a one instance. So I'm just going to set up a one more instance, exactly following the same step which I have just shown you. And I'm just going to set up a one more instance over here so that our load balancer can redirect those requests to the respective instances. And yeah, I'll try to come back once I have set up this whole EC2 instance and my second EC2 instance is up and running. And then we'll start to look into the target group setup and the load balancers. Alright, so both the instances are up and running, and here you can see the second instance over here. I'm just going to copy the public IP address, go to the next URL tab, and here you can see this is the home page. And if I go to foo, then you will see the foo message from my Apache 2 which is running into my instance 2. Also, I have added the name so that we can identify that request is landing on which server. So that's the additional modification which I have did. And similarly, I have modified this instance HTML page also, and I have hard coded the name. So if I go here and if I go and click on let's say foo, then it will show you the demo from EC2 1. So that we can identify where the requests are going when we will start accessing it from our load balancer or network load balancer as well as the application load balancer. All right, so instances are up and running. The next thing which we need to do is we need to set up our target groups. So let's take a look onto the diagram once again. So here you can see this is the setup we have done so far, and now we will just work onto this EC2 instance subnet. So I will just remove some of the elements from this diagram, and here I'll just shift this particular EC2 instance block to the right side so that we get a more space over here. And the next thing which we need to set up is our target group. So target group will set, so this is our EC2 instance and everything is running. So now we need to create a target group over here. And this target group is just a logical group where we will be mapping our EC2 instances. So this target group will include the instances, which is like a EC2 instance 1 and EC2 instance 2, which we have created. So let's go ahead and create this target group and map those EC2 instances inside that target group. So here is my AWS dashboard, and click on this EC2 because that's where we'll find the option to create a target group. So from the left navigation menu, just go to the load balancing section and you will find the option for a target group. Then click on here, and here we need to click on create target group. So here, and here we need to choose the instances because we have set up the EC2 instances. So I'm just going to choose with the target type as instances, and the name of the target group. So I'm just going to choose NLB demo target group. TG I'm using for abbreviation. The port, which is important over here, since we are working with the network load balancer, so we cannot use the HTTP over here. So instead we need to use TCP, which you can see over here, used with a network load balancer. If you choose HTTP or HTTPS, then you will not be able to set this target group with a network load balancer. So that's the key thing which you need to keep in mind. So click on TCP over here. And IP addresses, I'm just going to stick with IPv4. VPC, we need to change from here to demo NLP VPC. Health check, I'm just going to use HTTP. Attribute, I'm just going to keep everything default over here. Then click on next. And here you can see these are the EC2 instances which we need to include within this particular target group. So select both the instances, include, and after that click on create target group over here. So here you can see our target group has been created. So if you go and take a look onto the diagram, so if I go back, so yeah, so here you can see our target group is now including our EC2 instances. Let's move ahead, and the next step we will be creating our network load balancer. So here, if we go and take a look onto this diagram, then here we have achieved this far, like target group and this networking setup along with our EC2 instances. Now we need to set up our network load balancer, but here in the diagram you will see I have created ALB, which is application load balancer, and network load balancer. We are going to see the differences between both the two. But first let's set up the network load balancer. So let's ignore this arrow as of now and just focus on this network load balancer here. So this network load balancer should point to this target group which we have just created. So now the task is we need to set up our or create our network load balancer. So let's go back to our AWS dashboard over here and go to EC2 dashboard. From the left navigation menu, click on the load balancer over here. Click on create load balancer, and here you will find the option for application load balancer and network load balancer. And I have already covered the application load balancer in previous sessions, so just go and check those sessions if you are interested in application load balancer. But let's just go and create our network load balancer first. So click on create over here, and in the load balancer name, just type the name whatever you feel comfortable. So I'm just going to put demo network load balancer. Okay, scheme is internet facing, IP address 5 is IP4, and the VPC. So I'm just going to choose demo NLB VPC, and then I just need to choose the availability zone. So I'm just going to choose 1A, and here I'm just going to choose the public subnet, and also the 1B, and here I'm also going to choose the public subnet. Okay, so these are the minimum requirement which you need to fulfill. And then security group, so I'm just going to stick with default, but later if we need it, we are just going to modify the security groups for this particular load balancer. All right, so here this is important, the listeners and routing. So now we have created our target group, and now we need to map. So if you take a look onto the diagram, so I'm talking about this arrow, sorry, not this one, but if I'm just talking about this NLB and this EC2 instance. So this NLB is pointing to this target group. So if you go and select from the drop down, then you will find the NLB demo target group which we have just created. So select this one, and if you go down, then AWS Global Accelerator. We are just not going to include that one because we are just doing it for demo. And here you can see the details like basic configuration, security group, network mapping, VPC, subnets, and this our target group and listeners. So everything is ready, and then just go ahead and create a load balancer. And here we have just created our network load balancer, and click on load balancer over here and close this one, and it is into provisioning state. So it will take a couple of minutes to provision this particular load balancer. I would like to take a pause over here. So if you are liking this kind of a session and if you want more of this kind of a session, then I would highly encourage to subscribe to this channel, because I see into my YouTube analytics that you guys are watching this video but you don't consider subscribing it. So it will be a really boost for me if you consider subscribing to this channel, because that really helped me to and keep me motivated to prepare this kind of a session. And also, if you are interested into more premium content and you want to be a part of my community, then please consider joining my YouTube community, where I will be with you on a Discord group, and where you can just chat with me and send your messages. And also there are some private sessions which are there for my community members, which are not available here onto my YouTube channel. So consider subscribing to those also. Let's continue with our session. Alright, so now my network load balancer is up and running. Here you can see which is into active state now. So click on this network load balancer over here, and here copy this DNS name, go to new tab and paste it over here. And as you can see, it is not accessible because I am doubting that there is a security group for port 80 which we need to enable. So again, go back to network load balancer, go to the security setting and check the security group, which is this one. Click on the security group and go to edit inbound rule, and here you can see there is no incoming rule allowed for port 80. So click on add rule, go to HTTP over here and set the port 80 and select 000 so that anyone can access this particular URL of our network load balancer. Okay, then click on save, and now our rule has been added. So if I go to the tab, and here you can see it is accessible now. If I zoom it over here, so it is now pointing me to my instance homepage. Okay, so if I go and put a foo over here, then it should point me. Here you can see this is our foo from demo EC2, and if I go with a bar, then it should also show me the EC2 instance, although it is redirecting me only to the EC2 instance. But in a nutshell, my network load balancer is up and running, and now we are able to navigate, or we are able to access our EC2 instances. Alright, so now till now we have set up our network load balancer and we are able to access our EC2 instances and foo and bar URL. But the key difference, which I have been telling since from the beginning of this particular session, is like we cannot set up some specific URL based rule with our network load balancer. So what does it mean? So for that, we need to set up our application load balancer. So now we are going to set up our application load balancer, and then you will see the difference between the network load balancer and application load balancer. Okay, so the next chapter which we are going to cover is our setting up our application load balancer. But before we jump to our AWS console, let's take a look onto the concepts and the differences. Okay, so till now we have covered this URL where we are able to access our NLB URL, which is our network load balancer URL. So if I go into this tab, so this is our URL which is for network load balancer, and if I change this URL, then it is redirecting me to the respective page. But if you take a look onto this network load balancer once again, then I'll close this one. So click on this network load balancer and then go to our listeners. This is the section. Click on add listeners. So here you will not find any rules which you can define for your URL patterns. What does it mean by the URL pattern? So for that, let's take a look onto the diagram. So here in the application load balancer, there are some URL patterns. Like if URL ends with foo and URL ends with bar, then it should put some rules over here, and then it should redirect to the respective target group. So that it's properly working for URL patterns. But in the network load balancer, it is not possible. It will only give you one URL, and that URL will redirect to the EC2 instances. So although we have set up the foo and bar HTML pages, but I need more granularity, and I can set up this rule from the URL itself into load balancer. So it can direct that request to the target group. So that's the difference or the feasibility we have in our application load balancer, where we can put some rule patterns on the URL parameters which are coming in our request. So here, if it comes into as a foo, then we'll forward that request to the foo target group. If it is coming with a bar, then we'll target that request to our bar target group. So that's only possible with our application load balancer, and it is not possible with our network load balancer. So now let's try to set up our application load balancer. Okay, so I'll go back to my AWS dashboard once again. So here, go to the home page, and before that we need to modify a few things onto our EC2 instances, which I'm just going to show to you. So I'll open a notepad over here. So I'll just give me a second, and I think this is good. So here, this is my notepad over here. So right now we have EC2 1 instance and EC2 2 instance, and both the instances have foo as well as bar folder with their respective index.html page. And here also the same pattern is there, because we are having foo and bar HTML page. Okay, but now what we need to do is to define the URL pattern filter. I'll just go to EC2 and I will make it only foo, and here I will only create a foo folder, and inside that folder I'm just gonna create a index.html. So this EC2 instance will be our foo instance, and same I'll just do with the EC2, where I'll just create it as a bar instance. So here I'm just going to do EC2, I'll just put bar, and here I'm just going to create a bar folder, and here I'm just going to put an index.html. So that's the difference I'm just going to create between these two EC2 instances. And then we are going to create a target group for this instance. This is a one target group for this instance, which is like a target, let's say foo. So this is going to be a target group for foo instances, and this is going to be a one more target group for bar instances. So I'll just put target, and then I'll put a group, and then it should be bar. So now we will create two target group, and then finally we are just gonna create an application load balancer. And application load balancer, we are just going to define rules, and in that rules we are just going to define if it's coming with the foo URL, then just use the foo target group, and if it is coming with, I'm just going to copy the same thing, and if it is coming with a rule like a bar, then just point to the bar target group. Okay, and this will ultimately lead you to the EC2 1 over here, and it will lead you to the EC2 2 over here. So this is the next thing which we are going to implement, but this whole thing is not possible with our network load balancer. So that's the key difference which you need to keep in mind. Okay, but there are other differences also, but this is just a one prominent one which is easy to understand the differences between these two load balancer. Okay, so let's go back to our dashboard and start modifying those index.html pages. All right, so this is my home page of my AWS. So I'll go to EC2 over here, and I'll go to instances. I'll first rename this one. So I'll just put it like a foo, and sorry, I didn't put foo over here, and here I'm just gonna put bar. Okay, so I just renamed it. So let's go to the foo over here and copy this public IP address. I'm just gonna open my terminal over here. I'll clear it. I'll exit it first of all, clear it, and then just use the IP address to SSH into. And now I'm into my foo instance. I'll just clear it, and then I need to go to the directory var www.html, and then enter ls, and let's check again. So I am into, let me check, verify once again. So I'm into the foo instance right now, 373.11.1.105. So I am into foo instance, just to reconfirm. And okay, so what we need to do, we just need to remove the bar instance. So I'm just gonna run the command rf, and I'm just gonna remove bar. Okay, so I have removed this one. Then I need to restart my Apache systemctl and restart Apache 2. And now I have restarted my system. So let's verify from my public IP that I'm not able to access the bar page. So just hit enter. So yeah, this is accessible. I'm just going to refresh it, and then I'm just going to check with foo. Yeah, it is accessible. Demo to EC2. Let's check with bar, and now it should not be accessible. So it is not found. Okay. So now we have fixed our EC2 instance, which is our only foo instance now. Okay. And I'll exit it from here. Then again go back to the another instance, which is our bar instance. Click on it, copy the public IP address, go to terminal, clear the screen, and this is the SSH command. So I'm just going to change it to the IP address, clear it, and let's go to the directory. So change it to the var www html. And here I'm just going to delete the foo folder. So I'm just going to use sudo rmrf, and then here I'm just going to delete foo. Okay. And after that, I just need to restart. So I'm just going to run sudo system ctl restart apache 2. Okay. So now I have restarted it. Let's verify it. Go to the public IP and go over here, close this one, open it again. And here you can see I am onto the home page. Let's access the bar first of all. And here it is accessible on the EC2, but the foo should not be accessible over here. And here you can see the foo is gone. So now we have set up our EC2 instances. One is foo instance, one is bar instance. And now we need to create a target group for these two instances. Let's go back to our AWS dashboard once again. On the left navigation menu in the load balancer, create a target groups over here. This is the previous target group. I'm just going to create a new target group for EC2 instances. The name, I'm just going to keep it like foo target group ALB for application load balancer. Port HTTP, that's okay. And the VPC, I'm just going to choose demo NLB. Health check, I'm just going to keep it default. Click on next. And from here, I'm just going to select the foo. This is the foo instance, and then include it as a parameter below. And then click on create target group. Okay, so this first one is created. Let's go back to one more. I'm just going to copy the name just so that I just don't need to write it again. So again, I'm just going to create it for instances. And here I'm just going to put bar and port HTTP. That's fine. IP4, VPC, I'm just going to choose demo NLB. And after that, just click on next. And here I'm just going to include our, let me check. Go previous, which one we are creating. So we are creating a bar target group, so we need to include bar instance. So click next over here, click on bar instance, include as pending below, click on create target group. Okay, so let's verify the target group. So here you can see we have a foo and bar target group created, and now we need to create our application load balancer. So here from the left navigation menu, click onto the load balancer over here, close this section, and just click on create load balancer, and then select now application load balancer. Click on create and the name. So let's choose ALB foo bar LB load balancer, or maybe I can keep it foo and bar load balancer. I think that would be good. Foo bar load balancer, internet facing IP4, that's okay. VPC, I'm just going to choose demo NLB VPC. And availability zone, I'm just going to choose public, and here also I'm just going to choose public, that's okay. Security group, I'm just going to keep it default, we'll modify it later. And target group, so here we need to choose the target group. So first of all, let's choose any target group at the moment, because we will be setting up this listener rules later also, because this setup will only create a load balancer. Or maybe let's go ahead and try to create without a target group, because we need to set up those foo and bar URL based rule. That's why I'm saying. Okay, so everything is done over here. Then click on create load balancer. Oh, it's not allowing me. So just select one. So let's go with the bar and then go ahead and create a load balancer. Just select randomly the target group for this particular setup. Okay. So I'll just wait for a minute so that this particular foo bar load balancer is up and running, and then we'll start setting up those custom rules. Alright, so now my load balancer is up and running. So click on this foobar load balancer, and here into the listeners and rules section, then we need to modify this particular listener rule. So click on this one, and here click on add rule over here. So first of all, let's put the first rule for foo, and then click on foo rule, and then click on next, click on conditions, then click on condition, select path, because we need to specify a path. So I'm just going to choose foo. If URL ends up with the foo, then it will redirect it to the foo instances target group. Click on confirm, go next. Target group, so where we need to forward, so I just need to forward it to the foo, and wait one, that's okay. Click on HTTP, select HTTP, that's also fine. Then click on next. Priority, I'm just going to put it to 1 over here, and after that then click on next, and then click on create. Okay, so the foo rule has been created. Let's go back to foobar load balancer, then go to listeners over here, and here you can see the foo rule. Then click on add one more rule over here, then click on bar, then bar rule would be nice. Click on next, add condition, then click on path, put bar over here, click on confirm, click next. Target group, I'm just going to select with the bar, then click on next. Priority 2. It's just a random thing, you just need to assign the priority over here, but try to assign the priority which is like a high, low, low, and low. So here I'm just gonna assign 1, 2, and there is a default rule. If nothing, then it will just forward it to the home page. Okay, click on next, and then click on create over here. And now both the rules has been created for us. Okay, so now we need to verify these rules. So go to load balancers over here, then click on this DNS name and go to the URL bar and type bar over here and hit enter. And here you can see we are getting redirected to our demo NLP EC2 instance. So that's quite evident that now we have a 2 target group, and once we are accessing our load balancer and that has a URL ending with a bar, then it will redirect us to the demo NLP EC2 instance, which is our bar instance. And similarly, when the URL is ending with the foo, then it will redirect me to the EC2 1 instance, which is my foo instance. So with that, I have shown you like how to set up your application load balancer, how to set up your network load balancer, how to set up your rules for foo and bar, which is possible only with the application load balancer, and how to use your network load balancer. But I haven't talked about like what are the advantages of our application load balancer and our network load balancer. So these are some few arrows which I forgot to show it to you. But anyway, let's go ahead and talk about the advantages and disadvantages and how these works internally. So application load balancer work on the layer 7, and our network load balancer works on our transport layer, which is layer number 4. So in the layer number 7, we are having the protocol which are supported like a WWW, HTTP and HTTPS. But for transport layer 4, we only support TCP, UDP. That's why we were not able to set up those HTTP custom rule like a foo and bar rules which we have set up for application load balancer. So that's the main reason why application load balancer supports HTTP URL pattern but not network load balancer. So yeah, these are the few points which you can see onto the screen which we have just covered, and also these are the URL pattern which we have also seen. Apart from that, what are the other key differences? So application load balancer, path-based routing, TLS support, and also you can configure your WAF like web application firewall, which is available into AWS with your application load balancer. So with the help of application load balancer, you can achieve these tasks. But in the network load balancer, what you can do is it's like ultra low latency load balancer. So if you have an application where millions of requests are landing onto those particular application, then I would recommend you to use the network load balancer because it has a high throughput time. But also remember that you need to in such some of the cases you need to specify the static IP for your network load balancer so that you can point to that network load balancer as well. So these are the few differences which I would like to mention along with the current session which we have just performed. So I hope with that your application load balancer as well as network load balancer concepts are a bit clear, and if you have any question then please put down into the comment section. See you into the next session of our DevOps and AWS. Till then, take care and bye-bye. In this session, we are going to set up the AWS Web Application Firewall along with the application load balancer to access the EC2 instance. Also, we are going to see how to allow and block the traffic coming to EC2 instance using the Web Application Firewall rules. As you can see over here, this is our VPC, and inside the VPC we are having a subnet, and inside the subnet we are having an EC2 instance. So first we are going to create a VPC, then subnet, and then we are going to create an EC2 instance present inside our public subnet. So let's jump to the AWS console and start setting this up. So here is my AWS console, and in the search box type VPC because we want to create a VPC. So here onto the VPC dashboard, click on create VPC. And here you need to select the options for creating the VPC. So we are just going to select VPC only. You need to put the name. So I'm just going to put test VPC. And in the CIDR range, we need to specify the IP ranges. So I'm just going to put 12.0.0./16, which means we will have around 65,000 IP address possible within our VPC. Next thing, tenancy, we are just going to keep it default. Tags, we are just going to keep it default and simply click on create VPC. And here you can see our test VPC has been created. So click on your VPCs and here you will be able to verify that our test VPC has been created. Moving ahead, the next thing which we need to create is the internet gateway so that we will have an internet access available for our VPC. So here you can see onto the diagram, this is the internet gateway which we need to create. Alright, so here is my AWS console. In the left navigation menu, you will find an option for an internet gateway. So click on it and here click on create internet gateway. And here just put the name. So I'm just going to put internet gateway IGW, which is an abbreviation. And then I'm just going to put test. And after that, click on create internet gateway. And here you can see our internet gateway has been created. But this internet gateway has not been associated with the VPC. So what you need to do, you just need to click on action attached to VPC. And here you just need to search for the VPC which we have just created. So click on it and click on attach internet gateway. So now if you take a look onto the diagram once again, then here you can see we have created a VPC and we have attached the internet gateway to get the internet access inside our VPC. Alright, so after creating the internet gateway, the next thing which we need to create is the subnet. So again, go back to our AWS console and here in the left navigation menu under the VPC dashboard, you need to click on subnets. So here, these are the default subnets. So we are not going to use the default subnet. We are just going to create our own subnet. So click on create subnet. Here, first of all, we need to choose the VPC. So we have just created a test VPC. I'm just going to select that one. And here we need to enter the subnet name. So I'm just going to put the name. So here, this is test public subnet 1A. I'm just going to explain why we are using 1A. So that is because we are just trying to define the availability zone. So I'm just using the EU Central 1A. That's why I have suffixed with the 1A so that I can identify which availability zone subnet is. So I'm just going to select this subnet, and after that we need to select the IP ranges which is available for our subnet. So I'm just going to copy the IP range from my notepad and paste it over here. So here you can see I have just put 12.0.1.0/24, which means I will have a 256 IPs available for my subnet. Alright, so first subnet we have created, we just need to create one more subnet into the different availability zone. So I'm just going to click on add new subnet. I'm just going to copy the name from the top. I'm just going to put the same name, but I'm just going to change it to 1B because I'm just going to select a different availability zone for it. So select the different availability zone, which is 1B, and here I just need to enter the IP range. So I'm just going to copy the IP address and I'm just going to change a bit and make it 2 over here. Alright, so now we have created the 2 subnets over here, and then after that just click on create subnet. And here you can see our subnets has been created. After creating the VPC, internet gateway and subnet, we need to create a route table so that we can connect the internet gateway to the route table and subnet can access the internet. So for that, let's go back to our AWS console over here, and in the left navigation menu, you need to search for the route table. So here you will find the option route table just below the subnet. And here are some of the default route table, but we are not going to use those one. We are just going to create a new route table. So click on create route table, and here just enter the name. So I'm just going to put test public. Public I'm using because this is a public route table which will have access to internet. And I'm suffixing with the RT, which means this is a route table. Then we need to select the VPC, and the VPC which we have created is the test VPC. I'm just going to keep the tags default and just click on create route table. Alright, so now my route table has been created. But if you take a look onto this diagram, then we have just created VPC, Internet Gateway, and Subnet and route table. But this route table is not associated with this particular subnet. So what we're going to do, we are just going to associate the route table with subnet. So for that, click on Subnet Association, Edit Subnet Association, and here you will find the subnets which we have just created. These are public subnets. So I'm just going to select all of it and save association. Now this test public route table is now associated with this public subnet, but still this route table or this particular subnet still not have an internet access, and for that we need to create a route. So click on edit routes over here, and here click on add routes, and here you need to choose 000, which means anyone within the subnet can access the internet, as well as anyone from outside of AWS will be able to access those resources present inside the subnet. So that's why I'm just using the 000, which means from anywhere. Alright, so here we need to choose the internet gateway, because this is internet gateway is responsible for providing the internet access. So we need to choose the internet gateway, and here you will see the name which is we have created for internet gateway, that is test internet gateway. I'm just going to select that one and click on save changes. And now you can see our test route table has been created, and now we have associated with the subnet with the internet access. Let's take a look onto the diagram once again, and the next resource which we need to create is the EC2 instance. We have already created the VPC, internet gateway, subnet, and the route tables. Alright, so here is my AWS console. In the search box, type EC2 over here, click on EC2. And here you will find an option for a launch instance, so click on launch instances. Here just enter the name, so I'm just going to put test EC2 AWS WAF demo. This is the name of my EC2 instance. The next thing which we need to choose is the AMI, which is responsible for a base operating system. So I'm just going to choose Ubuntu over here. After that, you need to choose the instance type, whether you're going to choose t2.micro, t2.small, or t2.large. So I'm just going to stick with t2.micro for demo purpose. The next thing which we need to choose is the key pair. We need to create a new pair. So I just going to click on this create key pair, and here I'm just going to type AWS WAF EC2 demo, and it will just create a key pair for me. And remember, here I have downloaded this key, and this key is our private key, and which we are just gonna use to SSH into our EC2 machine later. But here you will see this is our public key, which has already been associated with our EC2 instance. And the same key you can also find it over here if you go to the EC2 dashboard, and if you click on key pairs, and here you can see this is the key which has already been associated. This is our public key. Okay, so now we have created the key pair. The next thing which we need to do is we need to modify the network setting, because we need to change the VPC and subnet. So click on edit, and here choose the VPC. So I'm just going to choose the test VPC, because that's the VPC I have created. And after that, we need to choose the subnet. So we have created two subnet, that is 1A and 1B, which is in Europe Central Zone. So I'm just going to choose 1A, and it doesn't matter which one you want to use. So we are just going to create one EC2 instance into one subnet. Auto assign public IP, so I'm just going to select enable. I just want to have a public IP address for my EC2 instance, and after that we just need to create the security groups. And here we are just going to create two security groups. One is for SSH, to enable the SSH onto the port 22 as you can see over here, and then we need to create one more for port 80. So I'm just going to choose HTTP over here, and the port is 80. Source type I'm just going to choose from anywhere, so that anyone from anywhere can access this IP address and can access the home page of my EC2 instance. And later we are going to install the Apache for that. Okay, so now we have created the security group. The next thing which we need to choose is the disk size. So I'm just going to stick with the default, which is 8 gigs. That is quite okay for the demo. And in the advanced detail, we are just going to write down some script into the user data so that we can install the Apache server onto our EC2 instance. So this is my user data section, which you can see over here. And here I'm just going to copy the script from my notepad to install the Apache. I'm just going to explain that one also to you. So here I'm just going to update the package manager. Here I'm just going to install the Apache. And here I'm just going to update the public HTML page or the index HTML page of my Apache, where I'm just printing the host name and the IP address of that particular host name so that I know that my request is landing on which host. Okay, and after that it has installed the Apache. I'm just going to restart that particular Apache, and everything will happen when it is going to start and setting up our EC2 instance. So click on this launch instance button over here. And it might take a couple of minutes to start our EC2 instance. So here you can see our EC2 instance has been provisioned, and go to EC2 dashboard. Click on instance running and remove this running filter over here. And here you will see the instance state is pending. I'll be back once this instance state changed to running. And here you can see our EC2 instance is running. So click on this instance ID to verify a few things. And here you just need to copy the public IP address, go to new tab and hit enter. And here you can see this is our default home page of my Apache, where you can see the host name along with the IP address. Let's take a look onto the diagram once again. So now we have done with the setup of a VPC, Internet Gateway, Subnet and EC2 instance. The next thing which we need to create is the application load balancer, which is sitting in the middle. So for that, let's go back to our AWS dashboard, click on this home page. And here into the EC2, we just need to click on EC2 dashboard once again. And at the bottom, you will find the option for a load balancer. So click on it. But before creating a load balancer, we need to create a targeted group. So here in the load balancer, you will find one more option, which is a target group. So click on it. But here is a little brief about the target group. You cannot create an application load balancer standalone to point to your EC2 instance. You just need to create a target group, and then you need to include the EC2 instances into the target group. And then later you just need to point the application load balancer to the target group. So first let's take a look how to create our target group. So here just click on create target group over here. And here you just need to choose the instances, because we are just gonna use the EC2 instances inside our target group. Go ahead, and here you will find the option for creating the target group name. So I'm just gonna put target group EC2 instances. The rest of the details you just need to keep default. I'm just gonna stick with the HTTP protocol port 80, and I'm just gonna need to choose the VPC also over here. So here I'm just gonna choose test VPC. Protocol version HTTP1, that's fine. Health check, I'm just gonna stick with the default one, and after that I'm just gonna click next. And here you can see this is the EC2 instance which we have just created. Here you can see the name of it. So you just need to select this EC2 instance, include as pending below, because this is the target group which we are creating, and now we are including our EC2 instance within this target group. And here you can see our target has been created with our EC2 instance, and then after that you can click on create target group. And here you can see into the target group, our target group has been created. The next thing which we will do, we will just create our application load balancer. So for creating the load balancer, just copy this target group name from here, because we will need it over there. Okay. So in the left navigation menu, click on load balancers over here. Click on create load balancer, and here you will have three types of load balancer, which is application load balancer, network and gateway load balancer. But we are just going to use the application load balancer. So click on create over here, and here you just need to specify the name. So I'm just going to choose LB for load balancer, and then I'm just going to use WAF demo. After that, we need to select internet facing. Yeah, I want internet facing, and I am just working with the IP4. I'm not using IPv6, so that's why I'm just going to choose IPv4. And here we need to choose the VPC. So we have created a test VPC. And after that, the subnet. So this is the VPC, and these are the subnets which I have created. I'm just going to select both of it. And then we need to select the security groups. So here the default is already created, but we need to create one more security group. So I'm just going to click on create new security group over here. And this security group is responsible for allowing the HTTP request on a port 80 for our application load balancer. Otherwise, we will not be able to access our EC2 instance on a port 80 with HTTP request. So here I'm just going to put security group name AWS WAF demo SSH and HTTP request. So I'm just going to allow SSH and HTTP. I'm just putting description over here, HTTP requests. All right. Test VPC, I'm just going to change it and I'm just going to use test VPC over here. So be careful. Just don't change and don't stick with the default VPC. Otherwise it will not work. Add rules. So I'm just going to choose SSH first of all and from anywhere. That's fine. And then again, add one more rule. And here I'm just going to choose HTTP port 80 and it's also from anywhere. So anywhere from anyone can access the port 80 as well as can SSH with the proper key into our EC2 instance. All right. So that's done. Create security group over here. But before that, I'm just going to copy this name also from here and create security group. There seems to be some error. Okay, so I cannot use the SG as the abbreviation over here. So I'm just going to use this security group. And I'm just going to copy this name. So I'm just going to click on create security group. So here you can see our security group has been created. So just close this window and I'll just make sure I have copied this name. I'm just going to close this one. I'm just going to refresh this load balancer. And here I'm just going to put the name. So here you can see our name of our security group. Select that one, go ahead, and here listener and routing. This is important because I have just shown you like how to create our target group, and inside the target group include your EC2 instance, so which we have already done. Now we need to target our target group. So here just select the target group which we have just created. So here I have just selected the TG, that is target group EC2 instances. All right, so the rest of the details, I'm just going to keep everything default over here. I'm just not going to change here anything. And these are the brief summary about our network settings, like how our load balancer going to look like with the subnet, network mapping, and the listeners and the routers. All right, so create load balancer and view load balancer over here. And here you can see it is provisioning. So it might take a couple of time for this particular load balancer to provision. And then we are just going to create our AWS web application firewall. All right, so my application load balancer is up and running. So let's verify a few things before moving ahead. So click on this load balancer and here you will find a DNS name. So just copy this DNS name and go to the new tab and paste that URL. So here you can see the home page. Now we are able to access our EC2 instance Apache home page using our application load balancer. And here is the IP address. This is the private IP address of my particular EC2 instance. Moving ahead, the next thing which we need to create is the application firewall. So let's go to the AWS homepage over here. And in the search box, type WAF and you will find an option for a WAF and shield. So click on it. And here, this is the default homepage for our web application firewall. So here on the left hand side, you will find the option to create a web ACL, which is we are going to create now, and also the IP set, which we are also going to see. So first of all, let's see. First, try to create our web application firewall. So either you can click on this web ACL link on the left navigation menu, and here's some of the things which you need to pay careful attention. So here, first of all, you need to change the region. Although this web application firewall is a global resource, it's not bounded to any specific region, which you can see over here. All of them are grayed out. But here you need to choose the region because you need to identify for which region your resource belongs to, for which you're trying to apply this web application firewall. So I'm working into the Europe Central region. So I need to choose over here Europe Frankfurt. And here you can see it has changed the region, and now we need to create our web application firewall. So just click on create web ACL. And here we need to key in some of the details. So I'm just going to put the name. So AWS WAF demo EC2. So this is the description I have put in. And the next thing which we need to check over here is the regional resources. I'm just going to stick with the default, and the region, again, just recheck over here. Are you working in the same region? So here I'm using the Europe Frankfurt because that's the region I'm working. Now, after creating the, not after creating, but when you are creating the web application firewall, now you need to attach the load balancer. So here you need to attach the resource or add AWS resource. So if you take a look onto the diagram once again, then here you can see our application load balancer, which we have already set up. Now we need to set up the AWS web application firewall. So here, go back to your console, add resources. And here you will find an option for an application load balancer. So select this box, and as soon as you will select, then you will find the load balancer which we have just created. So select this one, click add, and click on next. The next thing which you need to set over here is the add rules in a rule group. So this is important because in this scenario, what we are trying to test is we are just trying to block the access of my particular laptop. So any request coming from or originating from my laptop should be blocked. So that we are going to test it. And later on, we are just gonna allow that particular request also. So for that, we need to create a rules over here. But to create the rule, what you need to do, you just need to go to the IP set. So in the left navigation menu, here you will find the IP set. So click on it into the new tab. So here you can see this is the IP set. So here is a little brief about the IP set. So this is just a logical IP sets where we are just gonna put our IP addresses which we want to block it. So here, just click on create IP set and put in the name. So I'm just gonna put my laptop IP. And here the region should be Europe Frankfurt, and after that you need to enter the IP address. So for that, what I'm just going to do, I'm just going to Google my IP address, or I can just search for find my IP address. And here you will find here you can see the IP address which has been given to you. Just copy this one, go to your IP sets over here. And here just enter the IP, but just be careful, you need to enter the range, not just the IP. So here I'm just going to suffix it with 32 so that any IP which belongs in this particular range will be blocked. All right, then click on create IP set over here. And now you can see my laptop IP set has been created. Okay, so let's go back to our web application firewall where we were just trying to create add rules. So here in the drop down, just now select the add my own rules and rule groups. And here you will find an option for an IP set. So just select this IP set because we are just testing with the IP. Although the same thing which I'm doing, you can achieve with the security groups, but this is just a demo and I'm just showing the capability of a web application firewall. Here you will find other option like a rule builder and rule groups. So where you can go more granular and more complex validation. So you can just even go for like a request header. What are the parameters which is coming in, and you can block the request on those basis as well. But just keep the thing simple. I'm just going to use the IP set, just rule name. So I'm just going to put block my laptop access. So this is the rule name, I'm just putting it. So in the IP set, you will find the my laptop IP set, which we have just created. So select that one. Source IP address, yeah, I'm just going to go with that. And action. So what I'm going to do, I'm just going to block the access for my request. So any request which is going via my laptop or with my laptop IP will be blocked. After that, click on add rule. And here you will find this is the rule which we have created. So select that one, go further, and the default action will be, so these are the default action. It will allow requests to come in, but it will also validate that request inside this particular rule. So here you will find, it will find the IP address. So that's the basic nature of this web application firewall. All right, so click next over here. And here, this is the rule I just wanted to select, click next. And I'm just going to go with the default thing. So it is asking for a CloudWatch matrix. So I'm just going to stick with the default name. And this is the name of my CloudWatch matrix if you want to see the logs into the CloudWatch. All right, click next. And I'm just going to stick everything with the default. I'm not going to change anything. And I'm just going to go at the bottom and click on create web SEL. And it might take a couple of minutes to create the web application firewall. So I'll be back once this is ready. Alright, so after a couple of minutes, my web application firewall has been created, and as you can see, this is the success message, and we just need to verify a few more things, whether all the resource has been attached properly or not. So first thing, click on associate AWS resources, and here you can see the load balancer, so that your load balancer and web application firewall are attached to each other. Otherwise, there will be a problem and your web application firewall rules will not work. So that's the first thing you need to check. And second thing, you also need to check about the rules. So this is the rule which we have created, and inside that rule you will find the IP set. So this is the IP set, which is my laptop IP, and inside that I have blocked this particular IP address. So these are the few things which you need to verify. Okay, so now if you take a look onto the diagram once again, so now we have a web application firewall also ready, and now we are blocking this user's request, and in this case this user is me, and I'm just applying this IP address, which is my laptop IP address, to be blocked. Okay, so let's try to access the application and see how it behaves. So I'm just going to go back to my browser. I'm just going to close everything. I'll just go to load balancer URL, because that's how we are just going to access it. So click on EC2 over here. In the left navigation menu, click on this load balancer. Click on this load balancer URL, and here you will find the DNS name. So copy this URL, go to new tab and paste it over here. And here you can see 403 forbidden. Now we are able to block the request using the web application firewall. So now I cannot access the home page of my Apache, which is running inside my EC2 instance, which is running behind the load balancer. So here you can see, if you compare with the diagram, so this is the user which is trying to access this EC2 instance Apache homepage, but it has been blocked at the web application firewall level. All right, now let's try to change the things once again. So again, I'll go to home page, and here I will just look for WAF and Shield. Go to WebACL, select the region, again Europe Frankfurt, and then you will see your web application firewall. So here you can see, click on it. And here you can see the requests which has been blocked, which are coming through IP, which I have already blocked using the rules. So I will just change a few things over here. So go to the rules, click on this rule, and I will just select the edit rule over here. And here I'm just going to select allow. So now I'm just going to validate allow thing. So save the rule. I need to select on save also. So select save. Now I have saved it. So here you can see the action is allowed now. So previously I have not saved it. That's why it was not allowing me. So now refresh it once again. And here you can see, now we are able to allow that particular request to go in. And now I am able to access that particular page. So that's quite a few tests you can do. And also one more thing I could show you. So again, go to the rules and click on this edit rule. And there are a few more options which you can see over here, that like allow block we have already tested. So we can also enable the CAPTCHA. So let's enable the CAPTCHA and click on save rule, and then select this one and click save also this one. And now we have saved this one also. So let's refresh that page once again. And here you can see this is the CAPTCHA. I will zoom out a bit, and let's confirm you are a human. So let's begin. And here you can see this is the CAPTCHA, which you can see. Please place a dot at the end of the car's path. So here you can see, and click submit. Anyway, it was just a puzzle. I don't want to solve it right now. So that's how you're going to set up your AWS web application firewall with your load balancer. And with the load balancer, you can have any resource running behind the load balancer. I hope you liked today's session on how to set up your web application firewall. In the next session, we are going to try out VPC peering. We are just going to create 2 VPCs, and then we are just trying to set up a connection between those 2 VPCs so that they can communicate with each other. So see you into the next session of our DevOps with AWS networking. Till then, take care and bye-bye. By the end of this session, you will know how to set up your VPC pairing between the 2 VPCs, and also you will know like what are the benefits of using the VPC pairing. Let's start with it. So here you can see onto the screen. So first of all, this is our AWS account on which we are going to set up this whole demo. So we are going to create 2 VPCs. On the left hand side, you will find a test VPC 1, and on the right hand side, you will find a test VPC 2. These 2 VPCs are separated with each other. And here inside that VPC, we are going to create subnet, and inside the subnet, we are going to provision an Linux machine, which is going to be our EC2 machine. And similarly on the other VPC, which is the VPC2, where also we are going to create our subnet and EC2 instance. And after that, we are going to set up a VPC peering. So here you can see a purple icon for a VPC peering. And once we set up this VPC peering, then this EC2 instance from test VPC1 will be able to communicate with our test instance present inside our VPC2. Here is my AWS console. So let's start first creating the VPC. So in the search box, type VPC, click on VPC. And here you will find the option to create VPC. So click on it. And here you will find the options to create a VPC. So first of all, select the VPC only. We just want to create a VPC, and here we can put the name like a test VPC1. CIDR range. So this is going to be the IP range which we are going to allow inside our VPC. So I'm just going to put 12.0.0.0/16. So which means I will have around 65,000 possible IP addresses within my VPC. Tenancy, I'm just going to stick with default, and I'm just going to click on create VPC. So this is going to be my first VPC. And similarly, I'm just going to create a one more VPC like test VPC2. So click over here. So I'm just going to enter the name test VPC2. And here I'm just going to enter the CIDR range. So here I'm just going to change 13 instead of 12 so that I can identify the IP ranges between those two VPCs. And after that, I'm just going to click on create VPC. And check if whether you have created those VPCs. So here you can see our both the test VPC1 and test VPC2 has been created. Now after creating the VPC, the next thing which we need to create is the route table. So we are going to create a two route table, one for test VPC1 and test VPC2, so that it can route the traffic to our particular subnet. So let's go back to our AWS console, and here in the VPC dashboard on the left hand side, you will find a route table over here. So here there are a few route tables which has already been created, but we are going to create our own new fresh route tables. So click on this create route table over here. So I'm just going to put test RT for route table for VPC1. And here we need to select the VPC. So I'm just going to attach this route table to VPC1. And after that, click on route table. I'm just going to copy the name and click on create route table. So this is the route table which we have created. I'm just going to create a one more route table for VPC2. So again, click on create route table. I have already copied the name, so I'm just going to change it to 2 and select the VPC. So here I'm just going to select the VPC2, and after that, just click on create route table. Now after creating the VPC route table, the next thing which we need to create is the subnet. So we are going to create two subnet both in VPC1 and VPC2. So here is my VPC dashboard onto my AWS console. So click onto the VPC dashboard over here, and here on the left hand side, you can also find the option for creating the subnet. So click on this subnet, and here you will find the default subnet, but we are not going to use those ones. So click on create subnet and select the VPC. So first of all, I'm just going to create a subnet for our test VPC1. So select this one, and here I'm just going to put the name. So I'm just going to put test subnet VPC1. And I'm just going to put 1A for availability zone. So here I will explain like what's the availability zone is. So here you need to choose, like I'm just going to choose Europe Central 1A, but select whatever closest regions nearby you. Alright, so I have created this subnet, and the IP ranges I just need to put in. So I will just copy this IP address range from my VPC, and I'm just going to put over here, and I'm just going to change it to 1, and here I'm just going to put it to 24. So here you can see now 256 IP addresses are possible within my subnet. This is a demo, that's why I'm just keeping the bare minimum things over here. Alright, so now we have created this first subnet. I'm just going to copy it because I will need it for creating another subnet. So I'm just going to click on create subnet now. And now you can see our test subnet has been created for VPC1. I'm just going to create one more subnet and select the VPC. So this time I'm just going to choose VPC2. Subnet name. So I'm just going to put in. So I will just change it to 2 and I'll keep it 1A. So because the availability zone I'm using it 1A. This is a demo, that's why I'm creating only one subnet, but in your actual project or actual application, you might need to create multiple subnet for multiple availability zones. So just keep in mind. Alright, so now I have created those, so I just need to specify the IP range for my subnet. So I'm just going to copy that range, and here I'm just going to suffix it with 1, and here I'm just going to choose 24. Alright, so just click on create subnet now. And I'll just remove this filter over here. So here you can see both the subnet has been created. I'm just going to put test and hit enter. So here you can see I'll just remove it anyway. So we are having two subnets now, which is for VPC1 and as well as for VPC2. Alright, the next thing which we need to do is we need to associate our route table with our subnet. So we have created the route table, we have created the subnet, but both are in a detached mode. So we need to associate both route table and the subnet. So for that, let's go back to our AWS console. And here, just click on VPC, go to the route tables. And here you can see our route table for VPC1 and VPC2. So I'm just going to select the first one, go to subnet association, click on edit subnet, and here you can choose the subnet for VPC1 and click on save association. So now I'll check the diagram once again. So now our route table has been associated with this particular subnet, but also in the route table, we need to grant the internet access. And for that, we need an internet gateway. So what we will do, we'll just go over here, and here we are having an option for an internet gateway. And here we are going to create a new internet gateway. So I'll just put test internet gateway for VPC1. Click on create internet gateway, and now our internet gateway has been created, but this internet gateway is not associated with our VPC. So for that, we need to attach the VPC. So here, as you can see, the name we have put it is for VPC1. So in the actions, go to attach VPC, select the VPC and select VPC1 and attach internet gateway. Alright, so let's take a look onto the diagram once again. So now we have the route table associated with subnet, and now we have created the internet gateway for this particular VPC. And now in the route table, we need to create a route for internet using the internet gateway, so that this subnet can be, any resource inside this subnet can be accessed from internet. Although I have mentioned this is as a private subnet, but this is going to be our public subnet. So that's a correction I would like to make it over here. Alright, so let's go back to our AWS console, and here this is the internet gateway, and go to route table now and open the route table over here. And as you can see, our subnet has already been associated. Go to routes now, go to edit routes, and here add routes. So here we will choose access from anywhere. So that's why I'm just going to choose this IP address, and from the drop down choose internet gateway, and here you will find the test internet gateway which we have just created. Click on it and click save changes. Alright, so now we are done with the VPC1, where we have, let's take the diagram once again, where we have VPC, route table, subnet, and route table is attached with subnet, and also internet gateway has been attached to VPC, as well as we have created a route table, a route entry inside my route table. And the same thing I'm just going to perform onto the VPC2 also. So for that, let's first create the internet gateway. So go over here, I'll just copy this name from here because I'm just going to keep the similar name. So click here for VPC2, and just click on create internet gateway. And now internet gateway has been created, but we need to attach it. So click on attach to VPC, and here select the VPC. So this is our test VPC2 for that, and click on attach internet gateway. Alright, so internet gateway has been attached. So let's go to the route table and check the association. So this is our VPC2 route table. Click on this route table ID. Click on first the subnet association. So here you can see there is no subnet associated. So click on edit subnet, select this subnet, click on save association. So now subnet has been associated. Now we need to make a internet route entry inside this route table. So click on edit routes, add routes. So here I'll choose anywhere from anywhere. So this is the IP address for that. Select the internet gateway, and here test VPC2 internet gateway. So select that one and click on save changes. Alright, so now our network part is almost done, and now we need to provision the EC2 instance in both the VPC. So I'll just go to EC2 dashboard and I'll just provision the EC2 instances. Okay, so go to your home page of your AWS console over here, and in the search box type EC2, click on EC2, and here click on launch instances. And here, first of all, we need to enter the name. So I will put VPC1 EC2 instance. And after that, I just need to choose the image. So I'm just going to choose Ubuntu as my image, and the instance type t2.micro. I'm just going to stick with that one. And here we need to, next thing which we need to do is to enter the key pair login. So I'll just create a new key pair over here. So click on create new key pair, type in the VPC1 EC2 key. So this is the name. I'm just going to keep it. So I'll just copy this name just in case. Create a key pair. And here you can see I have downloaded the private key with me, and the public keys has been associated with my instance. All right. In the network setting, now we need to attach to our VPC which we have created. So I just want this EC to be attached with my VPC1. So I'll just from the drop down choose VPC1. And here in the subnet, you can see the subnet which we have created, which is already selected. Auto assign public IP. So I just wanted to enable it because I just wanted to do the SSH into it. All right, the firewall security group. So here we have some security group already. So SSH security group is already there on a port 22. So which I wanted. I just wanted to have one more security groups for HTTP requests so that we can access the home page of Apache, which we are going to install it. So here it is on a running on a, we are allowing the port 80 actually. And here I'll just choose from anywhere. All right, so now security groups are done. So we have added for port 22 as well as for port 80. After that, I'll just skip the advanced network setting. I'll just stick with default. The storage, I want to have it 8 gigs. And in the advanced detail, we need to have the script in the user data section to install the Apache as an application inside my EC2 instance. So go over here. Here you will find the user data section. So I'll just copy a script from my notepad. So just give me a minute. So here I'll just copy the script and paste it over here. So what will happen, this user data section, it will just going to install the Apache when this is going to boot up my EC2 instance. So that's the purpose of this user data script. So here it is updating the package manager, here it is installing the Apache, and then here it is going to update the home page of my Apache 2 with host name. And then it is going to restart the Apache 2. It's that simple. All right, so let's click on launch instance. And it might take a couple of minutes to start. So I'll be back once it's ready. So here you can see the instance is in success. All right. So here you can see my EC2 instance is running under my VPC1. So I'll just click on this instance ID, copy this public IP address. I'll just paste over here to verify that I have installed my Apache server or not. So here you can see my Apache has been installed and this is the host IP. But for VPC peering, we are gonna do the SSH and then we are just gonna check a few more things later in this session. So before that, I'll just close this one. We just need to spin another EC2 instance. So if you take a look onto the diagram once again, so here we have set up this EC2 instance which is running, and now we need to set up this EC2 instance as well. So let's go back to our EC2 dashboard. So all the steps are pretty much same. The only thing I will change over here is to set up the different VPC2. So launch instances. And here I'll just copy the name from my EC2 dashboard so that I have a similar name over here. So this is the name. So I'm just going to copy and change it to 2. All right. So now the name has been changed. Select Ubuntu. Ubuntu as my base operating system. T2.micro. That's fine. And here I would like to create a new key pair. So I will just check the name VPC1 EC2 key. So I'm just going to choose VPC2. And what's the name of it? Here is the downloaded key. So from here I'm looking into the name. So EC2 key that should be good, I guess. And then click on create key pair. So now we have both the keys with us which has been downloaded. These are the private key which we will use later. After that, go to the network setting and here choose the VPC2 subnet, which is already selected because we have created only one. Enable public IP, click on enable, and the security group. So here I'm just going to enable SSH port 22, add one more security group, select from the drop down, go to HTTP, port 80, and it should be from anywhere allowed to access. That's done. Storage 8 gigs, that's fine. Advanced detail, we just want to install the Apache. So I'll just copy the script, go over here, paste it over here, and hit on launch instances. So I'll be back once this second EC2 instance is launched. Alright, so my both EC2 instances are up and running. So I will just access the EC2 instance running under my VPC2. I'm just going to copy this IP address to verify the Apache page. So here you can see our Apache has been installed successfully. All right, so now let's take a look onto the diagram once again. So our whole infra is ready, but we are still, we have not created the VPC peering. So the next thing which we will do, we are just gonna attach or we are just gonna create a VPC peering between these two VPCs. All right, so let's go back to our AWS console, close this everything, go to the home page, and in the search box type VPC, click on VPC. And here in the left navigation, you will find an option for a peering connection. So click on this peering connection over here. And here you can see there is no peering connection which I have created. So click on create peering connection. So here, first of all, we need to enter the name. So I will just name like a peering connection between VPC 1 and VPC 2. I'll just put a dash over here. So this is the name of my peering connection. Select the local VPC to peer with. So here I will choose VPC 1, and again the acceptor VPC, the other VPC which we want. So that is going to be VPC 2. All right, so that's we have selected. So this is my first VPC, and this is the second VPC, and this is my VPC peering connection name. And then after that, you just need to click on create peering connection. And here it will ask like pending acceptance. So what will happen, like whenever you create a peering connection, then the destination VPC should accept that peering connection. So here in the action, you will find the accept request button. So just click on accept request and click on accept request. So here you will verify the details. So requester VPC is VPC 1 from where the request is originated, and acceptor is going to be the VPC 2. And these are the IP ranges for those VPC. Okay, so I'll just click on accept request. And now you can see our peering connection has been established. So here you can see onto the diagram. So now we have established our peering connection. But there is one more thing which we need to set up before this whole connection works and we are able to communicate between those two EC2 instances. So the next thing which we need to set is the route table. So here it is showing you the message like VPC peering connection has been established. Now you need to modify my route tables now. So we need to modify our route table so that this whole connection between the VPCs works. So what we need to do, you just need to go to the route table first of all. And here we will open the route tables one by one. So I'll just open the first route table over here. And here into the edit route section, here we need to add one more route. So here, see, this route table is for VPC 1. So here you can see this is our VPC 1. So now from this route table, we want to go to the VPC 2. So for that, what we need to do, we just need to put the IP range of our destination. So here, if you take a look onto the VPC, so if you go to the destination, so I'll open both of it over here. So this is the VPC 2 and the IP range for this VPC is 13/0.0/16. So I'll just copy this range and go to this route table over here. This is our route table from VPC 1. In the edit routes, click on add routes, and here we need to enter the IP range of our destination. So this is going to be the destination because from VPC 1 route table, we are trying to connect to the VPC 2. So this is the destination, and the destination for that we need a peering connection. So here you will find the option for a peering connection, and here you can enter the peering connection ID over here. And after that, you can click on save changes. So this is the first side of it where we have set the destination to be VPC 2 IP address. So click on save changes, and we have updated this route table. So just close this one now. And then go to another route table, which is from VPC 2, and click on this route table, and here click on edit routes. And now we need add route, and here we will add the destination to be the VPC 1 IP ranges. So here, this is the VPC 1 and here this is the IP range. So it just work for opposite for here. So I'll just paste it over here, the destination, and here I will choose the peering connection. Here I will choose the peering connection, this one, and click on save changes. And here you can see our routes has been modified. All right, so the next thing which we will do, we will just SSH into the EC2 instances and try to curl each other from each EC2 instances. Let's go to the AWS homepage, go to our EC2 dashboard over here. I'll close all the tabs. And here both the instances, click on both the instances. And here just check the connect instructions for that. So this is the one EC2 instance. Let's start with our VPC 1 EC2 instance. Okay, so click on connect and here you will find the instructions. So this is the key which we have downloaded, and first of all we need to change the permission of the key to be readable. So just copy this command and go to your terminal over here. Just check the keys first of all, and here you can see both the keys are available and both have a read and write permission that we need to change. So first of all, run the command chmod 400 VPC1 and hit enter. And similarly, I will do the same thing for other key also for my EC2 instance. So VPC2, change it, and I'll clear it, ls lart, and here you can see both the keys are now have the read only permission. So first of all, we will just log in into our first EC2 instance, so which is going to be this one, VPC1, inside my VPC1. So this is the command to SSH. So I'll just copy this one, go to my console over here, I'll clear it, and I'll paste the command over here and hit enter. And it will ask, do you want to accept the connection? Type yes. And now we are into our EC2 instance inside my VPC1. I'll clear the screen over here. I'll just open one more tab. So I'll open it over here. So here you can see. So here on the left hand side, this is my VPC1 EC2 instance, and here this is the EC2 instance 2 from VPC2, which I will about to log in now. So go to your console, and this is the second tab. Click on connect, and here this is the command. We already changed the permission for that EC2 key. So go to terminal, type the command over here, type yes to connect. And now we are into the EC2 instance of my VPC2. Now, if our connection has been established successfully, then we should be able to curl our Apache page from other EC2 instance. So what we will do, so this is my EC2 instance from VPC1. So I'm sitting over here. I'll just go to my dashboard over here into EC2, and I'll just go to running instances, and I'll go to EC2 instance, and I'll just copy the private IP over here. And I just want to access this EC2 instance into my VPC2 from VPC1 EC2 instance. So here I'll just go over here, and here I will type curl and the IP, private IP address. And here you can see this is the message which we were getting over there. So now we are able to communicate within the VPCs. So we had two different VPCs, and now we are able to curl or access the EC2 instance running into another VPC. And similarly, here you can see the address that is 13.0.1.154, and right now I am into 12.0.144, which is my VPC1 IP range. And similarly, if I do the curl, but I need to know the IP address of my VPC1 EC2 instance. So go over here, go to instances, click this one, copy this IP address, and paste it over here, hit enter. And here you can see the message which we are getting, server details, and these are the IP address. Okay, let's test one more thing, and I will modify the route table, and after that I will not be able to access those EC2 instances. So for that, I'll just close everything over here and go to VPC, and here into the route tables, go to this first route table, and I will also open the second route table. And here into edit routes, just remove this entry, actually this one for destination VPC. So just remove this one, and after that you will not be able to access the EC2 instances from each other. And similarly into another route table, I'll just remove this entry for destination VPC. I'll just remove this one and click save changes. Now both the route table has been updated, and let's go back and let's do the curl one again. And here you can see the request is not going through, and similarly over here the request is not going through. So this is the VPC peering, and how you can establish the VPC peering between the different VPCs present inside your AWS account. I hope you liked today's session on a VPC peering, and if you are interested into the similar content, then keep following this channel. And also I have a premium content which is available onto my YouTube membership program. So please go there and join if you feel like joining those sessions. In this session, we are going to demo on how to set up a transit gateway so that multiple VPCs present inside our AWS account can communicate with each other. Let's have a quick look onto the setup. So here we are having an AWS account, and in this AWS account, we are going to set up multiple VPCs. So we are going to set up 3 VPCs, which starts from test VPC 1, 2, and 3. And each VPC, we will have a subnet, and inside the subnet, we will spin an EC2 instance. So once we're done with the VPC setup, then we are going to set up a transit gateway, and then this transit gateway we are going to attach with each VPC. After attaching the VPC, we are going to perform a test where we are going to access one of the EC2 in one VPC and try to access the another EC2 instance running into another VPC so that we know our transit gateway is working. This is my AWS console, and let's start setting up the VPC 1. So this is the home page of my AWS console, and here in the search box type VPC. Click on the VPC, and here click on this create VPC, and here choose the option for a VPC 1, and here you can enter the name. So I'm just going to put test VPC 1 over here. IP range, so I'm just going to go with 12.0.0.0, and after that I'm just going to put 16 over here. So I will have around 65,000 possible IP addresses. Tenancy, I'm just going to stick with default, and tag and key value name, I'm just going to go with the default one. And after that, click on create VPC. Go to the VPC homepage and check. So here you can see our test VPC 1 has been created. After creating the VPC, let's take a look onto the diagram once again. So just to make things simple, I have just removed all the component which we are not going to create at the moment. So if you compare this diagram previously, so this is our ideal diagram, but right now I am working on the VPC 1. So now we have created the VPC 1. The next thing which we need to create is the internet gateway. So again, go back to your AWS console, and in the left navigation menu, you will find an option for an internet gateway. So click on it. And here click on create internet gateway. So here I will put internet gateway abbreviation and type test VPC 1. So I'm just putting the suffix VPC 1 so that I will be able to identify that this internet gateway belongs to VPC 1. So that's the reason I'm attaching a suffix with the VPC 1. And after that, click on create internet gateway. And here you can see our internet gateway has been created. So this is the internet gateway which we have just created, but this is in a detached mode. So we need to attach it to our VPC 1. So click on this ID, go to action, click on attach VPC, and here you will find the test VPC 1. So click on it and click attach internet gateway. The next thing which we need to create is the subnet over here. So now we have created VPC, we have created internet gateway, so we will create a subnet. So go back to your AWS console over here, and here in the left hand navigation menu, you will find the option for creating subnet. So click on subnet and click on create subnet. Here there are default subnet, but we are not going to use those one. We are going to create our own subnet. And as soon as you create a subnet, then it will ask like in which VPC you want to create. So as you remember that we have created a VPC 1. So we are going to select the VPC 1 over here. And here we need to enter the name of our subnet. So I'm just going to put test subnet, and I'm going to suffix it with VPC 1 so that I can identify that it belongs to VPC 1. And then I'm just going to put 1A. 1A is our availability zone. So here in the section, you will find availability zone. So I'm just going to choose Europe Central 1A. And after that, we need to specify the IP ranges for this particular subnet. So remember, we are just working with this IP range of our VPC. So we are going to use the similar range for our subnet. So I'm just going to copy this IP range. I'm just going to paste it over here. And here I'm just going to choose 1 over here. And I'm just going to make it 24 so that I have 256 IPs within my subnet. So I'm just going to create a one subnet over here, and this subnet we are going to make it as a public subnet that I'll show you in a moment. So after that, just click on create subnet, and here you can see our subnet has been created. But in ideal scenario, we will not have only one subnet, but we will have a multiple subnet, like a public subnet as well as private subnet. But this is just a demo. That's why I'm just creating only one subnet. So just keep in mind. Now we have created the subnet. The next thing which we need to create is our route table. So again, go back to your AWS console, and in the left navigation menu, you will find an option for a route table. So click on the route table over here. And here, these are default route tables. So we are not going to touch one, but we are going to create a new route table. So click on route table. And here again, we are just going to choose RT for route table abbreviation. and then we are gonna use test VPC1 suffix. And after that, we need to choose the VPC, because if you take a look onto the diagram, so we are working within our VPC. So every resource we are creating within our VPC1. So this route table also belongs to this particular VPC1. So here in the drop down, we are going to choose test VPC1. So select that one. And I'm just going to put the tags default as it is. I'm just not going to change anything. So click on create route table. Alright, so here you can see our route table has been created. After creating the route table, there is also one more thing. We need to create the routes over here, and also we need to associate the subnet. So this route table we have created, but we need to associate this route table with subnet, and also we need to create a route for the internet gateway so that we will have access to internet for this particular subnet. So for that, again, go back to your AWS console, and this is the route table which we have created, that is RT test VPC1. So click on this route table ID. And here into the subnet association, go and click on edit subnets. And here you will find the subnet which we have just created. So select this subnet and click on save association. Now we have associated our subnet with our route table. So here you can see this is our route table and this is our subnet which we have associated. So here you can see the subnet association. The next thing which we need to create a route. So go to the routes over here and click on edit routes. And here we need to click on add routes. So here we will choose 000 because we want to have an internet access within our subnet, because this is our public subnet. So that's why I'm creating this route. And this means I can access this public subnet from anywhere, this particular IP address. Here, then we need to provide a resource which is responsible for providing the internet access. So that is our internet gateway, and which we have already created with this, which is internet gateway test VPC1. So select that one and click on save changes. Remember, we are working in a public subnet, but if you are creating a private subnet, then you don't need to create this route with our internet gateway, because private subnet doesn't need an internet gateway, but instead you need to set up a NAT gateway. Alright, so now we have created our route table also. Now after creating our route table, the next resource which we need to create is our EC2 instance from this diagram. So let's go back to our AWS console. And here you can see this is the homepage of our AWS console. In the search box, type EC2, click on this EC2 instance over here and click on this orange button to launch an instance. And here we need to enter the name of our EC2 instance. So I'm just going to put EC2 test VPC1. I'm just suffixing it with the VPC1 so that I can identify this instance that it belongs to VPC1. So that's the only reason I'm just putting this name. Select the base operating system. So I'm just going to choose Ubuntu, and I'm just going to stick with instance type, that is t2.micro, which is a small EC2 instance. Then we need to create a key pair. We need to create a public and the private key, and that you can do at the same time using just this link, that is create a new key pair. So I'm just going to click on it, and here I'm just going to type EC2 test VPC1, and I'm just going to suffix it with the key and click on create key pair. And here you can see it has downloaded the key for you, and also it has attached the key for your EC2 instance. Okay, so we are just going to use this EC2 instance key later when we are going to perform the SSH into our EC2 instance. Okay, let's move ahead. The next thing which we need to set up is the network setting, which is really important. So click on edit over here. So first of all, let's take a look onto the diagram once again. So here you will see this EC2 instance we are creating inside the VPC, and the name of the VPC is test VPC1. So again, go back to your AWS console. And here in the drop down, you just need to choose the VPC1. Select that one. And in the subnet, as you remember, we have created one public subnet. So that's the subnet which we need to select it over here. But in case if you have created a multiple subnet, then there will be multiple subnets which will pop up over here. So just choose the suitable one, the one which you have created. Next thing, auto assign public IP. So yes, we need to enable it because this is going to be inside our public subnet. So that's why I'm enabling the public IP. Security group. So by default, they have the security group SSH22 enabled. That's so that we can SSH into our EC2 instance, but we need to add one more security group, and that I'm just gonna enable it for HTTP. So that any HTTP request comes to our EC2 instance, then those requests are entertained. Those should not be get rejected. and I should allow it from anywhere. So we can access this EC2 instance from anywhere in the world. Alright, so now we have created the security group. The next thing which we need to see is the storage. I'm just going to stick with 8 gigs. And after that, in the advanced detail, this is one more important thing. So we are just going to use the user data. So user data is the section where you can write down your shell script for installing certain packages. So here I'm just going to install the Apache. So I'll just copy the script from my notepad. So here you can see this is the script for installing the Apache. So the user data section is used to install certain packages onto your EC2 instance when you're trying to set up it for the first time. So here what it will do, it will just update the package manager. It is going to install the Apache, and after that it is going to update the index.html page, which we will access later on of our Apache. And here it will print the host name. I'm just going to show this a home page also after we set up our EC2 instance, and after that we are just going to restart the Apache. All right, so after that, once we have done this setup, then click on launch instance, and it will take a couple of minutes to get it up and running. So go to EC2 dashboard and click on instance running, and just wait for a bit. So I'll be back once this instance is up and running. Now, as you can see, my instance is up and running, and you can verify this instance state, which is green and running. So click on this instance ID, and here you can see all the details. So this is the private IP, which is 12.0.1.255. But we are not concerned about private IP, but we need to access our public IP. So just copy this public IP from here, go to the new window and paste it over here. So here you can see the IP address and the host name details of my EC2 instance. So this is the private IP which has been shown over here. So this is the home page of my Apache, which I have just installed using the user data. Let's have a look onto our setup once again. So here you can see our VPC1 is ready, and we have provisioned, or we have set up all the resource which is needed. Now the next thing is we need to set up the VPC2 and VPC3. So VPC2 and VPC3 setup are gonna be exactly similar. So I'm just not gonna show the same setup or same step again, because it will be boring for you. But what you need to do when you are setting up the VPC2 and VPC3, just follow the same step which I have followed in setting up the VPC1, and only suffix it with the VPC2. So you just need to create the VPC, Internet Gateway, route table, subnet, and EC2. Just follow all the steps which I have covered inside the VPC1 setup. Just remember, try to suffix it with the VPC2 so that you will be able to identify those VPC and those EC2 instances later. One more quick note which I forgot to tell you before creating the transit gateway is the IP ranges of your VPC2 and VPC3. So for test VPC1, we have used 12.0.0.0/24 and 16. For subnet and VPC. So here in the VPC2, you cannot use the same IP ranges. So you need to change it. So for just to simplicity, I will be using 13.0.0.16 for VPC and 13.0.1.0 for 20/24 for subnet. Similarly, I will be using the 14 series and 14 series for subnet. So just keep in mind, you need to keep some different IP ranges for your VPC2 and VPC3, and same goes with the VPC2 subnet as well as VPC3 subnet. So just make sure that you put the correct IP ranges before creating those VPC2 and VPC3. Let's go to our AWS console and create our transit gateway. So I'm just going to open my AWS console. So here in the search box, type VPC, go to your VPC dashboard. And here in the left navigation menu, go all the way down, and here you will find the transit gateways. So click on this transit gateway over here, this link, and here you will find the dashboard for your transit gateway. Here I have not created any transit gateway, so that's why the list is empty. I'm just going to click on create transit gateway and put a name. So I'm just going to put transit gateway TG, that's abbreviation, and I'm just going to simplicity, I'm just going to put VPC1, VPC2, VPC3. This is just a demo, that's why I'm using this naming convention, but it is not gonna be the same for in your case, and we don't use this kind of a naming convention in our production environment. So just keep this thing as a demo purpose only. All right, so description, I will put the transit gateway for VPC1, VPC2 and VPC3. All right. ASN, so this is a Amazon Side Autonomous System number. So this is just an route which we need to put. If you don't put anything, then AWS is going to assign to you. So what I'll do, I'll just not going to put any number over here because this is the route identification. So you need to put some kind of a route identification so that when we create our transit gateway, so VPC will be able to find that route based on the number, and then they will be able to navigate and communicate within the VPC. So that's the theory behind it. But let's just keep it. And if you want to keep it, then I think you can keep it 65412. I don't recall the exact number, but we will get to know once we create our transit gateway because AWS is going to create for us. All right. So configure cross account sharing option. So I'm not going to choose this option because I'm just working within my account. I'm not going for a cross account setup. So that's why I just keep it optional. The CIDR for transit gateway is also optional, so I'm not going to touch that one, and I'm just going to go and click on create transit gateway. And here you can see it's in pending state, so it will take a couple of minutes or maybe more to set it up. So I'll be back once this transit gateway state is up and running. After a few minutes, my transit gateway is set, and here you can see the state which shows available. So now my transit gateway has been set up. Let's go back to our diagram and see what the next component which we need to create. So here our transit gateway is there, but still our VPCs are not associated or attached with my transit gateway. So the next thing which I'm just going to do, I'm just going to create an attachment. So this transit gateway is attached to VPC 1, VPC 2 and VPC 3. So that's the next step which we need to do. So let's go back to our AWS console. And to create the transit gateway attachment, again go to the left navigation menu. In the transit gateway section, you will find an option for a transit gateway attachment. So click on this transit gateway attachment over here. And here this list is empty because we have not created any transit gateway attachment. So click on create a transit gateway attachment. And here we need to key in the name, and now we need to create the attachment based on each VPC. So we have a 3 VPC and we have a 1 transit gateway. So let's create for the first VPC. So I'm just gonna see transit gateway attachment VPC 1. The transit gateway, here we need to specify the transit gateway ID. Remember, we have only 1 transit gateway. So here is the transit gateway name and the ID which we have just created. So select that one. Attachment type. So yes, we are going to attach with the VPC. So I'm just going to choose VPC. But also, this demo is only for VPC specific, but in actual environment, you might need to attach to the VPN also, because in production like environment or in companies, we have our on-premise infra also. So in that case, you can choose the VPN also. But since we are working only into the cloud environment and also into our AWS environment, so I'm just going to choose the VPC. All right. Moving ahead, so now we need to define the VPC. So first attachment we are going to create is towards the VPC 1. So from the drop down, select the VPC 1, which is our test VPC 1, which we have created. So select the test VPC 1. And as soon as you select the test VPC 1, then it will show all the subnets. So here you can see we have only 1 subnet created, but in your case, it might be possible that you have a multiple subnet. So select all the possible subnet which you want to attach. Okay, so now we have selected the VPC and the subnet. The next thing which we need to do is create a transit gateway attachment. So click on this button, create transit gateway attachment. And here you can see our first attachment has been created. So if you take a look onto the diagram, so this is the transit gateway and this is the first attachment on the left hand side which we have fixed it. Let's create it for VPC 2 also. So go back to your browser, create transit gateway attachment. I'll just copy the name so that I can rename it. So I'm just going to copy this name, go there and change it to 2 because it is going to be for VPC 2. Again, our transit gateway ID is same. We are having a single transit gateway. So I'm just going to choose same, and here we are going to choose VPC. Here we are going to choose VPC 2, and here we are going to select the subnets within that VPC. And tags, I'm just going to keep it default. Click on create transit gateway. So now we have created for the VPC 2 also. Now the third one. So let's go back here, remove this filter, and here you can see 1 and 2 both are there. Let's create it for the third one. So paste the name, change it to 3, select the transit gateway which we have created, which is single, attachment type is VPC, VPC ID is going to be third. This is the subnet, and then click on create transit gateway attachment for third VPC. Remove it, this filter, and here you can see all the three attachments which we have just created. And again, in the diagram, you can see this is our transit gateway, and these three attachments we have created. Now our transit gateway is attached with all the VPCs. Before we go ahead, there is one concept which I would like to put your attention, because why it is different from a VPC peering when we are using the transit gateway, because VPC peering is also doing the same thing. It is also connecting the multiple VPCs. But there is a very good point about the transit gateway. In transit gateway, you need to create only single transit gateway, and it can handle multiple VPCs. But in VPC peering, here in the diagram, you can see here is the first VPC peering between 1 and 2 VPC, and there is another VPC peering which we need to create it for 2 and 3, because the peering between 1 and 2 cannot refer to the third VPC. So that's the drawback with our VPC peering. So the more VPC you have, then you need to create a multiple VPC peering. But if you take a look onto our transit gateway, then it is not the case. So here we are having a single transit gateway, and it is connecting to VPC 1, VPC 2 and VPC 3. So that's why transit gateway are more efficient than the VPC peering. If you have a 2 or 3 VPCs, then VPC peering is fine. But if you have more than 10 or 50 VPCs, then I would recommend to use the transit gateway. Now what next? Now we have attached the transit gateway to VPC. The next thing which we need to do is we need to update the route table, so that our subnet knows like how to route the request to the transit gateway so that it can communicate with the other VPCs. So first of all, we are going to update the route table of our VPC1 or the VPC1 subnet. So let's go back to our AWS console and start modifying our route table. Here is my AWS console. Go to the home page. In the search box, type VPC, click on it. In the left navigation menu, click on route tables. And first of all, we are going to work on our test VPC1 and its attachment. So click on the route table ID over here of my VPC1. And here these are the routes. So click on edit routes. Click on add routes. Now this is critical. So go back to your diagram once again. And here you can see this is our test VPC1, and if I go further over here, then here we can see now we want to reach out to the VPC2. So if I take a previous slide, so the VPC2 has a IP range of 13.0.0.0/16. So we want to reach out to this destination ID. But to reach out to that destination ID, we also need an attachment, and that attachment we have already created with our transit gateway. So we will use this attachment of VPC1 of our transit gateway and with the destination IP of my test VPC. So let's go back to our routes over here, and here type 13.0.0.0/16. This is the IP range of my VPC2, and here in the transit gateway, here you will find the transit gateway attachment VPC1. Click on save changes. Okay, so now we have fixed the connectivity between the VPC1 and VPC2 by creating a route. Now we need to fix the connectivity between the VPC1 and VPC3. So here again we need to know the IP range of the VPC, so that is starting with the 14, and we will again use the same attachment, which is the first attachment. This attachment we are going to use. So again, go back to our route table of my test VPC1, click on edit routes over here, click on add routes, and here I'm just going to choose 14.0.0.0, and after that I'm just going to choose 16, and here I'm just going to choose the internet transit gateway, and here I'm just going to choose the attachment VPC1 and click on save changes. And now we have the connectivity between our VPC2 and VPC3 with our VPC1. Now let's take a look onto the diagram once again. It should be this one. So here now we need to work on the VPC2 route. So now we need to fix the connectivity using the attachment 2 with our VPC1 and VPC3. So go back to your routes here and go to route table and open the VPC2 route table. So click on it. Click on edit routes. So here click on add routes. So here I'm just going to choose the VPC1. So this is the IP range of my VPC1. Select the transit gateway, and here you will find the transit gateway attachment 2, which we have created for our VPC2. Add one more route, and here I will use 14. And here again I will choose the transit gateway, so that is transit gateway, and here will be VPC 2, and click on save changes. So now we have fixed the connectivity between, if we take a look, so we have fixed the connectivity between from 2 to 1 and 3. So now we need to fix the connectivity between the 3, so that 3 can communicate with our 2 and 1 also. So any instance which is running inside the VPC 3 will be able to talk to EC2 and VPC 2 and VPC 1. So go back to our AWS console, click on route table, go to the route table 3 of our VPC 3. Click on edit routes, so click on add route. So I will choose the destination of my VPC 1 IP range and 16, and here I will choose the transit gateway, and that will be transit gateway attachment 3. So that's for VPC 1 connectivity, and here will be for VPC 2. It should be 16, and here I will type transit gateway, and here I will use the 3. Click on save changes. Alright, so let's take a look onto the diagram. So here you can see we have pretty much set up the whole transit gateway and whole infra with our EC2 instances and updated all the route tables. Now what we will do, now we will log in, or we will SSH into each EC2 instance from VPC 1, VPC 2 and VPC 3, and we will try to curl the pages of our Apache homepage of other EC2 instances. So let's switch back to terminal and try to SSH into our EC2 instances. Now we need to connect to EC2 instance, and for that go to our homepage of our AWS console, and here type EC2. We just need to find the instruction how to connect it. So click on instances running. Let's take a test VPC 1 EC2 instance. Click on connect, and here you can see this is the key which we have created. So we have created this key for EC2 instance running in VPC 1, but we have also created the other keys also. Those are ending with the 2 and 3. So now we need to change the mode of our keys. So right now these keys are into read and write permission, but we need to make it read only. So just copy this command from here and go to terminal. So here you can see I have divided my terminal into 3 sections. So this is going to be for VPC 1, VPC 2 and VPC 3. So let's start. First of all, let's check I have the keys or not. So here you can see I have all the 3 keys. So this is the 1, 2 and 3 key. Or maybe I can run simply just ls command to view it. So here you can see all the 3 keys I have right now. So I'll clear it. So first of all, I need to do chmod 400, and then I need to put the keys over here. So VPC 1 changed chmod. I'll just use the same thing, and I'll just put it to. Okay, no key. So I'll just run the ls command once again. And I can see that command. So I'm just going to rerun the command for VPC2. I can see that it's there. I have changed it, so I'm just going to run it for the 3rd key also. So 400, and I'm just going to choose the 3rd one also. It is this one over here. Alright, I'm just going to clear it, and I'm just going to run the command lslart just to verify. So right now I can see it's a read only. This is only read only, and this is also read only. So we have changed the read only permission for all the 3 keys. So I'm just going to clear it. Okay, so that's been done. The next thing which we need to do is we need to SSH into our EC2 instances. So this is going to be our VPC 1 EC2 instance. So just copy this command and go to your terminal and paste it and enter. And type yes over here, and here you can see I'll clear it, and here you can see this is the IP that is starting from 12. So this is our VPC1 EC2 instance. Let's open another terminal, and here we are going to use the EC2 instance from VPC2. So again, go back to dashboard, go to instances, select 2 and go to connect. Copy this SSH command. We have already performed the chmod change permission, so that you don't need to do. Go over here, pass the command, type yes over here, clear it, and here you can see that is 13. That is from our VPC 2. And now it is our VPC third. So go back to our EC2 instances, click on third VPC, and here click on connect, copy this command from here and paste it over here. Type yes. I'll clear it, and here you can see the IP which is starting from 14. So this is VPC 1, 12, this is VPC 2, that is 13, and this is VPC 3, which is starting from 14. Just to keep the thing simple, what I'll do, I'll just open all the instances into the new tab. So I'll start with the 1, 2, and 3. I need the private IP address of all those instances. So here you can see this is our VPC 1, this is our VPC 2, and this is our VPC 3. So let's start from our VPC 2 private IP, go to our, now we are into the VPC 1 EC2 instance ID. So I'm just going to use curl command to access the VPC 2 Apache page and hit enter. And here you can see I'm able to access the EC2 instance Apache from my VPC 2. And similarly, I'll try to access the Apache instance running inside the EC2 of my VPC 3. So go back over here and copy the private IP of my EC2 instance running into VPC 3, and I'll just use the curl command and paste it over here. And here you can see we are able to access it. So from EC2 instance from VPC 1, we are able to access the VPC 2 as well as VPC 3. And similarly, if I run the curl command from VPC 2, and now I will try to access, this is our VPC 1, and copy the private IP address. And here you can see we are able to access it. And similarly, I can access the VPC 3 from VPC 2. So this is the private IP address of my VPC 3 EC2 instance. And here you can see I'm able to access it. So this is VPC 2, and this is our VPC 1, and this is our VPC 3. Similarly, I'll just do the curl, and now I will try to access the, first of all, I'll copy this IP address. So this is VPC 1, I'm trying to access it. So that is also working from VPC 3. And now I will try to access the VPC 2 from VPC 3. So I'll just use curl, and then I'll just use the private IP address of my VPC 2. And here you can see. So now all our VPCs are connected, and now we are able to communicate between all the VPCs. So I hope you liked this session on how to set up the transit gateway and how to enable the communication between all the VPC using the transit gateway and a transit gateway attachment. And if you are interested into the similar content, then considering following this channel. And also for you, I have started the members only video. Those are only for the YouTube members which are into my YouTube members family. So here I will be uploading some of the specific or in-depth session using Terraform and AWS for those members. So if you are interested into learning more in-depth concept, and considering to be a member of this particular YouTube channel, and you will also get an access to the Discord group as well. Today we are going to talk about the VPC endpoint. This is our target setup which we are going to perform into this demo, but let's understand what is VPC endpoint. If you go by the definition of a VPC endpoint, then it says that if you don't want to leave your AWS premises or AWS boundary, then you should use VPC endpoint to reach the resources. So what does it mean? So here onto this diagram, you can see this is our AWS boundary where all the resources are present. So within the AWS boundary, we are having a VPC, which is our virtual private cloud. And in this VPC, we are having subnet. One is the public subnet and one is our private subnet. So what happens, like if a resource wants to communicate from our private VPC to our S3 bucket. So S3 bucket is not lying within the VPC, but it is within your AWS environment. So how can we do that? So for that, we need to use our VPC endpoint. So here you can see this is our VPC endpoint, which is attached to our VPC. So any resource which is present inside our private subnet, for example, this is EC2, will go and check with the VPC endpoint, and that VPC endpoint will help to communicate or to reach out to the S3 bucket present into your AWS account. So what's the benefit of this approach? So you don't need to leave your AWS environment, and you can reach the resources within the AWS. So you don't need, or your request don't need to traverse through internet and reach to that particular resource. So that's one of the biggest advantage of using the VPC. And let's start step by step, and we'll start first setting up our VPC. So we are just gonna break the whole implementation into multiple steps. So this is my AWS account, and the first thing which we need to set up over here is the VPC. So that is going to be our step number 1. So here you can see this is our AWS account, and inside that AWS account, first of all, I'm just gonna set up my VPC. So let's head over to my AWS console and start setting up our VPC. Here is my AWS dashboard, and in the search box you need to type VPC. Click on the VPC, and here click on the create VPC, and here we need to create the VPC by assigning the name. So I'm just gonna select the VPC only, and the name I'm just gonna put demo VPC endpoint VPC. And after that, we need to assign the IP address for our VPC. So I'm just going to go with 11.0.0.0/16. So this is going to be the CIDR range, and all the resources within our VPC will get the IP addresses with the range 11.0.0.0. So we can have a multiple IP addresses with the help of this CIDR range. Okay, so after assigning the CIDR range, just click on the create VPC. And here you can see our VPC has been created. Let's take a look on to the next step. So in the next step, we will gonna set up the subnet. And the subnet, when we are talk about, then we are gonna set up 2 subnet. One is the public subnet and one is the private subnet. So let's go back to our AWS console. But one more thing here, I would like to show you the IP ranges of our subnet. So as I told you, like the CIDR range of our VPC is this one, 11.0.0.0/16. So the public and the private subnet will also get the similar IP ranges, because we are going to create those subnet within the VPC. So here the public subnet, I will keep the range 11.0.1.0/24 and 11.0.2.0/24. So this /16 and /24 are the ranges or the available IP ranges which you will get. So if you choose 224, then you will get 256 IP, and if you reduce this number, then your IP ranges will increase, so that you can have a multiple IPs available within your subnet. I'm just going to show you when we are going to do this onto our AWS console. So our public subnet will have a 1.0 and 2.0 at the end of their CIDR range, and our private subnet will end with 3.0 and 4.0, just to give you the heads up like what's our IP range is gonna be. Okay, so let's go back to our AWS console and go to your VPC dashboard once again, and here you will find subnet. So here we just need to create our own subnet. So just check the name of the VPC so that we can keep the similar name for our subnets also. So I just copied the name, go to subnets, click on create subnet. And here, first of all, we need to select the same VPC where we are working. So this is the VPC which we have created. So select that one. And here I'm just going to put subnet public, and then I'm just going to suffix the name. So demo VPC endpoint, and then 1A. 1A is the availability zone. So I'm just going to copy this name to create other subnet as well. So here in the availability zone, I'm just going to choose Europe West 1A. Then after that, the IP ranges. So here we need to enter the IP range. So I'm just going to put 11.0.1.0/24. And tag I'm just going to keep as it is. Then click on add new subnet. Then here we are going to create one more public subnet. So here we have already created one public subnet. Let's create second public subnet over here. So I'm just going to put the name over here as subnet. We already copied the name, so I'm just going to paste it over here, and here I'm just going to change it to 1B. Availability zone, I'm just going to choose 1B, and the IP range I'm just going to choose 11.0.2.0/24. And here you can see the IP range is 256. So as you reduce the number, then you will get more IP ranges. So here you can see now you are having 65,000 IP ranges. But for the demo, I'm just going to go with 24. Okay, so 2 public subnet we have created. Let's create our private subnet. So here I'm just going to put the same name, and here I'm just going to change it to private. And availability zone, I'm just going to choose Europe West 1A, and IP ranges, I'm just going to choose 11.0.0. Sorry, it should be 3.0/24. Okay, so this is our third subnet, which is our private subnet. Then click add more subnet, and here just enter this name and change it to private, and put 1B over here. Availability zone, choose 1B, and the IP range I'm just going to choose 1.0. 4.0 and then /24. So this is going to be the IP range for my fourth subnet, which is my private subnet. And then click on just verify the details like private subnet. The name is a little bit incorrect here, so I'm just gonna put this name over here. Okay, so I corrected that name, and let's verify other subnets also. So just correct that one. That looks okay to me. This one also, and this one also. Okay, so all the 4 subnets are pretty much ready. Then click on create subnet over here. And here you can see all the 4 subnet has been created. Let's take a look onto the diagram once again. So now our VPC is there, our subnets are there. So next thing which we need to do is we need to set up our internet gateway. So where our internet gateway will reside. So our internet gateway will reside onto our public subnet. So which is this. So let's go back to our AWS console over here and go to VPC dashboard. And here click on the left hand side, you will find an option for internet gateway. So here you can see this is the internet gateway option. So click on it, click on internet gateway. And here we need to assign the name. So I'm just going to put VPC Endpoint IGW. So IGW is the internet gateway abbreviation, and then click on create internet gateway. And here you can see our internet gateway has been created, but the state is detached. So we need to attach to our VPC. So first of all, let's take a look onto the diagram. So this internet gateway is still a part of our VPC. So that's why we need to attach this internet gateway to this VPC. So go back here, click through action, click on attach VPC, select the VPC, which is our demo endpoint VPC, which we have created, and then click on attach it. So now it has been attached. And the next thing we will do when we create a route table, then we are going to use this internet gateway with our public subnet in our route table. So that's the next, in the further steps, we are going to perform that thing. Okay, so now our internet gateway has been attached to our VPC. Let's move further. And the next step is our route table. So we need to create 2 route table over here. So here you can see this is our route table for our public subnet, and this is our route table for our private subnet. Okay, so let's go back to our AWS console, and from the left navigation menu, you will find an option for a route table. So click on this route table here, and then click on create route table. And here we need to enter the name. So I'm just going to put VPC Endpoint Demo public route table. RT is for route table. The VPC, again, if you take a look, then this route tables are again a part of a same VPC. So we need to attach to that VPC. So that is our demo VPC endpoint. And then click on, I'll just copy the name to create my private VPC, but then just click on create route table. So here you can see our public route table has been created, but let's go back and create our one more route table, which is our private route table, which you can see over here. This is our private route table. Okay, so click on create route table and then put the name and change it to private. Again, select the VPC. So that is going to be our demo VPC endpoint VPC, and then click on create route table over here. And here you can see our route tables has been created. So our public and private route table is ready. But as I told you in the previous step, we need to attach this internet gateway to our route table so that this public subnet will still have the access to the internet. But remember, we are not going to attach this internet gateway to our private route table. Then it will not become a private subnet. So the key rule over here is the internet gateway will provide the internet access to our subnet, and whatever subnet have the internet gateway is gonna be called public subnet. But here in the private subnet, we are not gonna attach any internet gateway. So that's the key thing to remember in this whole setup also. Alright, so let's go back to our route table, and here I'm just gonna choose our public route table, which is this one. So click on this one. And here, first of all, we need to attach this route table or associate this route table to our public subnet. So here you can see this route table is a part of this our public subnet. So let's go to the subnet association over here, and here you can see this list is empty. I'll scroll it down. So here you can see this whole list is empty. Click on edit subnet association, and if you scroll here, then you will find our public subnet. So click this and this. Don't attach private subnet over here because this route table is only for our public subnet. Okay, click on save association, and here you can see the public subnet is attached to this or associated with our public route table. Okay, go to routes now. then click on edit routes, and here click on add route, and now we are specifying a route to get the internet access. So here the IP ranges I'm just going to assign is 0.0.0/0, which means it is open for everyone. Okay, and here we need to choose internet gateway and then select the internet gateway, which is our VPC endpoint internet gateway. Select that one, then click on save changes. So now our public subnet has internet access with the help of internet gateway, and the route tables has been updated. After updating our public route table, we need to work on our private route table as well. So we need to associate our private subnet with this particular private route table. So go back to our AWS console here, and here I'll just close this one. So here you will find a private route table which we have already created. So click on this route table, go to subnet association, click on edit subnet association, and from the list just select the private subnet for this particular route table. So select this one and this subnet. Okay, then click on save association, and now your private route table is now associated with your private subnets. Let's move to the next step, and in the next step we are going to set up the EC2 instances. So here if you take a look onto this diagram, then we are going to set up EC2 instance first of all into our public subnet, and then we are going to set up into our private subnet. So the idea over here is that we will be using our EC2 instance. So if you take a look over here, then we are going to later on using this public EC2 instance to log in into our private EC2 instance, because this private subnet doesn't allow any access from outside. So first of all, a person who is sitting over here like me has to get the access to our public instance, which is this one. So first we will set up our EC2 instance into public subnet. We will SSH into this EC2 instance, and from there we are going to access into our private EC2 instance. So let's go back to our AWS console and start setting up our first public EC2 instance into our public subnet. Alright, so here is my AWS console. In the search box, type EC2, click on this EC2 over here, and here you can see no instances running. So click on launch instances, and in the name just type public EC2 instance, and application OS image I'm just gonna choose Amazon Linux, and instance type I'm just gonna choose t2.micro. But if you're doing it for your own project, then just choose the suitable instance which fits your need. Okay, then click on key pair. So we need to generate the key pair. So here click on create key pair, because this keys we are gonna use it to SSH. So we are gonna create the public key and the private key. So here we need to click on create key pair, enter the name. So I'm just gonna put VPC Endpoint demo keys, and then click on create key pair over here. And as soon as you will create this key, then you will find a key which has been already downloaded for you, and this is going to be your private key. So just keep in mind that this key you need to keep it with yourself. And here at the same time the public key will be associated to your EC2 instance. Okay, so this is the key which we have created. Then go ahead and click on network setting, click on edit over here, and here we need to again go back and check the diagram. Why I'm saying so? Because this EC2 instance is present into this VPC, which is our VPC endpoint demo VPC which we have created. So go back over here, then from the drop down choose this VPC which we have created for this particular session. Subnet, so we need to choose our public subnet because we are working into the public subnet. So go back over here and go and choose our public demo VPC endpoint 1A subnet. So we have chosen this one. Okay. Assign public IP. Yes, this is our public instance. So I'm just going to enable and assign the public IP. Security group. So let's check those. So here you can see the security group for SSH is already enabled so that we can SSH into our EC2 instance. So that is already there. So just keep the thing as it is. Let's go ahead and advanced detail. I'm just not going to change anything over here. And I think we are good. Then just click on launch instances. And here you can see our instance has been launched over here. So I'll just remove this filter, and here you can see the instance is in pending state. So I'll be back once this instance is up and running. Let's refresh this page over here. And here you can see the instance is now into running state. So click on this instance ID and copy this public IP address from here, because we need to SSH into our EC2 instance. And also how to SSH. So all the instruction you can find, I'll show you once again. So here just click on connect button over here, and here you will find the option to SSH into your EC2 instance. So here you need to first of all change the mode of our key, which we have already downloaded, which you can see, which is this one. This is our private key. And then we are going to use this SSH command to log in into our EC2 instance. All right, so let me open my terminal over here, and I'm just going to drag my terminal here. So let's reduce the size of this terminal so that you can see all the commands. So yeah, I think this is good now. Let's go to the downloads directory where I have already downloaded. And if you are using the Windows system, then just use the putty for that reason. I'm using the Mac OS, but the same commands are going to be useful from your putty as well. So just install putty and then start following these instructions from there onwards. Okay, then go to demo. So this is the directory where I have already downloaded my key. So this directory will vary in your case. So just keep in mind, just choose the directory where your key is downloaded. Okay, and here you can see this is the key which I have already downloaded on my local system. So first of all, we need to make this key as a read only. So for that, there's already a command given over here, chmod. So just copy that command and paste it over here and hit enter, and which you can verify by running the lslart command. So here you can see now it is gone into read only mode. All right, so let's clear this one. The next command which we are going to use is from here. So this is the command for SSH. So just copy this command and go over here and paste it over here and hit enter. And are you sure you want to continue connecting? So just type yes. And here you can see now we are logged in into our EC2 instance, which is running into our public subnet. And here you can see this is the IP which it is denoting. So 11.0.1.90. So if you go back and go to instance ID, and here you can see the same IP address, which is our private IP address. All right, let's get back to our diagram once again. So now we have set up our EC2 instance into our public subnet, and we are able to access it. Now we need to set up our EC2 instance into our private subnet. So let's go back to our EC2 dashboard and go to EC2 dashboard over here. Refresh it, and here you can see one instance, but we need one more instance. So for that, click on launch instances. And here we need to enter the name. So let's copy that name so that all the names are into the similar. So public EC2 instance, the name I have kept. So go to EC2 dashboard, launch, paste it over here and change it to private now. All right. The next thing, again, I'm just going to choose Amazon Linux. I'm just going to stick with t2.micro, and key pair. I'm just going to select the same key pair which I'm using it for public instance. So one key thing over here, I'm just doing the demo, but in actual, we try to keep these keys separate for public as well as private instance. So if you want to make it more secure, then you can create one more key for your private instance as well. But since it is a demo, so I'm just going to stick with my public key instance. So both the instances now using the same private key. So that's just the one point I would like to give you a heads up, that you can still create your own private key for your private instance. Okay, so here from the drop down, I will just stick with my original key which I have created. So I'm just going to choose that one. Click on edit. Again, the VPC, I'm just going to choose VPC Endpoint. VPC, then the subnet. So here, this is the key thing. So here from the drop down, choose any of the private subnets. So I'm just going to go with the private subnet demo 1A. Don't assign the public subnet, otherwise this will be your public EC2 instance. So just keep in mind. Auto assign public IP, since we are working in a private subnet, so we cannot assign, we can assign, but it doesn't make a sense because no one will be able to access that EC2 instance. So just keep it disabled, the public IP address. Okay, SSH we need to enable because we will be accessing this EC2 instance from this public EC2 instance. Okay, that's been done, and I think we are good with it. So just click on launch instances over here. And here you can see our instance is in pending state. So this is our private instance, which is in pending state. So I will be back once this instance is up and running. Alright, so now my private instance is up and running. So click on this instance ID over here, and here you can see there is no public IP, but we have the private IP over here. But we need to connect to this EC2 instance. So click on this connect, and here you will find the similar instructions for connecting to your private instance. But let's take a look onto the diagram once again. So right now we already logged in into our EC2 instance, which is our public EC2 instance. I can show you once again over here. So here you can see 1.90, which is our public EC2 instance. And if you take a look, if you want to confirm from here, then go here, go to public, and here you can see this is our public EC2 instance. So now we already into the EC2 instance into our public subnet. Then from here we are going to perform the login into our this private EC2 instance. But for that we need to have that copy of that key into our public instance. Okay, so go back to terminal over here, and here we need to create that file. So I'm just going to put the name of that file, like I can copy that name actually. So I'm just going to copy this name from here, go back here and paste it over here, and then just hit enter. And here we need to write the content inside this particular key, and this is going to be the private key. So here I have already opened that key content, so I'm just going to select A and copy this one and paste it over here, and after that I'm just going to save and quit. Okay, so now this private key is now available into my public EC2 instance. So here again I need to change the mode of this key to 400 and verify that once again, and here you can see it has been changed now. All right, okay, so now we are ready to log in into our private EC2 instance. So this is our public, so close this one, we don't need this one, and I think just close everything over here. Go to instances once again, close all the tabs, go to private instance, click on connect, and here we can see I have already done this step. I just need to copy this command to SSH into, go back here, paste it over here and hit enter. And here you can see we are logged in into our private EC2 instance. I'm just going to clear the screen, and I'm just going to show the IP, which is 11.0.3.40, and which you can verify from here as well. So now we are logged in into our private EC2 instance. Alright, so till now we have just done the prerequisites which is needed to set up our VPC endpoint. Okay, so the next step over here is we are gonna create some S3 into our VPC so that we can simulate this whole scenario. So here is the S3 bucket which is residing into our AWS account, but not within that VPC, but it is just somewhere into our AWS account. And later on, we are just going to use this EC2 instance. So if I draw over here, so we are just going to later use this one to access this EC2 from here to this particular S3 bucket. So that's our target. We want to achieve it. So till now, we are able to set up this thing and this thing also. So both the things are working. And now we are just going to create a S3 bucket so that we will first try to access without the VPC endpoint. So here you can see in this diagram, there is no VPC endpoint. So let's try to access this S3 without the VPC endpoint. Are we able to access that S3 or not? Go back to our AWS console, and this is my private EC2 instance. So here I'm just going to run the command AWS S3 ls. So this is the AWS command for listing the S3 bucket, and hit enter. And here it is asking AWS configure your AWS credential, because this EC2 instance is there, but it is not, this EC2 instance is up and running, but it is not aware about the credential of this AWS environment so that it can access the S3. So we need to configure the credential. So I'm just going to go back to my AWS console over here. I'm just going to type AWS configure command. And here it is going to ask for the access key. So I'll just copy my access key from my notepad and I'll just paste it over here. So here's my access key. And after that, I just need to enter my secret. So I'm just going to copy my secret from the notepad and paste it over here. And the default region, so I'm just going to check the default region. So here it is Ireland. So I'm just going to use EU West 1. So I'm just going to put EU West 1, hit enter. And hit enter. All right, so now my access key has been configured. I'm just going to clear the screen, and then I'm just going to run the command AWS S3 ls. And here you can see it is just waiting and waiting. It is not able to get the response back. Although I have some S3 bucket already created onto my AWS console, which I can show you. So if I go and search here the S3 bucket, then click on S3 bucket. And here you can see there is this test VPC endpoint bucket, and there is also this VPC endpoint bucket. But ideally it should list all the S3 bucket over there onto my terminal, which it is not listing because it doesn't have a VPC endpoint. That's the simple answer. Okay, so I'll go back to our slide over here. So now we have seen this scenario. So let's go back and start creating our VPC endpoint. So our VPC endpoint will sit somewhere here where we will create a connectivity between our private subnet. So let's go back to our AWS console, go to the home page over here, and here in the search box type VPC, click on the VPC over here. And from the left navigation menu, you will find the option for an endpoint. So click on endpoints over here, and there is no endpoint which exists onto my AWS account. So click on create endpoint over here, enter the name. So I'm just going to put demo endpoint. It just type over here. So just put demo endpoint over here, click on AWS services. But the key thing over here is you need to define like what kind of a services it will be consuming or using. So here we need to specify S3 because we are just using this VPC endpoint for S3. So in the search box, type S3 over here and click on this COM AWS EU West 1. And remember, try to use the suitable region, otherwise you will be in a trouble. So I'm working in the EU West 1 region, so I'm just going to choose that one. And here there are a couple of it. So gateway and interface. So we are just gonna stick with the gateway because interface is something different, which we will cover in upcoming session. Okay, so that's a heads up. And in the VPC endpoint, so just click on select this one and click on demo VPC endpoint because that's the VPC where we are working. This whole setup is working over there. So select this one. And from that, again, if you take a look onto this diagram once again, so here I'll just try to sketch something. So this VPC endpoint is there, which we can see, but this VPC endpoint needs to communicate to this private subnet because this EC2 instance is present over here. So that's the key thing. So you have created a VPC endpoint, you have assigned that it should communicate to S3 or it should use the S3 service, but it still need a reference to which subnet from where it should be able to make the communication. So that is going to be our private subnet. Okay, so I'm just going to close this sketch and go back to my AWS console over here. So here you can see our public subnet and public route table and private route table. So this private route table, I should correct you over here once again. So here I mentioned the private subnet, but instead it should be pointing to the private route table. So that's the one correction from my side. So it should point to this route table so that EC2 instance can use this route and then it should be able to communicate from here. And also it should be able to use this VPC endpoint altogether. Okay, I'll just cancel this one now. Okay, so here just select the private route table because this private route table belongs to private subnet and then private subnet. In the private subnet, we have our private EC2 instance. Okay, and then after that, just click on create VPC endpoint. And here you can see our VPC endpoint has been created. I would like to take a pause over here and I would like to tell you more about my YouTube membership where I keep on uploading some other private sessions for my YouTube member. So here you can see there are some of the sessions which I am performing using the Terraform. So the same session which I have also prepared using the Terraform for setting up the VPC endpoint. So if you are a member of, or if you are a subscriber of, or if you like this kind of a content, then also there is a membership program which you can be a part of. And also please try to be a subscriber to this channel because that gives me a good boost to create similar kind of a content for you and to keep myself motivated. So just try to be a subscriber or just try to be a YouTube membership program so that you can get a more perks or more learning from DevOps and AWS side. Okay, so let's get back to our topic. Alright, so now we have set up our VPC endpoint, so we should be able to access our S3 bucket from our private EC2 instance. So let's go back to our console over here and let's run the command AWS S3 ls and hit enter. And here you can see our S3 buckets are visible over here. So with that, we can say, let's take a look onto the diagram once again. So with that, we can say that our private EC2 instance is able to communicate with our VPC endpoint, and with the help of that VPC endpoint, we are able to communicate with our S3 bucket, and we are able to list the S3 bucket which we have set up apart from the VPC, which are not present into our VPC. I hope you enjoyed the today's session on setting up the VPC endpoint. If you are interested into the similar content, then please considering subscribing to this channel so that I can keep on creating similar content for you. And also, if you are interested into some more premium content, then consider to be a premium member of this particular channel, where you will see a more in-depth sessions using Terraform and more AWS or DevOps topics. So see you into the next session. Till then, take care and bye-bye. Hello there, this is Rahul, and today we are going to talk about the AWS PrivateLink, also known as VPC Endpoint Service. As you can see onto this diagram, so this is our target setup which we are going to perform into the demo. But before that, let's try to understand what is this AWS PrivateLink, which we call it as a VPC Endpoint Service. So AWS has designed this service to provide a connectivity between the VPCs, between the various AWS services from the marketplace, and also you can use this service to connect your on-premise servers to your AWS VPCs. Now, what are the advantages of using the AWS PrivateLink or VPC endpoint service? So this service provides you a way so that your request doesn't need to go through internet, and everything will happen in a secure within the AWS environment. And with the help of AWS PrivateLink, not only you can connect multiple VPCs, you can also connect your on-premise servers data center to your AWS environment, and everything will be secured. So all the requests from your data center, which is like an on-premise data center, will directly go to AWS without traversing the internet. To simulate this whole use case or this particular demo, I have created two VPCs. One is the consumer and one is the provider. So here you can see this is the consumer on the left hand side and provider on the right hand side. But don't worry, this picture or this diagram might look overwhelming to you, but we are going to break everything into bits and pieces, and we are going to target each component in this demo. And also one more thing, for this particular demo, I don't own a physical data center. So assume this consumer VPC as your physical on-premise data center. So we will be making a request to our provider, like a provider VPC, which is providing the services, and this consumer is going to consume those services. So for this particular demo, although I'm doing from VPC to VPC, but this consumer VPC can be your on-premise data center. It can be any other services which is running in any other VPC or any other AWS account. So that's just one assumption I would like to make before we proceed into this particular demo. Also, one more thing, let's have a look onto the request flow, how the request will originate from the consumer and it will end up onto our service provider VPC. So here on the consumer side, a request will be originating, and that request can originate from a server that is running inside our private VPC. That will end up onto our VPC endpoint, and from there the request will be forwarded to our AWS PrivateLink, and then AWS PrivateLink will forward that request to our network load balancer, and then it will end up into our service provider EC2 instance where our application is serving those requests. So that's the typical request flow for this whole setup. Let's not make the whole process really complicated and start with our first step, which is our setting up our VPC. So now if you take a look onto the diagram, so now I have removed everything, and now we will first work onto the provider side. And the first thing which we need to do over there is to set up the VPC for our provider. So I'll jump back to my AWS console, but before that, the VPC should have a CIDR range, and the CIDR range I'm talking about over here is 11.0.0.0/16. So that's the IP range we are going to assign when we are creating our VPC as a first step. Alright, so this is my AWS console. In the search box, type VPC, click on the VPC over here. Click on create VPC and select VPC only. The name, just put the name service provider. The IP range, which I told you, 11.0.0.0/16. So this is the IP range for my service provider VPC. Tenancy, I'm just going to keep default. Everything I'm just keeping it default. Then just click on create VPC and click on your VPC, and here you can see our service provider VPC is ready. Let's take a look onto the second step, and the second step we are going to create a subnets, and the subnet I'm talking about is our public subnet and the private subnet within our provider VPC. So here you can see there are two subnet which I will be creating, and in the subnet we will be creating two availability zone subnets. So there will be two public subnet and there will be two private subnet. So here you can see the IP ranges. So in the IP range, the first public subnet will have 11.0, 1.0, and the second public subnet will have 11.0, 2.0, and similarly 3.0 and 4.0 for our private subnet. And both the subnets will have a different availability zone for maximum availability. So one VPC and 4 subnets. That's the approach we are going to take it. So this is my VPC dashboard. So on the left hand side, you will find an option for a subnet. So click on subnets over here, click on create subnet. And since if you take a look onto the diagram, then we are working in the service provider VPC. So we need to choose that VPC which we have just created. That is our service provider. After that, you need to enter the name. So I'm just going to copy the name which I have already put it onto my notepad. So this is the name of my first subnet, which is service provider public subnet 1A. 1A is for availability reason, to distinguish like in which availability zone I am running this subnet. Okay. From the availability zone, select Europe Central 1A. Just choose whatever region you are working. Just choose a suitable region which is available onto your region where you are working. Okay. The IP range. So here I'm just gonna stick with my IP range which I just shown you into the diagram, which is 11.0, 1.0/24. And if you reduce the number 16, then you will get a higher IP ranges for your subnet. But let's stick with 24 because of demo. Okay, the next thing I'll create one more subnet, which is again going to be public subnet. I'll just copy the name from my notepad once again. So let's copy it, paste it over here and make it a 1B. And public subnet, that's good. Availability zone, let's choose 1B. And the IP range, I'm just gonna keep it as 2.0 over here /24. Okay, so now our both public subnets are there, but I have not created yet. I have just provided the configuration. Add one more subnet, and here I'm just gonna put the name for my private subnet. So I'm just gonna copy the name and put it private over here. Okay, let me check once again. What's the name? Service provider public, that's correct. This is public, that's correct. And the third one, that is private. Okay, availability zone, I'm just gonna create 1A in private, and the IP range I'm just gonna put over here. Let me copy the IP range once again and put it 3.0 over here. Okay, and after that, click on add one more subnet, and I'll just copy the definition from here. Go here, put it and change it to 1B. Change availability zone to 1B. IP range, I'm just gonna copy once again, put it over here and make it a 4.0. All right, so now we are having all the four subnets within the VPC. That is private 1B, and this is private subnet 1A. That's good. Public subnet 1B. That's also good, looking good. And this is public subnet 1A. All right, and then after that, click on create subnets over here. And here you can see all the 4 subnets has been created. I'll just close everything over here. I just want to remove the filter so that I can show you. And here you can see all the 4 subnets are ready. All right, so now we have created the VPC, we have created the subnet. What's the next step? So now we are going to set up our internet gateway, and this internet gateway we are going to set up for our public subnet, which is over here. Because we will be setting up our EC2 instance into our public subnet, and we need to access that EC2 instance. That we are going to see it later. But just keep in mind, we are going to set up internet gateway, which will provide an internet access to our public subnet. So let's go back to our AWS console over here, and in the left navigation menu, click on internet gateways over here, click on internet gateway. And here I'm just gonna keep the name service provider internet gateway. So I'll copy and paste it over here. So service provider IGW for internet gateway. Click on create internet gateway. And here you can see our internet gateway has been created, but it is not attached to our VPC. So if you take a look onto the diagram, so this internet gateway is there, but it is not attached to this particular VPC, which is our service provider VPC. So go to the actions, click on attach, and then here you will find the option for a service provider. So attach to that one and click on attach internet gateway. Okay, so now we have attached our internet gateway, and this internet gateway is now available for us. Let's move further, and the next step is we need to create a route table. So let's take a look onto the diagram. So the route table we'll create one public route table for our public subnet and one private route table for our private subnet. So let's go back to our console over here, and from the left navigation menu into the VPC dashboard, you will find the options for a route table. And here you can see this is the default route table. We are not going to use that one, but we are just going to create a two route table. So click over here, and I'll just copy the name from my notepad and paste it over here. So service provider public route table. So I'm working on this public route table over here. Okay. VPC, again, we are working into service provider. So select that one and then hit on create route table. Okay. Again, we need a one more route table, which is this private route table within our private subnet. So go back over here, click on create route table, paste the name, change from public to make it private. Select the VPC, which is our service provider, and then click on create route table. Okay. Now route tables are ready, but these route tables are not associated with our subnet. So we need to associate this public route table to the public subnet and private route table to our private subnet. Okay. So go back over here, click on the public route table, and here you will find a subnet association. So click on this, and here you will find this is empty. So click on edit subnet, and we will attach this to or associate this with our public subnet. So like public subnet from the list, save association. And similarly, let's verify that one. So here you can see our public subnet has been associated with our public route table. Similarly, go to the private route table, click on route table, subnet association, edit association, and select the private over here. Okay. Click on save association. All right. So now our route table has been associated. So if you take a look, this route table has been associated with this public subnet, and this one is with our private subnet. Now there is one more thing. We need to attach our internet gateway route, or we need to create our internet gateway route with the route table, so that any request which is falling onto this subnet will route it via this route table into this subnet. Okay. So for that, go to your browser, AWS console, click on public route table, and remember, we are working into public subnet. So public subnet will have an internet access, and we have already created an internet gateway, but we need to create a route for that internet gateway so that request can follow to the route table, through route table to our VPC. Okay. So here in the routes, click on edit routes, click on add routes over here, and here enter the IP range. So this is the IP range 0.0.0, which means it is available for everyone for internet. Okay. And how we are going to route that request? So using the internet gateway. So select internet gateway, and here you can see the same internet gateway which we have just created in the previous steps. Select that one, click on save changes. And now our public route table is having internet access with the internet gateway, as well as our subnets are associated. But keep in mind, our private subnet will never have access to internet gateway, because those are some private resources running into private subnet, and we don't want to expose those resources. So take a look over here. So here you can see there is no routes defined for internet gateway into our private route table. And so subnet association is only for our private subnets. Moving further, the next step where we will be taking a look is to create our EC2 instances. So let's take a look where the EC2 instances will reside. So here you can see we are going to create an EC2 instance into our public subnet as well as into our private subnet. Okay, so let's go back to our AWS console over here and go to the home page, and here click on to this EC2, or either you can, in the search box, you can also type for EC2, click on this EC2. And here there are no instances running, but we will click on launch instances. And here I'm just going to copy the name, and I will just copy the name from my notepad and put it over here. So let's first create a public EC2 instance service provider, or I'm just keeping the name, but our public EC2 instance, I'm talking about this EC2 instance, which is present into our public subnet. So I keep the name public EC2 and service provider. Okay, so that we can identify that this EC2 instance belongs to our service provider VPC. I mean to say this provider VPC. So that's why I have created this name. All right. So here, choose Amazon Linux over here, and I'm just keeping everything default over here because I'm just doing it for demo purpose. And in case you need a higher CPU, then just change the instance type from T2 micro to some higher level CPUs. So that's up to you. Okay, so let's reiterate the whole thing. So this is the name. I'm going with the Amazon Linux. I'm just going with this AMI, which is the default one available over here, T2.micro. Key pair, I'm just going to create a key pair so that I can SSH into this EC2 instance. So I'm just going to click on create key pair. So I'm just going to put service provider EC2 public instance key. Okay, so that's the key for my EC2 public EC2 instance. Then just click on create key pair, and here you can see the key has been downloaded for you, and this is going to be your private key which you need to use later to SSH into this EC2 instance. Okay, and the public part of that key is already associated with your EC2 instance so that you can SSH and that key will work for you. Okay, so we are just going to use this key later. Just download it and keep it somewhere for your later use. All right. Next is the network setting. So click on edit network setting, and here we are working into our provider VPC. So I'm just going to choose from the drop down like a service provider. Subnet, I'm just going to choose the public subnet. So here let's go ahead and choose our public subnet 1A. Okay. After that, we are working into public subnet, and this is our public EC2 instance. So we need to have this public IP enabled, and this EC2 instance will have access to internet. That's why I'm enabling the IP as well. Okay. Security group. So I will just enable the security group, which is 22, because we need to SSH into that EC2 instance. So that's why I'm just enabling the port 22. And later, if we need, then we are just going to enable furthermore security group, but we will take that later. All right. So after that, I'll just click on the launch instances. Okay. All right, so now my instance has been launched. So here you can see it is in pending state. So I'll be back once this EC2 instance is ready. All right, so now our EC2 instance is up and running. So let's do the SSH into this EC2 instance to verify our key. And we are just gonna create one more EC2 instance into private subnet, but let's try to see how to use this particular key first of all. Alright, so here is my terminal, and I would like to show you the key first of all. So here you can see this is the key which is present onto my directory, and if you are using the Windows system, then it should be somewhere into your downloads directory. So just copy that particular key to some suitable directory where you can work upon later. And you can even use the putty in your Windows system to perform these steps. I'm using Mac, so I have some different utility I'm using, but if you are using putty or git bash, then these commands will work over there as well. Okay, so the first thing we need to do over here is we need to check the permission of the key. So here you can see it has a read and write permission. So before you start using this private key, this is actually your private key ending with the .pam extension. So you need to change the permission to make it read only. So for that, I'll just clear the screen, and the command is chmod 400 for making it read only. And then you need to enter the name, which is service provider, whatever key name you have given to it. Hit enter and then run the command lslart, and here you can see now it is a read only key. Okay, I'm just going to clear this screen, and now we need to SSH or connect into my public EC2 instance, so which is running over here. So click on this instance ID, click on connect, and here you will find the instructions. So you don't need to remember anything, you will just find all the instructions over here. So here you can see this is the command which I have already run, ch400, to make it a read only. This is our IP, which is our public IP if I'm not wrong. Let's check. So yeah, this is our public IP. Click on connect once again, and here this is the command for SSH into your EC2 instance. So just copy this command from here, go to your terminal once again and paste that command over here and hit enter. And here it is asking, are you sure you want to connect? Type yes. And here we are into our public EC2 instance, which you can see over here, which is 11.0.1.10. So here you can see in the instances, this is the private IP address, which is correct. And we are logged in into our EC2 instance. And also one more thing I would like to give you a heads up. So here in the subnet, for this demo, I'm just gonna use only one public subnet, and we are just gonna create only one EC2 instance. But maximum availability, you can have a multiple EC2 instance into multiple public subnet. But for this particular demo, I'm just sticking with a one EC2 instance over here into public subnet and one EC2 instance into our private subnet. But I have created two private private subnet, and I have created two public subnet, but I'm not gonna use those. But if you have a need, then you can use it. But I'm just keeping the thing simple. That's why I'm just creating only one EC2 instance, and I'm using only one public subnet and one private subnet. So that's just keep in mind. That's for demo purpose. I'm just keeping the things minimal over here. All right. Okay, so now our EC2 instance is accessible. Our public EC2 instance is accessible. Let's work on our private EC2 instance, which is over here. Okay, so go back again to your AWS console, EC2 dashboard, click on launch instances. I'll just copy the name meanwhile from my notepad for my EC2 instance. And let me check the name over here for my public EC2 service provider. I'll just copy the name. Click on launch instances once again to create an instance, and here instead of public, make it as a private. Okay, here I'm sticking with Amazon Linux and T2.micro and key pair. I'll create a new key pair for my private EC2 instance. So here I'm just gonna enter the name. Maybe I can copy from my previous key as well. So I'm just gonna copy this name, but I'm just gonna change it to private. Okay, and make it as a private instance. So this is the key for my private EC2 instance. All right, and then click on create key pair, and here it has downloaded that particular key to us. Okay, and after that we need to work on the network setting, because this EC2 instance, if you take a look, then this EC2 instance is present into private subnet. So we need to choose the correct VPC, correct private subnet, and then we need to launch the instance. So here, click on edit over here, choose the VPC, which is our service provider. Subnet, I'm just gonna go with private subnet 1A, which is this one. And enable public IP, no, we don't want, because this needs to be disabled, and this is over here, this is into our private subnet, and this doesn't need any public IP address, so that's why I'm not putting it there. Okay, and moving forward, SSH port, yes, we need to have a SSH port so that we can SSH from our public EC2 instance. So we will be using this as our Bastion host. And if you don't know about the Bastion host, then just take a look on to one more session which I have previously uploaded for Bastion. So just follow that concept. But to give you a brief, to secure your private EC2 instance, we only allow our public instance present into our public subnet to access this EC2 instance. Okay, because both are present into one VPC, so our public instance will be able to access that EC2 instance into private subnet. But anyone who is outside of this particular network will not be able to access this private EC2 instance. So that's why we need to have a public EC2 instance, which we also call it as a jump box or Bastion host. So this is already up and running, and now we will use this instance to SSH into this private EC2 instance. Okay, but anyway, let's first launch this instance. So here, this is the security group 22 for SSH port enabling. And after that, I think everything looks good over here, and I'm just going to click on launch instance. And our instance is launched. Let's wait for a couple of minutes, and the state should change from pending to running. All right, so now my instance is up and running. So click on this instance ID, and here you can see there is no public IP, but only the private IP which has been assigned. And the IP range, if you'll see, it is ending with 3 over here, 3.50, but it's the key thing is it's ending with 3. And if you take a look onto the diagram, then our private subnet is and have a range of 3.0/24. Means all the instances or all the resources will get the IP ranges which is ending with a 3 dot star or 3 dot something. Okay, so that's our private EC2 instance. All right, now what we need to do is we need to SSH into this instance as well. Okay, so what we will do, we are already logged into this public EC2 instance, and from here we are just going to use that key to SSH into this particular EC2 instance. Okay, so let's go back to our console over here. So this is my public EC2 instance, which is 1.10, which is ending with 1.10, and now we need to first copy the key of this instance. Okay, so for that, I'm just gonna open that key into my notepad, and I'm just gonna show to you. So this is the key. If I can reduce the size of this notepad over here, I think that's looking good. Okay, so this is the key which we need to copy into our public EC2 instance. Okay, so here I'm just gonna drag it on this side. I'm just gonna open the terminal over here, and let's copy this name. I'm just gonna rename it also. Just copy this for the time being. I'm just gonna clear the screen, and I'm just gonna first of all create the file over here and make it as a private key. Okay, hit enter. And then open that file, because here we need to paste the content. So here I'm just going to open it, and here in the notepad you can see this is the content of the key. I'm just going to copy everything. I'll move it here, and here I'm just going to paste. I'm just going to escape, save, and quit. And now my key is there for my private EC2 instance. Now we need to change the mode. So I'm just going to put it 400 over here, and then I'm just going to put the name. Let's verify the permission. And here you can see the permission is only read. Okay, then clear the screen, and let's go back to our private EC2 instance. So this is our private EC2 instance. Follow the connect instructions, and here you can see this is the command. While creating the key, I just put these extensions. That's a typo mistake which I have did it, but keep in mind whatever the name. So here you can see it is ending with this. This is the file name of my private key. So I'm just going to use this name. So we need to tweak this command. So that's a typo mistake I did. So just keep in mind, just whatever file name you have created for your SSH key, use the same name. Okay. So go to terminal, paste the command over here, and we need to change it to make it back. Okay. Hit enter, type yes. And now we are logged into our private EC2 instance, which is ending with 3 and 3.50. So that's our private EC2 instance. All right. And this particular instance doesn't have access to our internet. So if you take a look, ipinfo.io, and here you can see it is not able to ping anything. Okay. And I'll clear the screen once again. I can show you google.com. It is not able to ping. Okay, so this instance doesn't have an internet access yet, and we will see in the next step how we can install our HTTPD server onto this EC2 instance, so that we can do some activity, or we can create some basic HTML pages so that we can access that page from our public EC2 instance. Okay, so let's take a look onto the next step for this particular demo. Okay, so let's take a brief look what we have achieved so far. So we are working into this provider VPC. We are able to set up VPC, Subnet, Internet Gateway, route table, EC2 instances, and both EC2 instances are accessible to us. Okay, that's fine. Now we need to install an HTTP package or HTTP server onto this EC2 instance, so that we will be able to access that particular page for this particular testing. All right, because that page we will try to access it from our consumer VPC, which we have not built yet. We are just going to build it soon. Okay, so let's work on this private EC2 instance and install our HTTP server onto it. Okay, so for that, right now, if you can see over here, so here we don't have the access to internet, so we cannot install any certain packages. So to solve that, we are going to use the NAT gateway. So we are just going to enable the NAT gateway so that this particular EC2 instance can make a request outside, which means it can access the internet from within the EC2 instance to the outside, but no one from outside can be able to access this EC2 instance. So that's the NAT gateway we will set up temporarily for installing those packages. And once those packages has been installed, then we are just going to remove the NAT gateway. But ideally, what happens in actual practices, we never allow any internet access from outside, and even if you are giving the NAT gateway access, then it is also quite restrictive. So for this demo, we are just gonna enable NAT gateway temporarily to install that Apache or HTTP server. Once we are installed, we are just gonna remove it, and then we are just let it running onto our EC2 instance, which is present into our private subnet. Okay, so go back to our AWS dashboard, and here on the home page, go to VPC, click on VPC over here, go to NAT gateways over here. So here you can see this is the NAT gateway, and here click on create NAT gateway, and service provider NAT gateway. So that's the abbreviation I'm using. And since the NAT gateway is access to internet from a VPC, so we need to choose a subnet where internet is available. So the internet is available onto our public subnet 1A, which is this one. Because if you take a look onto this diagram, then this is the public subnet where we have an internet gateway and it has an internet access. So we are just gonna select the public subnet for creating our NAT gateway. Okay. So now we have selected the public subnet, then we need a elastic IP for that particular NAT gateway as well. So allocate the elastic IP over here, and then click on create NAT gateway. And here you can see our NAT gateway is into pending state. So once it is up and running, I'll back and I'll show you what next needs to be done. Alright, so now my NAT gateway is available, and if I take a look onto the diagram once again, so now our NAT gateway has been attached. I have not put that element, but just parallel to internet gateway, you can assume that there is a NAT gateway in our public subnet. Okay. Now this EC2 instance in our private subnet needs to access the NAT gateway so that we can install our HTTP server onto this EC2 instance. Okay. So go back to your AWS dashboard, and here we need to update the route table for that. So we need to go to the route table, choose the private route table because we are working into this private subnet and route table is private route table. So this is our private route table over here. Click on edit routes, and here add routes, put the 000 over here so that it can access the internet. And here we need to choose the NAT gateway. And here you will find the NAT gateway which we have just created. Select that one, click on save changes. And here you can see our route table has been updated with our NAT gateway, and our this subnet or this route table now have a route for a NAT gateway, and NAT gateway can access the internet. So this EC2 instance will be able to make a request to internet. But remember, no one from internet can make a reverse request to this private VPC. That's still it, because it doesn't have a public IP address assigned, and as well as it doesn't have an internet gateway with this private subnet. Alright, so it's still residing into our private subnet, but now it has access to internet using the NAT gateway. Alright, so let's go back to our terminal, and here you can see, oh, it is started pinging already. So I can show you once again. So I'm just going to clear it. And here you can see 11.3.50, that was our private EC2 instance. I can show you once again. Go to EC2 over here and click on EC2, and this is our private. Click on instance ID, and here you can see 11.3.50. And what I was showing to you is that I previously run the command google.com. It was not able to ping it, but now you can see it started to pinging. So now it can access the internet from our private EC2 instance. Okay. So I'm just going to clear it, and now we need to install the HTTP or Apache server. So I'm just going to copy this command and just going to paste it over here. So this is going to install HTTPD server. Okay, so here you can see the status has been complete and it has been installed. I'm just going to clear the screen. And the next thing which we need to do is we need to check the status of that particular instance. So I'm just going to paste it over here, and yeah, it is not started yet. Here you can see the status of this particular HTTP server is not starting, or it is not started yet. All right, but before that we need to create our basic HTML page. So for that, let's use Google. I can do it, but I'm being lazy over here. Sample hello world HTML page. So let's open this one. And let's see if I have a code over here. So I think we can use this one. Okay, just copy this content, go to your terminal, and here now we need to go into the directory, and we need to create a file. So I'm just gonna use sudo touch, and then we need to go into var and www.html, and here I'm just gonna create a file that is index.html. Okay, then I'm just gonna open the same file into the edit mode, go html and index.html, and paste the content, and here I'm just gonna put into the head section. Okay, so here let's put h1 for heading, sorry, and here I'm just gonna close the h1, and this is a demo for AWS PrivateLink. Okay, and this is provider, service provider, VPC service provider EC2. Okay, so that's the content I have pasted. Save and quit. After that, we need to start that particular HTTP server. So I'm just going to paste the command over here. So this is the command for starting it. Let's check the status of the instance. This is the command for checking the status, and here you can see it is up and running. Okay, I'm just gonna clear it, and now we have installed that HTTP server. Then we can curl the page. So I'm just gonna use localhost, and here you can see it is giving me the response back. This is the content which I have written into my HTML page. So that's the content. Since there is no browser onto terminal, so that's why we are just seeing the HTML content from here. Okay, so now our EC2 instance has been set up. We have installed the required package or sample page to verify this whole setup later. And one thing which we need to do now, we can remove the NAT gateway from here. Okay, so for that, because we have already installed this HTTP server, and we don't need that NAT gateway now. So go back to our VPC section. So in the search box, type VPC over here, go to the VPC, and here go to NAT gateway, click on the NAT gateway and click on action and delete NAT gateway. Type delete over here, and it is getting deleted. And also you need to release the elastic IP. Since this NAT gateway is still in a deleting state, so it will not allow me. So later on during the demo, once this NAT gateway has been deleted, we are just going to remove that elastic IP as well. Okay, so let's refresh it. It is still deleting, but we can do one more test over here. This is my private EC2 instance, and now try to do the ping to the Google. Let me run that command over here. And here you can see now it doesn't have the internet access. So now our private EC2 instance is completely isolated from outside. Neither it can be accessed from my internet, nor it can make a request to the internet. Okay. All right. So that's been done. Let's move ahead and take a look onto the next step. So the next step we are talking about is setting up a target group. So if you take a look onto this whole PPT once again, if I show you this diagram once again, so we are still working on this provider section, and I'm just going to show you one more thing over here, which is this one. So we need to set up our network load balancer, but for setting up this network load balancer, we need a target group. Okay, so that's what we are gonna do. All right, so let's go back to this PPT once again, and we were somewhere here. Okay, yeah, that's correct. Let's play it, and yeah, this is the target group. We need to set it up. Okay, I'm just gonna remove it from here. Okay, so the target group here, we need to create a target group, and this target group will contain a EC2 instance. So target group is just a logical grouping, so that a network load balancer, assume this is a network load balancer, this is a target group, and this target group can have a multiple EC2 instances. That's a logical grouping we need to do in the target group. Okay, so we need to create this target group. So for that, go to your AWS console over here. In the search box, type EC2. Go to the EC2 over here. From the left navigation menu, go to the targets group, create target group, And the type should be instances because we are working with the EC2 instances target group. So I'm just going to choose that one. Target group name. So I'm just going to copy, or let's write it over here. Service provider target group TG. I'm using it for abbreviation. Protocol port. This is important. We will be working with the network load balancer, which we have not created yet. But since this whole setup requires a network load balancer, so we need to choose the TCP in the target group because that's the only protocol which will be working with the network load balancer. So choose TCP over here, port 80. Yes, that's the default port we are going to use. VPC. So take a look over here. So we are working into the provider VPC. So from the drop down, choose the provider VPC over here. Okay. Health check, keep it same. Don't change anything over here. Click on next over here, and here take a look again. And this is our private EC2 instance. I want this to be included into the target group. So here from the drop down or from the checkboxes, select this private EC2 instance, include as pending below. So this is our target group where we are including EC2 instances. And remember, this is demo, that's why it is only one EC2 instance, but in actual there could be multiple EC2 instances into private subnet. And using this target group, you can attach those EC2 instances. Okay. But keep in mind, this is demo. I'm just keeping it only simple things over here. So I'm just including only one EC2 instance. Create a target group. And now our target group has been created. Okay. And the status, we need to check the status later once we set up our network load balancer. But for the time being, it is created and it is there. Okay, let's move ahead and let's take the next step, what we are going to do. So the next step is we need to set up our network load balancer and where it will sit. So here you can take a look. And also one more thing, I am running out of space in putting more and more elements over here. So now I have reduced the target group a little bit smaller over here. But I just wanted to mention that thing so that you can understand. So we are already included that target group. Now we will be working on to the network load balancer. Now we need to create a network load balancer. So again, into the EC2 dashboard, we already created the target group. So in the same section, in the load balancing, you will find a load balancer. Click on it. Create load balancer, and now we need to create a network load balancer. So just take a look over here. So this is network load balancer. We are just going to create this one. Okay. And click on create load balancer name. So I'm just going to put service provider. Sorry, I just put something wrong. I'm just going to click on create once again. I just click on backspace. Here I'm just going to put service provider net NLB. I'm just keeping the abbreviation NLB for network load balancer. Scheme, we don't want internet facing. We just want everything internal. So I'm just going to keep it internal. Network mapping. So here you can see the VPC where we are working. So we are working into the service provider VPC. Select that one. And here we need to choose the subnet. So I'm just going to choose service provider private subnet 1A. And here I'm just going to choose service provider subnet 1B. Okay. So both the subnets has been selected over here. And security group. So this is the default security group over here. So what I can do, I can just add one more port into that security group. So go over here and type security group, or you can create a new security group as well. That's up to you. So that security groups, maybe I can go to the EC2 instance and from the left navigation menu, click on security group and put that ID over here. Select that. And here you can see it is traffic which is allowing. So I can add it inbound rule. I can add one more rule for port 80 over here and choose 000. Okay, so that's a one more addition I have done it. Click on save. So I just modified the same security group which is assigned to me by default, or you can create a new security group from here and you can attach it from here as well. Select that one. Okay, so that's up to you. Secondly, here we need to choose a target group. So if you take a look, this network load balancer needs to point to the target group. So here we are assigning that target group, and the target group is this one which we have just created. Select that one. And after that, yeah, everything looks correct to me. And after that, I'm just going to click on create load balancer. And here you can see the load balancer right now into the provisioning state. So it might take a couple of minutes. So I'll be back once this load balancer is up and running. Alright, so after a couple of minutes, my network load balancer is up and running and the state has been changed to active over here. Okay, so let's take a look onto the diagram once again, and now our network load balancer is up and running. Okay, so let's take a look onto the next step, and the next step is we need to set up our AWS PrivateLink, or we can also call it as a VPC endpoint service. Okay, so how to do that? So here, this is the VPC endpoint or private link which we need to point it to our network load balancer. So to do that, what you need to do is in the network load balancer section, you can go to the integrations, and here you will find an option for a VPC endpoint service, or we can also call it as AWS private link. So this is a one option. From here you can go and create an endpoint service. Second option, I'll open one more tab. It's the same option, it's just a different way of creating it. Go to the VPC section, and here in the left hand side you will find the endpoint services. So it is also the same thing. Okay, but just it's a bit confusing there, but I don't know why, but just keep in mind. Okay, but anyway, I'm just gonna go to my network load balancer over here. So this is my network load balancer, and here I find the option for a endpoint service. Click on create endpoint service and click on create endpoint service over here, and here I would put service provider endpoint service. I can put it like this. Okay, next we need to choose the load balancer type, which is network, because we are working with the network load balancer, and here you can see it is already populating the name of the network load balancer which we have just created. So select that network load balancer. And after that, additional settings, supported IP address type. So I will just go with the IP4. If you are working with the IP6, then go ahead and choose IP6 as well. That's not a problem for you. And after that, just click on create, and our endpoint service endpoint for our VPC has been there. Okay, so let's take a look onto this once again. So this is the endpoint service, VPC endpoint service or AWS private link, and the state is available for us. Okay, so before we move forward, let's take a look onto the diagram and what we have achieved so far. So I think our provider section is pretty much ready. We have a VPC, Subnet, Internet Gateway, EC2, route table, network load balancer, target group, and our VPC endpoint service. So what's the next step? So in the next step, we will start setting up our consumer VPC. So if you take a look over here, then I'm just going to start setting up my consumer VPC. And here, first thing we need to set up is our VPC, which is our consumer VPC with the IP range 21.0.0.0.0, so that we can differentiate what is our consumer and what is our provider VPC. Okay, so let's go back to our AWS console. I'm just gonna close all the tabs so that there's no confusion. Go to search box, type VPC over here, click on VPC, create VPC, VPC only. And here the name, I'm just gonna keep the name as a service consumer. I'm just copying it from my notepad. IP address, I will also copy it from my notepad and put it over here. Sorry, not here, but it should be here. Okay, so that's the IP range for my consumer VPC. Tenancy default, click on create VPC. Okay, so VPC has been created. Let's go and create the subnets as well. So click on subnet. These are our service provider subnets, which is already there, but we need to create 2 more subnet. Okay, so here I'm just gonna choose now service consumer VPC because I am working onto the consumer side now. Okay, so here is my consumer VPC. All right, so here now I will just create only one public subnet and one private subnet just to keep the thing simple. All right, so I'm just going to copy the name from my notepad, put it over here. So this is going to be my public subnet for my consumer VPC, availability zone 1A. IP range, I'm just going to keep it to 1.0. Okay, and add one more subnet, and here I'm just going to keep it private subnet. Okay, so remember in our provider we have created 2 public and 2 private, but here I'm just keeping the thing simple, so creating 1 public and 1 private subnet. All right, choose the zone 1A over here, and the IP range I'm just going to choose is this one. All right, and after that we are good. Everything looks good over here, and then just click on, maybe I can make it a 3.0 because in the private subnet we had the range in our provider VPC 3 and 4. So let's choose 3.0 for this private subnet as well. But still, it's starting with 21 and our service provider started with the 11. Okay, create subnets, and our subnets are there. And take a look onto the next step, what we need to do next. So yeah, subnets. Yeah. So here, consumer, we created the VPC, we created the subnet, both public subnet and private subnet. And remember, here I have mentioned 2 IP ranges. So in the diagram, I was supposed to create 2 public, 2 private, but I'm just keeping the things simple and creating 1 public and 1 private subnet. But steps are exactly the same. Okay, let's move ahead. And the next thing is we need to set up our internet gateway, and internet gateway will be sitting on the public side of our consumer VPC. Okay, so go to your internet gateway over here, click internet gateway, and the name I'm just going to put it over here is service consumer internet gateway. Click on create internet gateway, go to action, click on attach VPC, and here we are going to choose the service consumer VPC. Okay, click on attach, and here you can see in the diagram. So this internet gateway is now attached to VPC, but now we need to attach it to both to our public subnet. Okay, but before that we need route tables. Okay, let's take a look onto the next step here. What I'm saying here is set up consumer route table. Okay, so yeah, this is the steps I'm talking about. So now we have set up VPC, subnet, internet gateway, and now we are setting up our route table for our public as well as for our private subnet. Alright, go back, and from the left navigation menu, click on route tables, and it should be here. Okay, here it is. Click on create route table. Let's create the public route table first of all. I'm just going to copy the name from my notepad, paste it over here, select the VPC, which is our service consumer, and then click on create route table. And similarly on a private route table, I'm just going to copy the name, go to the route tables, click on create route table, put the name. This is our consumer private route table. Select the VPC, which is our consumer VPC, and then click on create route tables. Okay, so now our both I'll select the VPC over here as a consumer. Okay, so now my both public and private route tables are ready, and here you can see in the diagram. So now both public and private route tables are ready, but we need to associate with our public subnet, and this needs to be associated with our private subnet. Okay, so go back and click on public route table, click on subnet association, go to edit and attach only the public subnet. So click that one, save association. Similarly, go to our private subnet, private route table, click on this private route table, subnet association, edit subnet association, select this one, click on save association. Okay, so now both route tables of our consumer side, this consumer side is now attached to this subnet, and this is attached to this private subnet. But we need to set up a route from internet gateway to this route table, that we need to do into our public route table. Okay, so go back again and go to our public route table over here, which is this one. Click on this one and go on edit routes. Click on edit routes, add route. Click on internet IP address, which is this one. Here internet gateway, and here we need to choose the service consumer internet gateway, which we have just created. Select that one, click on save changes. Okay, so that's been done, and let's take a look now. So I think we have achieved this so far, consumer VPC. And the next step, let's take a look. So now we need to set up our EC2 instance. Okay, so where we need to set up this EC2 instance? So first we will set up into our public subnet, and then we are going to set up into our private subnet. Okay, so go back to our dashboard over here, go to home page, or in the search box type EC2, click on this EC2 over here, click on launch instances. Here I'm just going to put the name. So first of all, let me create a public. So I'm just going to put a public EC2 service consumer so that I can identify. Choose the Amazon Linux. I'm using the default AMI instance t2.micro. Create a key pair. So here I can create a new key pair. I'm just going to put the name public EC2 service consumer key. Okay. Create a key pair, and here the private key has been downloaded for you, and the public key has been attached to EC2 instance. Okay, that's done. Click on edit, and here select the VPC. So that is, we are working into the consumer VPC. Select consumer VPC over here. The subnet, we will be working into public subnet, so select the public subnet, and since we are working into the public subnet, which means this side, so here we need to enable the public IP for EC2 instance. So here on the select enable public IP. Security group, I'm just gonna keep the default, which is SSH22 open for us, and after that we are just gonna click on launch instance. Okay. So now our public EC2 instance has been launched. It's into pending state right now. Okay, so we'll come back and see this later. But in the meantime, let's take a look onto the diagram. And here you can see this is our private subnet. We need to launch one more instance into our private subnet. Okay, so this is our public, which is getting ready. Meanwhile, I'm just going to copy the name and go to the launch instances, put the name over here. Amazon Linux, yeah, I'm just going to choose everything default, and if you need higher CPU, then just choose the correct one. Okay, create a new key pair, so I'm just going to put the key, and I'm just going to put a key name over here. Okay, create a key pair, and the private key is with you and public key attached with our EC2 instance. Okay, network setting, click on edit VPC. We are just going to choose consumer VPC because we are working again into the consumer side, so consumer VPC. Subnet, we are just going to go with private subnet. So take a look, this EC2 is sitting into private subnet. Okay, I select that one. Enable public IP, no, it's a private EC2 instance. Private subnet, so no public IP. Security group, yeah, 22 SSH, that looks good. And after that, yeah, everything looks good to me. I click on launch instances. All right, so now my instances has been launched, and here you can see it's coming up. So let's put the filter over here running, and I'm just gonna put the name as consumer. Okay, so one more instance will be shown quite soon. Here you can see it is in pending state, and we are just looking into only the consumer side of EC2 instances. Okay, meanwhile, let's try to log in into our public EC2 instance, which is this one. Okay, so this is the details. This is the public IP, which you can see, and the instructions for connecting it is over here. So again, these are the same instructions which we need to follow again. So I'm just going to open a terminal once here, and here you can see. So I'll just divide this terminal into the two sections. So let me, yeah, I think it looks good now. So I will divide it vertically, and here I can move this to this side, and probably I can move this section to this side. Okay, why I did so? So this is our private instance from our provider's VPC, and this is on the left hand side, this is our consumer VPC. Okay, now I need to go into the downloads directory, into the demo where I have downloaded the key. I'll just run the ls command, and here you can see the keys which I have downloaded, which is this one, private, and this is the public one. Okay, so I'll just run the command export ps1 so that I can reduce the size of the particular terminal. And let's verify the permissions. So here you can see these keys have a read write permission that we need to change. So I'm just going to do chmod 400, and after that I'm just going to choose this key first of all, public key. That's done, and then I'm just going to choose the another one also, which is this one. Okay, and we have changed the permission. Okay, I'll clear the screen. Maybe I can just do it like this. I'll increase the size of it, lsLART, and here you can see both the keys are now into the read mode. All right, so now let's take a look onto the diagram once again. Now we need to SSH into this public EC2 instance, and from there we are logging into this EC2 instance. Okay, so let's go into this public EC2 instance, and yeah, this is our public EC2 instance. Here you can see public EC2 consumer side. This is the command we need to use for SSH. Copy this one and go to your terminal, and I'll clear it. Paste it over here and hit enter. Type yes to connect, and now we are into our public EC2 instance. The private IP is 21 01102. So which you can see if you go to the instance, and here you can see this is the public private IP of this public EC2 instance. All right. Now the next thing is we need to SSH into this EC2 instance, which is into private subnet. For that we need to have the key. So what I'm just gonna do, I'm just gonna create a key. I'm just gonna copy the name from here, and I'm just gonna run the touch command to create a key. And here I'm just gonna change few things. I'm just gonna name it as a private. Okay, so now I am into my public EC2 instance, and I need a private key of my private EC2 instance. Okay, so if I take a look, so here when I was onto my local system, so these were the key, and I have already used this key to SSH into my public EC2 instance. So already I have used this key to SSH into this one. Now I need a private key for SSH into this private EC2 instance, so which is this one. Okay, which is this one. But I need to copy this key content over here into this EC2 instance. All right, so I'm just going to clear it. I'm just going to open that file. Let me run VI, and I think it's private. Yeah, you need to open in the VI mode, and here these are the contents. If I put it over here, so this is the content of my private key. I'm just going to copy this one from here and go over here, paste it, save and quit. I'll change the mode to 400 and put it private. That's done. LSLART verified. It's in the read mode. Okay, that's done. And now we will do SSH into our private EC2 instance. So go to the instances, go to private, go to connect, and we have already done the permission change. Let's copy this SSH command, go to terminal and paste it over here. And after that, hit enter, type yes. And now we are logged in into our private EC2 instance, which you can see 21.3.165. And if you take a look, 21.3.165. So now we are logged in into our private EC2 instance, which you can see over here. Okay. Let's take a look at what we have achieved so far. So now we have a consumer VPC, we have a provider VPC, and what's the next now? So the next thing is we need to set up a consumer VPC endpoint. So what is that? So as you can see over here, so if I draw something over here, so here you can see this is the VPC endpoint we need to create so that this VPC endpoint can talk to this private link, which we have already done the creation. All right. So now you can start making the dots. So it looks complicated in the beginning, but now we are able to set up all of these elements into this particular diagram. Okay, so let's go back. I'll just close this one and go back to our AWS console, and here onto the search box, type VPC, click on the VPC, and remember we are setting up this VPC endpoint onto the consumer side so that we can consume these services of VPC endpoint, service or private link from provider. Okay, so here onto the left navigation, click on endpoints, click on create endpoints, and here we need to enter the name. So I'm just gonna say VPC endpoint from consumer, and the key thing over here is I'll close other tabs also, close other tabs. All right. Now we need to select the service. So now if I take a look and if I show you, so now we are creating this one, but this needs a service name of this particular private link. Okay, so for that what we need to do, we need to select other endpoint services from this checkbox, radio button, whatever you wanna call it. And here we need to enter the service name, and from where we will get the service name. So you need to open one more tab, go to the VPC section over here, click on VPC. Here go to the endpoint services. So here we have already created this endpoint service. So click on this ID, copy this service name from here, go to the VPC endpoint service, put the name over here and click on verify service. And here you can see our connection has been made, but it is not complete yet. So now our endpoint is able to find that service, which is this one, which is this service. So this endpoint is able to find that service. The next thing is we need to choose the VPC. So where we are working, so we are working right now onto consumer side. So this VPC endpoint is on a consumer side. So that's why I have chosen this consumer VPC. Subnet. So here I'm just gonna choose our private subnet, which is this one. So I'm just gonna choose this one from here. So our request from this EC2 instance will go to VPC endpoint, and this VPC endpoint will call this thing. This will call network load balancer. This will go to the target group where it will find EC2 instance, and then the request will go and end up into this EC2 instance where we are running our HTTP server with a welcome message into our HTML page. Okay, so I'll close this one now. Go back and here choose the subnet, and so I'm just gonna choose private subnet over here. And security group, so let's keep the default one, and also in the default one I'll just open it. I'll just put one more port inbound rule. So I'll click on that one, add rule. I'm just gonna go and add HTTP port 80 from anywhere, and then just click on save rules. And yeah, it's modified. I'll close this one, go back. And I have updated the security group, but you can create your own security group as well. Okay, but I'm just keeping the things quite quick and simple here. That's why I have just modified that one. Okay, create an endpoint. And now we have successfully created our VPC endpoint. But if you take a look onto this diagram once again, then this VPC endpoint has been created, but these needs to be get acceptance from this one. So it's need to be get acceptance over here so that this is both are connected. Okay, so for that, what you need to do, go back to your AWS console, and here you can see in the endpoint service, this is the endpoint service which we have created. I'm talking about this endpoint service now. This tab is for VPC endpoint for this one, and this tab is for this one. Okay, so just to keep you synced with me. All right, now click on the service ID, go to the endpoint connection, and here you can see the pending request, which is pending acceptance. And if you take the copy this ID, VPC endpoint ID, copy this, go into this tab, and you will find the same thing. Here you can see this is the same ID. We need to accept it. So now you need to select this one, click on action, go and accept that endpoint, type accept, and click on accept. And now the state will change from pending to accepted already. I'm not sure what's the exact stats, but it should go green after some time. Okay, so I'll be back once this request is accepted. Sorry for taking a break over here, but I would like to say a few things about my channel, because you have been following this channel for so long, and I would highly encourage you to please subscribe to this channel, because that gives me a good boost and keep me motivated to create such kind of a content, because I see a lot of you guys watch this kind of a sessions, but you really don't consider subscribing. So that's just a one small request for you to just be a member to this particular YouTube channel. And also, if you want to access some of the premium content for specifically for my channel members, so I have this membership program where you can just be a part of it, and you can access some of the content which are specifically for my members. So if I could show you, like there are some videos which I have only created for members, and these are some videos, some sessions where I'm using the similar concept, but this time I'm using the Terraform, which is more actual way of provisioning the whole infra. And there will be more separate session for those members. So if you are interested, then please consider subscribing and also consider joining the community. Okay, let's get back to the topic. Okay, so after a bit, here you can see our request is accepted and it is available now. And let's check the VPC endpoint. I'll click over here, and it's also available, which you can see over here. Okay, so I'll close everything. And let's take a look onto the diagram once again and see where we are. Okay, so now we are at this stage, and if I click here, then you can see the request flowing over here. So if I highlight you, so here you can see now our EC2 instance will make a request to this VPC endpoint. This VPC endpoint will make a call to this VPC endpoint service. This will make a call to the network load balancer. This will search for a target group EC2 instance, and then it will go to the EC2 instance, and where you will see our welcome page. Sorry, I'm just writing it with my mouse, so Just ignore the spelling. Okay. And then you will see the welcome message, the HTML page. And if you take a look over here, then we are not going outside to the internet to make the request. Everything is happening within the boundaries of this AWS, and no request is escaping out of this particular zone. So the idea is we don't want our request to travel to internet so that any intruder can intercept that request. We want to have it as secured as possible. So this VPC, although it is in AWS, but this VPC we can replace, this consumer VPC we can also replace with our on-prem server or on-prem network as well. Okay, so that's also you can do, and other services from AWS Marketplace also you can attach to it. Okay, so now let's verify. Try to access this EC2 instance from this EC2 instance present into this subnet. Okay, to verify this thing, we need to know the VPC endpoint DNS name. So this is the VPC endpoint, and we need to know the DNS name of this VPC endpoint. Okay, so I'll just go to my AWS dashboard over here, and here you can see this is. I'll just start again. So I'll just go to the VPC, go to the VPC dashboard. And here go to the endpoints, and now I'm talking about this endpoint, which is you can see over here. So I'm talking about this VPC endpoint. Okay, so I just need to find the DNS name. So click on this VPC endpoint ID and go and copy this DNS name from here. Go to your terminal and here, and this is our private EC2 instance from our consumer, which is 21.3.165. So if you take a look, if you go to the VPC, not VPC EC2, then go to instance running, then go to consumer private, which is this one, and 21.3.165. Okay, so here we are sitting onto the same one. Okay, and I just need to copy that DNS name once again. So I copied that DNS name. Just go and hit curl and hit enter. There seems to be some problem, and we can check. So what we need to do, let's take a look onto the diagram once again. So here I think we forgot to enable the security group port 80 on this EC2 instance, which is into our provider VPC. Okay, so we need to fix that part. So what I'll do, I'll just go over there. So in terminal, just close this. This is not working. So I'll go over here, go to my EC2 here, click on EC2, 4 instances running. So we need to choose a private service provider, which is this one. Click on this one and go to security group over here. And here you can see this is only allowing port 22. It is not allowing port 80, and that's the issue. We are not able to access that welcome page. Okay. So go to this security group over here, click on edit inbound rule and add rule, click on HTTP, port 80, select it from anywhere and click on save rule. Okay, now it has been updated. Let's go back and try to curl the same thing here. And here you can see our issue is resolved. Okay, so this is how you can access this whole setup, and the key idea over here is like our private EC2 instance is able to make a request which is going all the way from here and landing into our private EC2 instance into our another VPC. So this is secured, this is not traversing through internet, and now we are able to make this communication happen. And that's the key point between the VPC endpoint and VPC endpoint services, which we call it as a private link. So the private link keep everything private for your whole network. So that's the idea behind this whole demo. I hope you enjoyed the today's session, and in the next session we are gonna see some more AWS networking concept, but this session was specifically designed for VPC endpoint and VPC private link, whatever you wanna call it. And if you have any feedback or comments, then please put down into the comment section, and I'll try to follow this channel for similar content. And in this session, we are going to first take a look like what is AWS Route 53. Second, we are going to take a look like how to set up your hosted zone inside AWS Route 53. Third, we are also going to take a look like how to work with your custom domain and how to integrate with our AWS Route 53. Fourth, we are going to take a look on the name server setting, and also we are going to take a look onto the A record, CNAME record and aliases. And in the demo section, we will also include like what is simple routing and how to set it up with the AWS Route 53, which will also include like a weighted routing where we will be distributing the traffic based on percentage. Third, we are also going to take a look over there like what is a geolocation based routing. routing so that we can restrict the traffic based on the request coming from a country. And at last, we are also going to take a look onto the failure based routing, where we will be setting the primary as well as the secondary routing. Let's first try to understand what is Route 53 and how it works behind the scene. And for that, I have taken a very basic example, and here onto the screen you can see whenever users tries to enter any website URL. So here you can see it is trying to enter a website which is jhook.org. We will set up this jhook.org domain later into the demo section, but just here I'm trying to explain the workflow. So this user is trying to enter this URL, and as soon as the user enters this URL, this request goes to the domain name system, and which is in this case is our Route 53. So as soon as the request lands on our Route 53, it tries to resolve that particular request based on the name server setting. And once it resolves that request, then that request is forwarded to particular resource which has been configured into our AWS environment. So that request forwarding is happening with the A record. So we configured two things into Route 53, which is a name server records for resolving the domain, and then the A record or a CNAME record for forwarding the request to the particular resource. So here in this example, I'm taking an EC2 instance. But in AWS, you can have a multiple instances or multiple different resources running behind the scenes. So you can serve the same request either with the EC2 instance, or either you can serve it with the Fargate, or you can also serve it with ECS services, or also you can run a Kubernetes cluster behind the scene. So it doesn't matter that in AWS what kind of a resources you are running, but you need to set up the A records or CNAME record properly so that your request will be served back. Before we proceed, I would like to show you the settings which is of our Route 53 hosted zone. So here you can see this is my jhook.org hosted zone which I have created into Route 53, which you can see over here. And these are the settings which I have created for my domain, which is jhook.org. So here you can see there are three types of record. First is A record. There is second one which is name server, which stands NS over here. And third one is SOA. But we are more concerned about the name server record and the A record. So this name server record is responsible for resolving your domain. So whenever a user enters jhook.org, then these name server settings will help is to resolve the request. And these are the name server settings which is given by AWS. And this is the A record which will help us to redirect the request to either EC2 instance, to Fargate service, to Lambda, to API gateway, or any other resources. So this A records we will be creating multiple times during the demo. So this is how our hosted zone look like. Now you're a little bit more knowledgeable about Route 53. So the first thing which we will do is to create our Route 53 hosted zone. And for that you need to go to the home page of our AWS. And here in the search box, you need to type Route 53 and click on this Route 53 link over here. And here you will find the options to create your hosted zone. So here you can see I have already created a hosted zone, but I can show you how you can create your own hosted zone for your domain. So click on this hosted zone and here you will find the option. So here you can see I have already created the jhook.org. Because these settings takes time to come into effect. So that's why I have already created this hosted zone for my domain. But I can show you how to create your own hosted zone. Let's assume that you have a website which is test XYZ and you need to create a hosted zone for that particular website. So click on create hosted zone over here. In the domain name, type the name and just change the domain name as per your requirement. So here I'm just taking a test XYZ. And after that, you need to select the public hosted zone because we are just trying to point our public domain to this particular Route 53 name server settings. So that's why I'm keeping this as a public hosted zone. And after that, click on create hosted zone. And as soon as you click on it, so it will be ready. And here you will find the details. So this is a name server settings, and these are the name server system settings which is available from AWS Route 3. And these are really important to point your domain. I'll show you how I have pointed my own domain with these settings. So here are the few details which you need to keep in mind. So this is the first settings which you need to keep in mind, which is a name server setting, and second one is SOS. SOA is not going to use pretty much, but we will be focusing on the name server settings. Now you know how to create the hosted zone. So let's get back to the original hosted zone which I have created for my domain. So go back to the hosted zone over here. And here click on the jhook.org which I have already created. And here you will find the settings. So here you will find the first setting, which is the name server setting, which is just similar to the text XYZ which we have created. So these are the name server setting which has been created by AWS, and this is the SOA record which has been created by AWS. But here you will notice a record which I have created for testing purpose, but that's just for a testing purpose. So we will start everything from the scratch. So for that, I'm just going to delete this record, delete this record, and yeah, just click on delete. All right, so let's take a look once more. So now the only thing which we have over here is the name server and the SOA record. Now you might be wondering that since I have created this hosted zone for this jhook.org domain, so do I own that particular domain? So the answer is yes, I own this particular domain because I have purchased this domain. So I will show you like how the settings looks like from my domain registrar. So here in the new tab, you can see this is the Google domain from where I have purchased this particular domain. So keep in mind, there are two things. First, we need to purchase a domain, and then we need to create a hosted zone for that particular domain in AWS. So the second part, which we have already done, so we have already created the hosted zone for that particular domain. And now I'm just going to show you the settings from my domain registrar, because that's the first thing which I have did when I purchased my domain from Google domain. And you can buy the domain from any other service provider like GoDaddy, Namecheap. So there are multiple service providers which are available in the market. So you can just purchase the domain from those services. Alright, so now what are the things which we need to pay careful attention when we need to configure the domains between AWS Route 53 and the custom domain which you have purchased, which in this case is jhook.org. So in the left navigation side, you will find a DNS, which is a really important thing, and I'm also paying a lot of attention on the DNS record, because if you misconfigure these records, then your domain name settings will not work. Okay, so here in each service provider, whether you go with the Google domain, whether you go with the GoDaddy, whether you go with the Namecheap, or whether you go with the SiteGround, everyone will have a DNS settings available when you purchase a domain. So just go and check for the DNS settings when you purchase a domain. So here you can see this is the DNS setting, and I'll show you the default setting which is provided by a Google domain. If you have purchases from a GoDaddy, then they will provide you some default setting. So these are the default name server, and if you go down here, then you will find the name server of my Google domain. So here you can see these are the name servers from a Google domain when I have bought this particular domain. And these are the name server settings which you need to use when you are just trying to host somewhere. But now we are working with the AWS. So AWS provides their own name server settings. So here you can see this is the name server setting, and these are the name server setting for our jhook.org. So there is a little bit of confusion over here, which generally happens whenever you start working with the domain names. So first of all, you need to pay careful attention that you need to point our domain to AWS. So you will be using the name server settings of your AWS, not from the Google domain or a GoDaddy or a Namecheap. So you just need to copy these records from AWS and then go to your Google domain, and here it is showing the default name server of a Google. We don't need to use those. So here you will see a couple of options. So default name server, I don't want to use it. And here you can see your domain isn't using these settings. So I'm not using these settings provided by Google domain, but instead I need to have a custom name server, because I have already created the Route 53 for that. So here you will find a custom name server which is active, and if you go down over here, then you will find the options. So here I have pointed those custom name servers from AWS. So here you will find that NS652 AWS DNS, and you will go and check here, then it is NS652 AWS DNS. So that's why I have pointed that onto the Google domain. Hey, whenever someone is trying to access the jhook.org, then just point that request to this particular name server setting, so that that request is forwarded to this hosted zone settings which is present into my AWS account. I know these settings seems like a little complicated, but let's try to break down the whole logic once again. So here onto the screen, you can see I have created two sections, Google domain on the left hand side and AWS section on the right hand side. And on the right hand side, you will find the hosted zone which I have created for jhook.org. And as soon as you have created the hosted zone for jhook.org, then you got these name server settings from AWS. You have not created it, AWS has created for you. Alright, so that part is quite okay. but on the left hand side from the Google domain where we have done the purchase of our Google domain. So we have done the purchase, and as soon as we have done the purchase, then we have got the name servers from Google domain. But since we are working with the AWS Route 53, so we don't need to use the name server settings of Google. So here you can see the Google domains.com. So any records which belongs to the Google domain, we are not going to use those. But instead, we are just going to use the settings from our, or the name server settings from our AWS Route 53. So which is this in this case. And then we are just going to put those custom setting into our Google domain name servers. And here you can see I'm just using these values inside my Google domain, and that I have shown you over here. So if I switch back to my Google domain, and here you will find into the custom name server setting, I'm using the AWS name server setting, so that whenever someone tries to access that particular domain, that request will be routed to the Route 53 hosted zone settings for jhook.org. Let's try to run a very simple demo. Now we have seen like our jhook.org, which has been configured. Now that will point our request to the Route 53, and from Route 53 we will create a record that will point to our EC2 instance. So that's gonna be our first simple demo for this particular concept. And now we need to create our EC2 instance for that. So onto the home page, you will just need to type EC2 over here and click on EC2. And here you can see there are no instances running, so click on launch instance. And here we will first type the name of the EC2 instance. So I'm just going to put test EC2 Route 53 demo. And after that, you just need to choose the machine. So I'm just going to choose Ubuntu over here. And after that, I'm just going to choose the T2.micro. Yeah, I'm just going to stick with the small one. Key pair, I'm just going to select the existing one. You can create your own key pair, but it doesn't matter for this particular demo. And the network setting, I just want to keep everything default over here, but I just need to create a security group also. So here I have already created the SSH, so that I can SSH into my EC2 instance, and also I just need to allow HTTP so that I can access the port 80 of my EC2 instance. And after that, into the advanced details section, I will be inserting the user data script, so that whenever my EC2 instance is booting up, then it will install the Apache by default onto that particular machine. So for that, in the user data section, I'm just going to paste the script. So here it was just going to install the Apache, and then it is at the end, it is going to restart the Apache. And these are the index.html page, which I'm just updating with the host name. So now we are done with the EC2 instance settings. So what I need to do, I just need to click on launch instance. And also one more thing, we need to enable the public IP before launching the instance. So here into network setting, we need to verify one thing, the auto assign public IP, which is enabled, so that we will get a public IP for our EC2 instance. So click on this launch instance. And I'll be back once this instance is up and running. Here you can see my AWS EC2 instance is up and running. So I need to click on the instance ID to verify my instance in Apache 2 installation. So for that, I'm just going to copy the public IP address, go to the new tab and paste it over here. And here you can see this is showing me the home page of my Apache 2 along with the hostname IP address, and which you can verify from here into the console also. So here you will go and Control F and find, and here you can see the same IP address. So now my EC2 instance is up and running. But the thing is, we are trying to access it with our public IP, but I don't want to access it with my public IP, but instead I want to access this home page with the jhook.org domain. So for that, we need to go to our AWS Route 53 records, hosted zone records, and create a record to point to this particular EC2 instance. Let's go back to our AWS Route 53 settings, and here I'm just going to open one more new tab and click on Route 53. Go to the hosted zone, and here click on jhook.org. And here we need to create a record for our EC2 instance. So click on create record, and here we will first select the simple routing. So just select this one and click on next. And here we need to create a record. So click on define simple record over here. And here, the first thing which you need to pay careful attention is we are pointing our main domain. We are not pointing any subdomain. So we will keep this field empty so that our main domain is pointing to the home page of my EC2 instance. And from the drop down, we need to select a route traffic to an IP4 address. So select this one, and here you need to enter the IP4 address, so which you can copy from our public IP of my EC2 instance. So copy this public address, go to the Route 53 define simple record, pass the IP address over here and click on define simple record. And here you can see our A record has been created, and also we can do one more thing. We can click on edit, and we need to remove this or we need to reduce this seconds, TTL second, because we are just doing it for the test purpose and we just wanted to see the changes in a quick response time. So I'll go over here and I will just change it to 10 seconds so that we can check by accessing the domain. So click on edit records and then select this one and click on create records. And here you can see now we have created our A record, and which is pointing to the IP4 address of my EC2 instance. And here you can check the status also. So click on it and here it is showing pending. So we just need to wait for a couple of minutes and it should be up and running. And here you can see the record is in sync state now, and so we will be able to access our jhook.org domain and it should point to the home page of my Apache 2 instance running into EC2 instance. So here this is my URL. I just need to hit enter. Looks like it has taken a little bit more time to propagate those changes, and here you can see now we are able to access the jhook.org and it is pointing to the IP address of my EC2 instance, which is 172.31.20.21, and which we can verify here also. I would like to refresh this page, and if you go over here, then 172.31.20.21. So that's the IP address now we are able to point with our domain. Alright, so till now we have seen a very basic example of a simple routing. So we have a user which puts a request for jhook.org, which goes to the Google domain, and then from there it finds the name server record for Route 53, and from there it has a record which points to this EC2 instance. This IP address is just an example IP address which might differ when you are going to create your own EC2 instance. But the idea is pretty simple over here when we are using the Route 53. But the problem with the simple routing is that whenever we create a record, so we are putting an static IP address over here. So suppose in another case, like we want to change the EC2 instance and we want to have another IP address, then this record will be unuseful for you, and that routing or the domain will be inaccessible because that resource IP address has been changed and we are using the same IP address inside in our A record. So that's not a best practice to use the A record with a static IP address. To fix this, we need to use the load balancer so that we are hiding our resources under the load balancer and we don't need to provide the static IP address in those cases. So let's take a look on how to set up the load balancer and put the load balancer on top of our EC2 instances so that we don't need to change the IP addresses again and again. So before we jump into our weighted routing, I would like to first tell you about the load balancer and how we are going to configure the load balancer along with our Route 53. So here is a workflow which is quite similar to the one which we have seen previously. So here this is a user which is trying to access the website which is jhook.org, and it is going to the Google domain, and then from Google domain it is finding the name server record for our Route 53, and then the request is coming to the Route 53 hosted zone. And once that request enters into our hosted zone of our AWS Route 53, then it goes to the load balancer, and the load balancer will then forward that request to our EC2 instances. So here you will see there are a couple of load balancer which we will see eventually into the weighted routing, but the idea is we need to have a load balancer, and then that load balancer will point to the EC2 instance. So that's the ideal way, or that's the more preferred way of using Route 53 along with the load balancer and hiding all the resource behind the load balancer so that you don't need to hard code the IP address of resources for our Route 53. Alright, so now you have an idea like we need to use a load balancer so that we don't need to hard code the IP addresses for our Route 53A record. But now you might be wondering why I'm showing this diagram. So load balancer is one concept which you need to incorporate when you're working with the Route 53. But on top of that, you also need to set up your proper networking, which means you need to set up your AWS account, which I'm assuming that you already have an AWS account since we are working inside our AWS cloud. Second, the important thing is you need to work inside a VPC. Although there is a default VPC available by AWS whenever you get or whenever you sign up for AWS, but we are not going to use those default VPC. We are going to create our own VPC, and inside that VPC we are going to create a public subnet as well as the private subnet. And after creating those public and private subnet, we are just going to create an internet gateway for our public subnet so that public subnet can access the internet. And after that, we are just going to create a route table, and these route table will be responsible for forwarding the request to our public subnet as well as to our private subnet. And once we configure the route table, then we are just going to provision the EC2 instance inside my public subnet as well as my private subnet. So this is the minimal network setting you should do whenever you are working with our Route 53 and the load balancer, because these are the more ideal practices which you need to follow whenever you're trying to set up this kind of a environment. So what we will do now, we will just set up these things like a VPC, public subnet, private subnet, internet gateway, route table, and EC2 instance. Once we set up all these, then we are going to provision the load balancer, and then we are going to point that load balancer to our Route 53. Alright, so let's take a look like what resource we need to create first. So we already have a AWS account because we are already working inside our AWS account. The next resource which we need to create is the VPC. So switch back to your console onto AWS. So here is my AWS console. Go to home page. Here in the search box type VPC. Click on VPC. And don't worry, we are going to take a look onto the weighted routing, geolocation based routing, and the failover routing also once we set up all this networking. So here first thing we are going to create is the VPC. So click on create VPC, and here click VPC only and type the name. So here I'm just going to put test VPC, the IP CIDR range. So here I'm just going to put 12.0.0.0/16. So that's the IP range for my VPC. Tenancy, I'm just gonna put it to default, and tags, I'm just gonna keep it everything default. Then click on create VPC. And here, just go to your VPC, and here you can see our test VPC has been created. Now, after creating the VPC, the next resource which we need to create is the public subnet as well as the private subnet. So let's go back to our AWS home console, and here into the VPC dashboard. Here you will find the options for creating the subnet. So click on subnets over here and click on create subnet. So first of all, we are just going to create a public subnet, and that subnet is present inside my VPC. So this is the VPC, and the name of the VPC which we have just created is the test VPC. So here the first option you will find is to select the VPC. So here you will find a test VPC which we have just created. And here we are just going to create the subnet. So here first of all, I'm just going to create a test public subnet, and subnets are just for the availability. Suppose if you are having a multiple subnet, then those subnets are present into the different region. So if something goes wrong with the one data center, then you will have another subnet present into another region available to serve those requests so that you get a maximum availability for your resources. So here I'm just creating a first public subnet. So I'm just gonna put 1 and 1A over here. And here in the availability zone, I'm just going to choose 1 Europe Central 1A. So that's why I have suffixed it with the 1A so that I can identify in which availability zone I'm creating this particular subnet. Alright, so that's it. I have selected the Europe Central 1A region, and here we need to enter the IP range for our public subnet. So this is the IP range or the CIDR block from the VPC. But here I'm just going to enter 12.0/1/0/24. So here I will have a 256 IP available inside my subnet. So that's the IP address I'm just going to use for my public subnet. I'm just going to copy the name because we are just going to create one more public subnet for maximum availability. So that's a one subnet. I'm just going to click on add one more subnet. I'm just going to paste it over here, and here I'm just going to put 1B. And here availability zone, I'm just going to select Europe Central 1B. The IP range, I'm just going to keep 12.0. Let's put 2.0/24. Here you will see that I'm using the different IP range for different subnets. So here in the first subnet, I'm using 1.0, and here I'm using 2.0. Alright, so now we have created two public subnets. So let's create one private subnet as well. So click on add new subnet, and here just enter the name, and I'm just gonna modify it to make it to private, and I'll put 1 and 1A for Europe Central 1A. So here select the Europe Central 1A, which is the availability zone, and the IP range I'm just gonna put 12.0.3.0/24, so that I will have a 256 IP addresses within my private subnet as well. Alright, so I have created the 3 subnets. One is private and the 2 public subnet. So after that, we are just gonna click on create subnet. So click on create subnet over here. And here you can see our subnets has been created. So if I scroll it down, I'll just remove those filters so that it's easy to view over here. I'll just close this one. So here you can see our subnets are visible over here. So there are some default subnet which you can see over here. There are no names associated with it. If I can zoom out, so it might be visible. Yeah. So here you can see our 3 subnet has been created. So let's go back to our diagram and see what resource which we need to create next. So here we have created the VPC, we have created a public subnet as well as private subnet. So the next resource which we need to create is the internet gateway. So for that, again, go back to the home page, go to the VPC dashboard and click on internet gateway. From the left navigation menu, click on internet gateway, and here I'm just gonna put the name. So I'm just gonna put test IGW. IGW is just an abbreviation for internet gateway I'm using, and just click on create internet gateway. And here you can see our internet gateway has been created. So click on internet gateways, and here you will find the test IGW. But here you will notice it is detached. It has not attached with any VPC. So what we need to do, we just need to click on internet gateway. And here you just need to go to action, click on attach VPC, and here you need to select the VPC, which is our test VPC, and then click on attach internet gateway. Why we are attaching this internet gateway? Because if you take a look onto the diagram, then this internet gateway is sitting inside the VPC. So that's why we need to attach it to that particular VPC where we are working. So now we have created our internet gateway as well. Since we have created the internet gateway, the next resource which we need to create is the route table. So here, this is the route table which we will be using for our public subnet as well as for our private subnet. So let's go back to our console over here, and here onto the VPC dashboard. In the left navigation menu, you will find the route tables, and also in the home page of the dashboard, you will also find the route table. So click on any of the options. So here you will find some default route table, but we are not going to use those ones. So we are just going to create a new route table. So first, let's create a route table for our public subnet. So I'm just going to put RT test, and then I'm gonna put RT for route table, and then I'm just going to put public so that it belongs to my public subnet. And here again, everything we are doing inside the VPC. So I'm just going to select the test VPC over here, and then I'm just going to click on create route table. So here you can see our test route table public has been created. I'm just going to create one more route table which is private. So I'm just going to click on create route table, put test RT, and here I'm just going to put private and select the VPC. So I'm just going to choose test VPC again, click on create route table. Alright, so now we have created both the route tables. So let's verify those. And here you can see our test public and test private route table has been created. But if you take a look onto this diagram, so here in the public subnet, we need to have a route table which we have just created, but this route table needs to have an internet gateway also. And also it should attach with our public subnet, because this route table, although there are 2 route tables, but here in the diagram, I could not show both the table because of limited space. So just I have shown one single route table over here, but just assume that this is our public route table. So what we need to do inside this public route table is to attach the public subnet as well as let us know the internet gateway inside the route table so that this public subnet can access the internet. So that's the importance of our route table. So let's go back to our route table over here. Click on this public route table, go to actions, and here first click on subnet association, which is this one. So click on edit subnets, and here we need to choose only the public subnet because this is our public route table. So I'm just going to choose these 2 subnet which we have created. Click on save association, and here you will verify that the subnet association, here we have added a public subnets inside my subnet association. So this particular route table RT public has been associated with our public subnet. Alright, that's been done. The next thing which we need to select is the route for an internet gateway. So if you take a look onto this diagram, so this route table has been associated with subnet, public subnet, but we have not associated with our internet gateway. So let's go back and here click on edit routes, and here click on add routes, and here you need to enter this address 0.0.0.0, which means this public subnet can access the internet from, or the internet can access this public subnet from anywhere. So this is a two-way communication happening. So if I am sitting from anywhere in the world, so I should be able to access this subnet inside the VPC. So that's the route we are just trying to create. So use this IP address, select the internet gateway over here. So internet gateway, which is this one, and this is the test internet gateway which we have just created. So just use this internet gateway and then click on save changes. And here you can see our public route table is ready, and now we have an internet gateway for providing internet access for our public subnet which we have just associated. Alright, so that's been done. Let's go back to route table once again, and now we will work on our private route table. So click on this private route table ID, go to subnet association, click on edit subnet association, and here we will be attaching only the private subnet, not the public one. So click on save association, and here you can see our private subnet has been associated. And the routes, we are not going to create an internet gateway over here. Otherwise, it will defy the purpose of our private subnet. Private subnet doesn't have an internet access, and no one from any part of the world can access the private subnet. So that's why we call it as a private. So that's why I'm not assigning any internet gateway over here. Alright, so let's go back to our diagram once again. So here you can see our route table has also been created now. Let's move ahead, and the next resource which we need to create is the EC2 instance, and then we are going to create an EC2 instance inside our public subnet. So let's go back to our AWS console over here, go to home page, and here click on EC2 instance. And here you can see our one instance is already running, but that is just a default instance which I have created, which is running without any, which is running inside the default subnet, default subnet and the default VPC. So what I'll do, I'll just terminate this instance because we don't need it at this moment. So I'm just going to terminate this instance over here, and I'm just going to create a new EC2 instance inside our VPC and inside our public subnet. So here, if you take a look onto this diagram, then I'm talking about this EC2 instance inside this VPC and this public subnet. So let's go back to our browser over here, go to EC2 dashboard, and I'll refresh this one. So here you can see that instance has been terminated. So now click on launch instance. And here I'm just gonna choose like a test EC2 instance, and here I'm just gonna choose Ubuntu as my base image, and here instance type t2.micro, I'm just gonna choose that one. The key pair, I have already created this key pair, but if you want to create a new key pair, then you can just click on create new key pair, and that will let you create a new public and private key for our EC2 instance. Alright. So that's been done. Click on network setting. We need to edit this network setting now. So here we will first choose the test VPC because we are working inside the test VPC. Then subnet. So here I'm just going to choose the first subnet, which is public, this one. Auto assign public IP. So I'm just going to enable that one. Then security group. So here I have already enabled the SSH for our EC2 instance. So I'm just going to enable one more security group, and here I'm just going to put HTTP over here. Port 80, and it should be accessible from anywhere so that I can access the default page, which I'm just going to install Apache for that. So it should be accessible on a port 80. So that's why I'm just going to enable these two security groups. All right, that's been done, and I'm just going to go with the default storage. That's fine. Go to advanced detail, and here I'm just going to use the user data section. If you go down over here, then you will find a user data section. So from a notepad, I'm just going to copy one script, which I'm just going to show to you. So this is the script which I'm just going to pasting over here. So this is a user data script which is going to install this Apache, as well as it is going to update the index.html page, which we will be accessing later, and which you have already seen into the first demo where I have shown the home page. So here, this is the default page where it will be showing you the host name and the IP address. And after it is installed, then it is going to restart the Apache, and everything will happen on the boot time of our EC2 instance. All right, so let's click on launch instance over here. and it will take a couple of minutes for this instance to come up and running. So I'll be back once this instance is up and running. Alright, so I have refreshed this home page of my EC2 dashboard, and here you can see one instance is running. So I'm just going to click on it. So here you can see this is the test EC2 instance which we have just created inside our public subnet. So click on this instance ID, and here you can see the public IP address. So just copy this IP address to verify the Apache 2 home page. So just hit enter, and here you can see our EC2 instance is running, and now we can access the Apache 2 home page, which is this is the private IP address of that instance, which you can verify from here also. So here you can see this is the IP address of my EC2 instance running the Apache. Alright, so now we have seen the EC2 instance has been up and running. So the next thing is now we need to configure the load balancer for this EC2 instance so that we don't need to access using this public IP address. Alright, so to do that, what we need to do, we just need to create a target group. So target group you can create from the left navigation menu from our EC2 dashboard. So if you go to the load balancing section, so here you will find a target group. So click on this target group, and here we need to create a target group. So target group is the logical grouping of our EC2 instances, so that our load balancer can choose this particular group to forward the request. So that's the meaning of our target group. So here I'm just going to select the instances. After that, I just need to put the name. So I'm just going to put test TG for target group EC2. And here I'm just going to select the port HTTP, IP4. But here you need to select the correct VPC where you are working. So I'm working into the test VPC. So select that one. Move ahead and then click on next, and here you can see this test EC2 instance is already showing over here when I'm just about to create the target group. So here just select that one, include as a pending below, because this target group can have a multiple number of EC2 instance. Although I have created only one EC2 instance, but you can have more than one EC2 instances inside the target group. So just select that target EC2 instance inside the target group and click on include as pending below. So here we have included that one, and then click on create target group. So now our target group is ready, and this target group contains our one EC2 instance, which you can see over here. Alright, so now we have created the target group. The next thing which we need to create is the load balancer, and I'm just going to show you like how you can access the load balancer URL to access the EC2 instance. Okay, so again go to the left navigation menu, click on the load balancer, and here we are just going to click on create load balancer. So click on create load balancer, and here we are just going to choose the application load balancer. So click on create. So here I'm just going to create an application load balancer. So here we need to enter the name. So I'm just going to put test LB for EC2. Okay, so this is going to be the load balancer for my EC2 instances. All right, so here I'm just going to keep everything default. Internet facing, yes, I want internet facing. IP4, yes, I want IP4. Here we need to choose the VPC. So I'm just going to choose the test VPC where I'm working right now. And then we need to select the availability zone of our public subnet. So I'm just going to select Europe Central 1A. And here you will see the public subnet 1A. And then I'm just going to choose another one, which is 1B for my public subnet. All right, so those has been selected. Security group, this is important because security group is necessary for your load balancer. So the first security group we will enable is for port 22 so that we can SSH into our EC2 instance, and then we are just gonna enable the port 80 also so that we can able to access the Apache 2 homepage. Otherwise our load balancer will not allow to access the Apache homepage. So for that, click on create security group, and here I'm just gonna put the name. So test security group for load balancer. So this is a test security group I'm creating for a load balancer. So here I'll put a description like allow SSH and port 80. Then select the VPC. So I'm working on a test VPC. So select that one, click on add inbound rule, select SSH over here and put anywhere. So anyone can from anywhere in the world should be able to SSH into our EC2 instance. Add one more rule and here put HTTP. this one and select anywhere from the world. So anyone from anywhere should be able to access the home page of my EC2 instance. All right, so that has been done. So click on create security group. And here you can see our test security group has been created. So just copy this name, which we need it. And again, go back to our load balancer. So here we are just trying to add that security group. So from the drop down, just refresh this page. And here you will find the test security group, which we have just created. So select this one. And here the next thing is listeners and routing. So here we need to configure our target group, which we have just created previously. So in the drop down, you will find a test target group, and inside that test target group, we have already included our EC2 instance. So that's already there. So now our EC2 instance has been added as a target group inside the load balancer. Then move ahead and verify the details. So here are the basic details for my load balancer, which includes the security group, network mapping, and the listeners. All right, so that's been done. Then click on the create load balancer. And here you can see the load balancer has been created, but it will take a couple of minutes to provision. So if you go over here, so here you can see the state is provisioning. So I'll be back once this load balancer is up and running. So I'll refresh this page after a couple of minutes, and here you can see my load balancer is now active. So click on this load balancer over here and copy this DNS name and go to this new tab over here and hit enter. And here you can see it is now pointing to the EC2 instance, and we are not using any public IP of my EC2 instance anymore. We can just simply access it with our URL of our load balancer. Sorry to pause you in between of this particular session, but I would like to encourage you guys to please subscribe to this channel, because I have seen like many of you watch and enjoyed this kind of a session, but you don't consider subscribing to this channel. Being an open source community member, I also spend some time on creating and drafting these sessions, which takes quite a significant amount of time. So do me a favor, please consider subscribing to this channel, which will really help me and keep boosting, putting my effort to create similar content in future as well. So let's continue with the session. Now we have created the load balancer. So let's take a look onto the diagram once again. And now we need to fix the linking between the Route 53 and the load balancer. So I'm talking about this Route 53 and the load balancer. We have already fixed the linking between the load balancer and the EC2. So we are able to access the EC2 instance from our load balancer. But we need to create a record so that our Route 53 can redirect the request to our load balancer, and then the load balancer will forward that request to the EC2 instance. So let's go back to our AWS console and go to our Route 53. So I will just close all these windows over here. I'll close this one and go to my home page, and here in the search box type 53, that will point to the Route 53. Go to the hosted zone over here. Click on jhook.org where we are working, and here first of all just remove this entry, because we are no longer using the static IP address. We have already seen that. So I'm just going to delete this record. Click on delete, and now we are just back with our hosted zone when we have created for the first time, which has a name server and SOA record. So now we need to create a new record for our load balancer. So click on create record. And here we are again going to choose the simple routing. Click on next. Click on define simple record. And here we are gonna point our main domain to our load balancer. So select the main domain, which is jhook.org. And here we are just gonna select the A record, because we are just gonna use the A record once again. And here the choose endpoint. So instead, previously we have specified the IP address over here, which is like a 192.xxxx something. But we are not going to use that IP address anymore. We are just going to use the load balancer over here. So from the drop down, you just need to select the load balancer. So here you will find the alias to application and classic load balancer. So select that one. And as soon as you select the application load balancer, then it will ask like in which region those load balancers are present. So here we need to choose the correct region. So in that case, our region is Europe, Frankfurt, Central 1A. So this is the region where I'm working. So as soon as you select the region, then it is going to ask like for which load balancer you want to choose. So here you will find the load balancer which we have just created, which is test LB for EC2. So select this load balancer and then click on define simple record. So click on it, and here you can see our A record has been created, and now it is pointing to our load balancer instead of IP address. So click on create records, and here you can see our record has been created. So now what we will do, it will take a couple of minutes to activate this DNS propagation, and it might take more than 2 minutes as well. So just be patient. Sometimes I have seen that it takes around 5 to 15 minutes as well. So, but here I'm just gonna first of all click on view status to verify this. So still you can see the status is pending. So I'll be back once this propagation has been in sync. Alright, so now the changes are in sync, and here you can see the green icon. So I'll go back to jhook.org homepage of my hosted zone, and here we can verify the details once again. So here we are having a record with the load balancer. So now I will open a new tab over here. So I'll close this one, and here I'm just gonna type jhook.org, and it should point me to the EC2 instance. And here you can see this is the IP address which I'm getting, which is of my EC2 instance, so that we can verify that I'm just getting redirected to the correct EC2 instance or not. So the IP address is 12.0.1.47. So go to EC2 and go to dashboard over here and refresh this once again. Click on this instances, and here you can see this is the instance which is running. Click on it, and here you can see the IP address. I'm just going to zoom in a bit. 12.0.1.47. So it is redirecting to the correct EC2 instance, and we can verify the network details as well. So here you will find the VPC. Here you can see this is our test VPC, and this is our subnet. So it is pointing to the correct EC2 instance. So now you can see that instead of using the hard-coded IP address, now we are using the load balancer, and it doesn't matter how many EC2 instances you are running behind the load balancer. You can point n number of EC2 instances, and you don't need to change this record anymore. And this will point to all the resources present inside that particular load balancer target group. Alright, so now I'm assuming that now you're a bit more familiar with the Route 53, and now you know like how to work with the A records and how to set up your load balancer so that the Route 53 can redirect that request to our load balancer, and then eventually you will be able to access your EC2 instance. Now we will talk about the weighted routing. So as the name suggests, the weighted routing, which means we will be putting a percentage to share the traffic load onto multiple load balancers. So here you can see onto the screen. So we have already seen like how to configure a one load balancer, but in this example we are going to configure multiple load balancer. So our Route 53 will have a multiple load balancer, and then it will redirect those requests to the EC2 instances. So here you can see the first load balancer will forward that request to first EC2 instance, and another load balancer will forward that request to another EC2 instance. And also we can configure the percentage, like how much traffic of percentage should be redirected to the first load balancer and how much it should be redirected to the second load balancer. So that's what we call it as a weighted routing. So let's jump to our AWS console and start setting up the another load balancer. But before I set up another load balancer, I need to set up another VPC. So I'm just taking the same diagram once again, and I'm not gonna repeat the same process once again because it will be boring for you. So as you remember, we have already created a test VPC, which I can show you. So here onto the dashboard, you can see, go to the VPC, and here you will find the option for a VPC. And here you will find a test VPC. So this is the test VPC which we have already created, but I'm just going to create a one more test VPC 2 so that we can create another load balancer inside the VPC. So I'm just talking about this one. So I'm just going to create a one more load balancer so that it can present inside another VPC. So this is our first load balancer, and this is going to be our another load balancer into the test VPC 2. So just follow all the steps which I have shown previously while I am creating the test VPC. So I'm just going to use the exact same steps. But the only thing which I'm just going to change over here is the IP range. So since I am already using the 12.0.0 for my test VPC, which I can show you here. So this is the IP range which I am using for a test VPC. So instead of that, I will be using 13.0.0 for my test VPC 2. So I'm just going to create the whole test VPC, subnet, route table, internet gateway, and then I'm just going to be back, and then we will be creating EC2 instance and load balancer, and then eventually the route 53. Alright, so moving ahead, so here you can see onto the screen, so I have created the test VPC already, and here I have created the test VPC2 also. Now the next thing is we need to create an EC2 instance inside our test VPC2. So what I'll do, I'll just go to home page and click on EC2 instances, click on create or launch instances. Here I'm just gonna put the name, so I'm just gonna put test EC2. I'm just gonna put VPC2 as an abbreviation to identify the EC2 instance. Then put Ubuntu as my base operating system, and then I'm just going to choose t2.micro. That's correct. And I'm just going to choose the same key pair. You can create your own key pair also, that's fine. Click on edit network setting. Here I'm just going to choose the test VPC2 now. So here based on that I will choose the subnet. I only created the public subnet. So here you can see the test subnet 2 and test subnet 21A. I have not put the public keyword here, but these subnets are public subnet, just so that you keep in mind. Alright, so I'm just going to select 1A over here, auto assign public IP enable, and then here I'm just going to create a security group. So SSH is already there. I'm just going to add one more. So here I'm just going to choose HTTP and choose it from anywhere, source type from anywhere. That's done. And storage 8 gigs, that's fine. Into advanced detail, I'm just going to install the user data section. Here I'm just going to copy the script for installing the Apache, copy and paste it over here. So here you can see the Apache installation script, and after that I'm just going to click on launch instances. And here you can see our instance has been launched. So go back over here, and here you can see it is in pending state. So I'll be back once this instance is up and running. And here you can see our EC2 instance is up and running. So click on this instance ID, copy this IP address, go to the new tab and hit enter. And here you can see the home page of my Apache 2, and the IP range is 13.0.1.25, which belongs to my test VPC2 and the public subnet. Alright, so now my EC2 instance is up and running. So if you take a look onto the diagram once again, so here this EC2 instance is running. I'm talking about the below one. So here I need to configure the load balancer for the test VPC2 EC2 instance. So go back to your home page of my AWS dashboard, click on home page over here, and here go to EC2. In the left navigation menu, we need to create a target group again. And here this was a target group for my test VPC, but here I'm just going to create another target group, and here I'm just going to put test target group for test VPC2, so that I can identify which target group belongs to which VPC. Alright, port type is HTTP, that's fine. Here I'm just going to choose the VPC, that is test VPC2, and after that HTTP, that's fine, attribute, then click on next. Here you will find the instance which we have just created. So select that one, include as a pending resource, and here we have added it. Click on create target group. And here you can see our target group has been created. And the next thing which we will do over here is to create a load balancer. So click on load balancer from the left navigation menu and click on create load balancer. Choose application load balancer, click on create. Here I'm just going to put test LB for EC2 test VPC2. Okay, so this is the load balancer for my test VPC2 EC2 instance. Here I just need to choose the test VPC. So here I will choose test VPC2, choose both the subnet, public subnet. Then security group, let's check if we have that security group available or not. So I don't think that security group is available, which we have created for a previous load balancer. So I'm just going to go over here, and here I'm just going to create a security group. So I'm just going to put test security group for LB, and I'm just going to put test VPC2. And here I'm just going to put allow SSH and port 80. Select the VPC, so I'm just going to choose test VPC2, add rules. First of all, allow SSH, custom, it should be from anywhere, add one more rule, put HTTP over here and choose anywhere, and then yeah, we are good to go. Click on create security group over here, and here you can see our security group has been created. Copy the name, go to load balancer, refresh the page, and here select the security group over here, and now we have added that security group into load balancer. And go ahead, and here we need to select the target group where we have already included our EC2 instance. So just select the drop down, and here you will find the target group from our test VPC2. Select that one. Go ahead, and here you will find all the details about your load balancer, and then just click verify those details, and then click on create load balancer. And here you can see our load balancer has been created. Let's verify the status. So here you can see it is in provisioning state. So I'll be back once this load balancer is up and running. After a couple of minutes, my load balancer for test VPC2 is up and running. So click on this load balancer and go to DNS name, copy this one and go to new tab and hit enter. And here you can see the IP address of my VPC or EC2 instance from my test VPC2, which you can see over here. So this is the IP address which is starting from a 13. So now my load balancer is up and running. So let's take a look onto the diagram once again and try to understand where we are. So now our setup is ready, but we need to create a records inside my route 53 so that we can divide the traffic 50-50% between these load balancer, and also we'll try to tweak that parameter. So instead of sending 50-50, we will try to change it to make it like a 90-10 or 80-20. So let's go back to our AWS homepage and try to configure these records inside our route 53. So here is my AWS. Go to homepage. I'll close all the tabs over here. Go to route 53. Click on hosted zone. Go to jhook.org, and here first of all delete this record because that we don't need it. That is a simple routing. Here you can see this is a simple routing, but we need a vetted routing. So I'll just close this one. I'll just delete this record. Click on delete, and then we are just gonna create a new record. So click on it. Here you need to choose the correct option. So here I'm just gonna choose the vetted routing for this one. So select vetted routing. Click on next. And here I'm just going to go with the main domain. I'm just not going to use any other domain. So here I will choose the A records because yes, we want to create an A record. And here we need to define the weighted record. So here click on weighted record, and here we need to choose the endpoint. So first of all, we are just going to select the first load balancer. So here select the type of endpoint. So that is going to be our application load balancer. Select the region. So I'm just going to choose Europe, Frankfurt. And here you will find the option for a load balancer. So here you will find two options. So we are just going to go with our first load balancer, which is test LB. And then just, before creating this test record, we need to define the weight. So weight is like where we'll go with the 50-50% first of all. So let's choose the 50%. So here you need to enter the value between 0 to 255 because it's like a 256 bits. That's why you need to enter the values. So I will put around 128 because or 128 or 127. So let's go with the 128 because that's the 50% of our 256. So that's the key thing which you need to keep in mind. So I'll just put 128 over here. Health check, I'll just skip it. And the record ID. So I'm just going to put a record for test LB. So that's the identifier. Click on weighted route. So here you can see the first record. I'm just going to add one more record. Here I'm just going to choose the endpoint to be the application load balancer. Here I'm just going to put 128 over here also. And here I will just put the ID. So I'll put a record for test load balancer 2, which includes our test VPC 2. Put a dash over here also, and then click on define weighted routes. We need to choose the region also. I forgot. So here I will choose Europe Frankfurt, and here we need to choose the load balancer. So I'm just going to choose test VPC 2 load balancer. And I think we are good to go. Click on create weighted routes. Select all of it. Click on create records. And here you can see there are a couple of records now. So here you can see first record with 128 and another record with a 128, which means our traffic will be split at 50-50% between these two load balancer, which you can see over here. This is from test VPC2 load balancer, and this is the first load balancer which we have just created. So wait for a couple of minutes, just check the status over here also. So it's in pending state, so it might take a couple of minutes or more. So I'll be back once this is up and ready. Here you can see it is in sync now. Alright, so let's do one thing. Let's try to verify by accessing the domain. So I'm just going to go and type jhook.org over here and see where our request goes. So here you can see our request is going to 13.0/125. So that's our EC2 instance running into test VPC2. So if I refresh it, so still it is going to that particular EC2 instance. So what we will do, we'll just try to reduce the percentage of our EC2 instance running into test VPC2 so that our request goes to the another instance. So for that, what you need to do, you just need to go to the records, go to hosted zone into our route 53, and here into the records, you just need to identify that particular record first. So here you can see this is the test VPC2 instance or the load balancer record. So what I'll do, I'll just select this one, click on edit record, and here instead of 128, I'll just mention like let's say put 1 over here, or maybe we can put it 0, and then click on save. And I'll just verify the status later, and also I'll just update this record as well. So click on edit record, and here you will put 255 so that all the request goes to the another EC2 instance. Click on save over here. Alright, so let's check the status over here. It's in pending state, so I'll be back once this status has been changed. And also why I did 0 and 255, because I'm just running everything into a limited environment. I don't have multiple number of requests, like thousands of requests coming to EC2 instance. So those split cannot be so visible significant if we go with the 50-50. That's why I have just gone with the 0 and 100%, so that you will see the difference quite immediately. So that's the reason behind splitting the traffic. Instead of 50-50, I'm just going with a 0 and 100%. Alright, so here you can see it's in sync now. So let's try to access the jhook.org, and now it should go forward all the requests to the another first test VPC, which starts with our 12.0 IP range. So I'm just gonna put that one, and here you can see it's forwarding all the requests to my old VPC, which is a test VPC, and which you can verify from here also. Go to EC2 instances running, and here this is the old instance which is starting from a 12. So this is how the weighted routing works, which you can split the traffic between the different load balancer. If you are using the load balancer, you just need to define the weighted percentage in terms of 0 to 256. So just choose suitable number and divide the traffic between those two load balancers. Moving forward, the next routing which we will talk about is the geolocation based routing. So here all the setup is still the same. We are still using the same load balancer, same EC2 instances, but we are just going to modify our A records. Instead of weighted A records, now we will be creating a geolocation based A records. So here we will try to configure a first load balancer for Sweden and another load balancer for Finland. And I'm just going to use the VPN to test this particular feature. So let's go back to our AWS Route 53, delete the old weighted records and create a new geolocation based records for routing. So I'll go back to my browser. I'll close this window and I'll close this one also. Go to hosted zone, go to jhook.org, and here first of all delete this weighted records from the Route 53. Select both of it, click on delete record and click on delete. Alright, so now I have deleted both the records, and our jhook.org will not work anymore. So if I open this one and go to jhook and type org, so it will take a couple of seconds to reflect those DNS changes, and here you can see it has gone. Alright, so the next thing which we will do, we will create a geolocation based routing. So click on create record over here, and here we have seen the simple routing, we have seen the weighted routing. Now we'll select on geolocation routing. So select that one, click on next. Again, we'll go with the jhook.org, which is my main domain, and here we will choose the A record because we want to create an A record. But here define the geolocation record. We need to create those records based on the country. So select that one, choose the endpoint. So I'm just going to choose application load balancer. I think it's this one. That's correct. Reason, I'm just going to choose EU Frankfurt. Load balancer. So I'm just going to choose first load balancer, which is test load balancer. That's done. And here I need to define the location. So I'm just going to serve the request coming from a Sweden for this particular load balancer. So here I'm just going to choose Sweden. And then I'll just put the record identifier. So here I will put a record for Sweden test LB. And then define record. That's been done. Then I'm just going to add one more, and here I will just choose the endpoint as application load balancer. And reason, I'm just going to use Euro Frankfurt, and here load balancer. Here now I'm just going to choose the another load balancer, which is a test VPC from test VPC 2. Select that one, and here in the location I will type Finland, because I just wanted to have the request only served from Finland from this particular load balancer. Alright, so here I will choose the record ID, record for Finland, test LB, test VPC 2. Define record. Alright, so here we can verify once more. So here test VPC 2 load balancer from Finland, and the first one is from Sweden. Okay, so both of them are ready. Click on it, click on create records. And here you can see our geolocation based A records has been added to our route 53. And again, click on view status, and here it is showing the pending state. So it will take a couple of minutes to get it active. Meanwhile, I'll show you my VPN setup so that we can configure the VPN, and then we will be able to test this feature actually. So for that, I'll just open a NordVPN, which I have been using for my personal use. So here is my NordVPN, and I will just choose the region. So click on quick connect, and let's test. It's already connected to Sweden. Here you can see if font is too small, but here you will see connected to Stockholm. So now I'm connected from a Stockholm, and if I take a look onto the diagram once again, so this is my old load balancer from Sweden. So it should point to the IP address of a 12 series, because that's the first VPC we have created, and inside that VPC we have assigned the range of 12 IP addresses. So I should get the only EC2 instance from a 12 IP address, and only those should be visible onto my browser. So let's go back to my browser and check the status. So it's in sync, and yeah, I can see it's in sync. Go to the new tab, and here I will just refresh this page over here, and here you can see it is only serving the request from 12. And that belongs to my test VPC, and which is only applicable for my request coming from a Sweden. So if I refresh this one, so here you can see the IP address is not changing because I have configured the traffic coming from a Sweden. Alright, so that's we have tested. So let's disconnect this one, and I will now connect to Finland. So let's try to search over here, Finland, and select Finland over here. And let's check. Yeah, now I'm connected to Helsinki, which is Finland, and I will try to refresh the same page once again over here, and here you can see the IP address has changed to now 13. So as you can see, our request is getting directed based on the location because of geolocation based routing. So if you take a look onto the diagram, so here this is the geolocation based routing which is working. So this is how you define. So if you take a look onto the A records once again, so here you can see we have 2 A records, and one for Sweden and one for Finland. And based on these location, now we are getting redirect. So this is how we configure our geolocation routing in our Route 53. Now let's talk about the last routing, which is like a failover routing, and as the name suggests, so it will work when something fails onto the one A record side. So here I'm taking the same example where we are having a multiple load balancer which is working inside my AWS account. So there is a one load balancer which is serving, and there is another load balancer which is serving from another EC2 instance. So here you can see this is the request flow. But now what will happen in case of failure? So what we will do, so let's assume that our first load balancer, which is present inside my test VPC with the IP range of 12, fails. Then what will happen is like it will start serving that request from my another load balancer which is present inside my test VPC 2, which starts from the IP range 13. So in that case, we will define primary and the secondary A records inside our route 53. So in case if primary fails, then we still have a secondary A record to serve the traffic. So that's the purpose of our failure routing. So for that, what we will do, again, we will go back to our AWS console, and now I'm just going to delete this geolocation based A record because we have already seen that demo. So I'm just going to click on delete records, click on delete. And I'm just going to close this one, and here we can see our default hosted zone. So now we need to click on create record, and now we have seen simple weighted geolocation. Let's check the failover routing. Click on next, and here I will just go with the main domain. A records, that's fine. Click on define failover records. So click on it, choose the endpoint. So here I'm just going to choose the application load balancer. Reason, so I'm just gonna choose EU Frankfurt. Load balancer, so here I'm just gonna choose first load balancer, and here I'm just gonna define as primary because that's the first load balancer which is in the range of IP address 12 inside my test VPC. Alright, so here I just need to define the record type ID. So here I will choose like a primary A record. Click on define failover record, and then add one more define failover record for secondary. So here I'm just going to choose application load balancer. Reason, I'm just going to choose EU Frankfurt. Load balancer, here I'm just going to choose test VPC2 from the test VPC IP range 13. Choose the type as a secondary. Yes, that's correct. And I'm just going to choose the record ID. So here I'll just choose a record. I'll just put secondary first of all, secondary A record, and then click on define failure record, and then select both of it and click on create records. And here you can see our both the A records has been created, and one is primary is pointing to the test LB with the IP range of 12, and this is pointing to the test LB from a test VPC2 with the IP range of 13. Check the status over here, and here you can see it's still in pending. So let's wait for a couple of minutes and I'll be back once it's in sync. Alright, so now both, not both, but at least our hosted zone A records are in sync now and both are active. So let's go back to our diagram and take a look. So now we are simulating the scenario where we want to fail the load balancer from a test VPC from IP range 12. So this primary route, we want to fail it. So what we will do, we will just go back to our home page, go to your EC2 instance over here, go to EC2 instances, and here we are just gonna change the state of this instance, which is test EC2 instance, which is running inside my test VPC with the IP range of 12. So what I'll do, I'll just go to instance state, and here I will just put stop instance and click on stop. So it's stopping that particular instance at the moment. So here you can see it says stopping. And if you take a look over here, so here we have done the stopping of that particular instance, which means our primary, this primary route is down. And now all the requests should be served from my secondary routes. So what we will do, we'll just go back to our browser, and it might take some time to propagate all these changes. So you need to be a little patient because you might still be having some requests served from our old instance because it's still getting stopped. Okay, so here just refresh this page. Here you can see the service is temporarily down. It shows that message, but it will take a couple of minutes to come into picture, and it will start serving from our secondary A record type. So I'll be back and we'll refresh this page once again. Alright, so I have waited for a couple of minutes, and let's try to refresh this page once again, and now it should point to the IP address of EC2 instance, which is 13. So let's refresh this page over here, and here you can see it is pointing to the 13. And go to EC2 dashboard once again and refresh this one also once more, and here you can see that's only one instance running. Click on it, and here you can see the IP address, that is 13.0.1.25. This is the IP address, and the same which you can see over here also from our domain name. So this is how you will configure the failover routing into our Route 53. So with that, we conclude our session on a Route 53, and I hope this comprehensive course on Route 53 will help you to understand Route 53 in a much better way. So see you into the next session of our DevOps and AWS session, and also please consider subscribing to the membership program which I have just launched in the previous month. So where I also share more in-depth knowledge sessions which is close to our industry standard. Hello and welcome back, and in this session we are going to talk about the AWS Certificate Manager. And here is what we are going to implement inside our AWS Certificate Manager demo. So first, user is going to make a request using the URL. That request is going to land on our AWS Route 53. Route 53 is going to forward that request to our application load balancer, and that load balancer is going to point to our EC2 instance where our application is running. But to secure that URL, we are going to use the AWS Certificate Manager, which is going to issue the certificate to us, and we are going to use those certificate records inside our AWS Route 53. And once we have imported those records inside our Route 53, then we are going to use the same URL, but this time we are going to use the HTTPS. Let's break down this whole implementation into multiple steps. So the first thing, we will start with our AWS account. Second, we are going to set up our VPC within that AWS account. Third, we are going to create a subnet inside that particular VPC. Fourth, we are going to set up our internet gateway. Fifth, we are going to set up our route table. And sixth, we are going to set up our EC2 instance. After setting the EC2 instance, then we are going to create an application load balancer so that an user can access our application running inside an EC2 instance via the load balancer. And for that, we are going to use the DNS name of our load balancer. So after setting up the load balancer, the next thing which we are going to configure is our Route 53. And once we configure the Route 53, then user can make a request using the URL. So here you can see into the diagram, then we will have a Route 53 on top of our load balancer. And that user can use the URL like http://jhook.org, which is my own domain, can be used to access the particular service which is running onto my EC2 instance. But as you have noticed into the diagram, that URL I am using is HTTP. It is not HTTPS. And to introduce HTTPS into the URL, then we need to use the AWS Certificate Manager. So we are going to use the AWS Certificate Manager to generate those certificates, and we are going to use those certificate records to insert into our AWS Route 53. So once we create those records inside our AWS Route 53 after generating those certificates, then we can use the URL that is HTTPS along with my domain. Well, that was a quick overview like what we are going to implement. So let's start with our demo, and here you can see this is my AWS account and this is my AWS console. So let's take a look onto the diagram once again and see what are the components which we need to create. So as we know, this is our AWS account. The next thing which we need to create is the VPC. So I'm just going to go back to my AWS console. In the search box, type VPC. Click on the VPC over here. Click on create VPC, and you can just choose VPC only. Put the name. So I'm just going to put test VPC, and here we need to mention the IP range of my VPC. So I'm just going to use 12.0.0.0/16. And after that, I'm just going to keep the default tenancy and then click on create VPC. And here you can see our test VPC has been created, which you can verify from your VPC section. And here you can see our test VPC has been created. Let's move ahead. The next thing which we need to create is our subnet. So again, go back to our VPC dashboard over here and click on this VPC dashboard link on the left navigation side. And here you will find the options for a subnet. So click on subnet, and here you will find default subnet, but we are not going to use those one. I'm just going to click on create subnet, select the VPC which we have just created because we are still working inside our VPC. Here you can see this is the VPC and this is our subnet. So again, go back to our AWS dashboard under the subnet section, select the VPC which is our test VPC, and here we need to enter the name. So I'm just going to put the name test public subnet 1A, and here I'm just going to choose 1A over here, or I'm just going to write 1A because I'm just using the Europe Central 1A to identify my subnet. So select this availability zone. Here we need to specify the IP at range of my particular subnet. So I'm just going to use 12.0.1.0/24 so that I will have a 256 IP addresses for me. I will add one more subnet over here because I just want maximum availability. So I will choose a different zone to provision this subnet. So I'm just going to copy this name from here, go to subnet 2, and I'm just going to change it to 1B. Then availability zone, I'm also going to change to Europe Central 1B over here. And the IP range, I'm just going to choose 12.0.2.0/24. So here is the difference. Here, this IP range is starting from a 2.0 at the end. You can see 12.0, 2.0, and this subnet is 12.0, 1.0. So that's the basic difference between the IP ranges of my both the subnets. After that, just click on create subnet over here. And here you can see our both the subnets are ready. After creating the subnet, the next resource which we need to create is our internet gateway. So again, go back to our AWS console and onto the VPC dashboard. And here you will find internet gateway. You can find it from the left navigation menu also. So here you will find the option for an internet gateway. So click on it. And here you will find some default internet gateway which has been created. So I'm just going to click on create internet gateway because I don't want to use the default one. So I will create a new one, and here I will put test IGW, which is the abbreviation for internet gateway I'm using. And after that, just click on create internet gateway. And here you can see our internet gateway has been created. But the thing is, you are working inside the VPC. Here you can see this is the VPC and this is our internet gateway. But this internet gateway needs to be attached with this particular VPC. So for that, what you need to do, here you will find the option for attach VPC on the green bar, or either you can go to actions and click on attach to VPC. And here you will find a VPC which we have just created, which is a test VPC. So select that one and click on attach internet gateway. Alright, so after creating the internet gateway, the next resource which we need to create is our route table. So for that, go back to your again AWS console, click on VPC dashboard over here, and from the left navigation menu, you will find a route table. So click on this route table. This is the default one. We are not going to use that one. Click on create route table. I'll just close this message box, and here we need to enter the route table name. So I'm just going to use test RT public because this is going to be my public route table so that I will have access to internet. And here we need to choose VPC since we are working within the VPC, and the name of the VPC is test VPC. So I'm just going to select that one. Again, you can check the diagram. So we are creating this route table, and this route table is again under the VPC, and the VPC name is test VPC, which we have just created. Okay, so here I have selected the test VPC. The rest of the things are I'm just going to keep default. Click on create route table. And here you can see our route table has been created. But the thing is, once you create this particular route table, then this route table needs to be associated with the subnet. So here you will see, here I have created some arrows. So this is a route table which is associated with our public subnet. So for that, we need to attach that subnet to the public route table. So go back to your console, click on subnet association. I am under the test RT public. This is our public route table. So click on subnet association over here, click on edit subnet. And here you will find the subnets which we have just created. Select all of it, click on save association. And now we have associated our subnet with our route table. But again, if you take a look onto the diagram, then we need to attach our internet gateway as well so that this public subnet can access the internet. So for that, again, go back there, go to the routes over here, click on edit routes, and here click on add routes, and here type this address, so which means the internet you can access, or this particular subnet can be accessible from anywhere. This is the IP address for that, and here you will choose internet gateway, and here you will choose test internet gateway which we have just created. So select that one and click on save changes. And here you can see our internet gateway has been attached with my route table. So again, take a look onto this diagram. So we are pretty much done with our internet gateway, route table, and public subnet, and we have attached all the three components. Moving ahead, the next resource which we need to create is our EC2 instance. So again, go back to your AWS console over here, go to the home page of AWS console, and here in the search box type EC2, click on this EC2. And here you can see there are no instances running. So I'm just going to click on launch instances over here. And here we need to enter the name of the instance. So I'm just going to put test EC2. And here I need to choose the base operating system. So I'm just going to choose Ubuntu over here. And the machine type, I'm just going to use t2.micro. Key pair login, I'm just going to create, or either you can create a new key pair, but I'm just going to stick with the existing one. So this is going to be the key which I will be using. If you don't know, then just click on this create new key pair, and then you will be able to download your private key with your EC2 instance, which is you're associating right now. So that's the key pair thing. Then the important thing is the network setting. So click on this edit over here, and here we need to select the correct VPC which we have just created. So if you take a look onto the diagram once again, so we are working under the VPC and this is our EC2 instance. So here from the drop down, select the VPC which is our test VPC. Subnet, we have created two subnets. So here you can see both the two subnet, 1A and 1B in the Europe central region. So here I'm just going to choose first subnet. Auto assign public IP, so I'm just going to enable it. So yes, I want the enable the auto public IP for that one. And then we need to create some security groups. So for that, I'm just going to create keep the default one, which is SSH. The next security group which I'm just going to put is HTTP, so that I can put HTTP request towards this EC2 instance. And source type, I'm just going to put anywhere, so that anyone from anywhere in the world can access this EC2 instance. So that's why I'm just going to keep the source type as anywhere. Okay, after creating both the security group, the next thing is the storage. I'm just going to stick with 8 gigs. That's fine. Go to advanced detail, and here you will find some option like a user data. So here I'm just going to install some custom packages. So I'm just going to copy that script from my notepad, and this is script where I'm just going to install the Apache. So here, this is the script. Here I'm just going to install and update the package. Then we are going to install the Apache, and this is the index.html page where I'm just going to print the host name of my EC2 instance. And once it is done, then it is going to restart the Apache. And this will happen on the boot time when this machine is getting started. So this is the main part of this user data script. All right, so now we are done with this user data script. Then what I'm just going to do, I'm just going to click on launch instance. And it will take a couple of minutes to get this instance ready. And I'll be back once this is up and running. After a couple of minutes, my instance is up and running. Let's verify a few details. So here click on instance ID, and this is the public IP address. So I'm just going to copy this public IP address and paste it over here. And here you can see this is the host home page of my EC2 instance where I have installed the Apache 2. But remember, we are not going to use the IP address, but our aim is to first create a load balancer, then point that domain to this particular IP address that we are going to see later. But just keep in mind, we are just trying to verify our EC2 instance at the moment. Let's move ahead, and the next resource which we need to create is our application load balancer. So let's go back to our AWS console and start setting up our load balancer. So here, this is the home page with the public IP address. I'm just going to close that one, and this is the EC2 instance. So I'm just going to go again to the home page over here, go to EC2. And in the left navigation menu, you will find a section for a load balancing. But before we create a load balancing, we need to create a target group for load balancer. So here in the load balancing section, you will find a target group. So click on this target group, and here we need to create a target group. So target group is just a logical group where we will put our EC2 instances. So for example, we have created one EC2 instance over here. So we can add that EC2 instance into one target group, and one target group can contain multiple EC2 instances, so that our load balancer can point to the target group, and target group can have a bunch of EC2 instances running, so that load balancer can direct the traffic between those EC2 instances. So that's the significance of this particular target group. So let's create this target group first. So here I'm just going to choose instances, and here name. So I'm just going to put test TG for target group. Protocol, I'm just going to keep it HTTP. Then I'm just going to stick with IP4 address, and the VPC, which is important because everything we are doing within this VPC. So this VPC name is test VPC. So I'm just going to select the test VPC. Protocol version HTTP1, that's fine. Health check, I'm just going to keep it default and then click on next. And here you can see our instance it is asking. So would you like to include this particular instance into our target group? So just select that one. And here you can click on include as pending below. So include that one over here. And after that, create target group. So click on create target group. And here you can see our target group has been created and our instance has been added to this target group. So this register target, as you can see, the count is 1. But if you create multiple EC2 instance, then you can follow the same procedure to add multiple EC2 instances. So that's all about our target group. Now we will go back again onto our left navigation menu into the load balancing section, and now we will create our load balancer. So here click on the load balancer in the left navigation menu. I will just put it down over here, and here you can see there is no load balancer as of now we have created. So I'm just going to click on create load balancer, and we are going to choose with the application load balancer. So and here we just need to click on create. Here we need to enter the name of the load balancer. So I'm just going to put test LB. For LB is for load balancer. Scheme is internet facing because I want to be internet in this load balancer to be available publicly. IP4 because yes, I am assigning the IP4 addresses. The VPC, which is again important. So again, this load balancer is sitting under the same VPC. So here you can see. So I'm just going to choose the same test VPC over here. And here it will ask for the subnets. So the subnets which we have created. So we have created 1A and 1B subnets. I'm just going to select both the subnet. After that, the security group. So this load balancer, in the load balancer, we also need to enable the same port. So first of all, we need to enable the port 22 for SSH so that we will be able to SSH into our EC2 instance. We need to enable port 80 and also we need to enable the port 443 that we will take a look later. But let's enable the security group for port 80 and 22. So here I'll just click on create security group. And here I'm just going to name the security group. So I'm just going to put test security group for LB. Description, so I'll put allow SSH port 22 and port 80. VPC, I'm just going to select test VPC over here, click on add rule. So I'm just going to choose HTTP over here, port 80, and I'm just going to select it from anywhere. Add one more rule. So here I'm just going to put SSH 22 and anywhere from IPv4 so that anyone from anywhere can SSH or can access the HTTP port. So that's the significance of this rule. And then outbound rule, I just don't want to keep anything. And after that, I'm just going to click on create security group. And here you can see our security group has been created. So I'm just going to copy this name of this security group, go back to my application load balancer, just refresh this list. And here you will find the test security group for LB. Select those security group, go down, and here you can see there are some listeners. So here you can see it is listening on a port 80. So what I'll do, I'll just stick with the port 80. We are just going to see it later when we will be enabling the HTTPS. And after that, you just need to verify a few details over here, and then you just need to click on create load balancer. Here you need to select the target group, which I forgot to mention. So as you remember in the previous step, we have created a target group where we have already included the EC2 instance. But now our load balancer needs to point to that target group. So here, just from the drop down, select the target group, which is test TG. So that's the target group, which includes our EC2 instance. So just keep in mind. And after that, if you go down and then click on create load balancer. And here you can see our load balancer has been created. So again, go to the load balancer section, and here you can see it is provisioning. So it might take a couple of minutes to get it provisioned. So I'll be back once this load balancer is up and running. Now my load balancer is up and running and the state is changed to active. So click on this load balancer over here and copy the DNS names to verify that our load balancer is pointing to the same EC2 instance or not. So copy this DNS name from here, go to the new tab and hit enter. And here you can see it is pointing to the same EC2 instance which we have accessed using the public IP. So if you take a look onto the diagram once again over here, so here you can see we have completed this setup. So here is the user which is using the DNS name. So this is a DNS name. So this is just an example DNS name I'm taking over here, which is different from the one which I have provisioned right now. So this DNS name has been used for this load balancer, and this load balancer is pointing to our EC2 instance. But still, we don't want to use the load balancer DNS name. We want to use our own domain name. So for that, we need to introduce our Route 53. So here you can see onto this diagram, now we are going to introduce our Route 53, and Route 53 doesn't reside under the VPC. It is a global resource. So whenever you create a Route 53 or hosted zone inside a Route 53, then it doesn't belong to any region or any VPC. So it will be a global resource, just to keep in mind. Alright, so now we are going to create our Route 53, and in the Route 53, once we create, then our user is going to use our URL, and that URL is going to point to the Route 53, and then it will go to the load balancer, and then the load balancer will point to our EC2 instance. And at last, we will have our domain name, which we will be using. But still, we are not using the HTTPS. We will still see HTTP. Because first we need to introduce our Route 53 into the system, and once we create a Route 53, then we are going to use the AWS Certificate Manager to set up the SSL. So let's go back to our AWS console and start setting up our Route 53. Here is my AWS dashboard. In the search box, type Route 53. And here you will find the option. So click on Route 53. And here you will find the option for a hosted zone. So click on this hosted zone over here. And here you will see I have already created the jhook.org, but you don't need to worry. I can show you like how you can set up your own domain inside your hosted zone. So what you need to do, you just need to click on this create hosted zone. So click on this create hosted zone, and here you need to enter the name of your domain. So let's example take test XYZ. This is your supposed to be the domain. I'm assuming that you might be having some kind of a domain which is already reserved for you, or you are the owner, or you have already purchased that domain. So just keep in mind, you need to keep the same name. So if let's example say test.xyz your domains, then just put the same name over here into the hosted zone. And here into the description section, you can put any description, but just for this demo purpose, I'm just not gonna keep anything because it's optional. The type, I want to have it as a public hosted zone so that anyone with that particular domain URL will be able to access that particular service. And once you enter this name, then just simply click on create hosted zone over here. And here you can see our hosted zone has been created for test.xyz. If you go back to the hosted zone dashboard, then you will see two hosted zone over here. So let's compare both the hosted zones so that you don't feel that I have not shown you like how to create your hosted zone for jhook.org, which I'm just going to show you later. But let's click on test XYZ, and here you will see two records. One is the name server record, which contains the name server setting, and one is the SOA record, which contains this particular record. So these are the default setting which is been provided by AWS. And if you compare with the other hosted zone, which is jhook.org, which is my own domain. So if you take a look over here, then you will also find the same settings. So there is no difference between those two. So here you will find the name server, and these are the name server setting. And here you will find the SOA, which is this record. So these settings are same. So just create a hosted zone based on the domain which you have purchased. So it might be possible that you have purchased that domain from GoDaddy, Namecheap, or even AWS also helps you to purchase that particular domain. So just keep the same name and create the hosted zone. Now we know like how to create the hosted zone, but I would like to explain one concept, which is our name server setting concept. And this is the slide which I have taken from my previous demo. Because I have purchased my domain from a Google domain, which you can see on the left hand side, and this is my AWS services. So what happens is we have created a hosted zone, and once we create our hosted zone, then we get our name server record, which is from AWS, which you can see over here. But also if you purchase a domain from any registrar, for example, this is my Google domain, but if you purchase from a GoDaddy or a Namecheap or any other service provider, then that particular domain will also have their own name servers. So here you can see these are the records from my Google domain. But things are like we want to point this domain to our AWS services. So what will happen in that case? So we will not be able to use the name server record of our Google domain. So we need to rely on this particular records, which is from AWS. So what we will do, we will just copy these records from our AWS hosted zone for our name server, and then we are going to paste those records inside my Google domain DNS settings, so that our jhook org, the domain which I have purchased, will be pointing to the domain name server records of AWS instead of Google one. So once anyone enters that URL, then it will be pointing to the name server records of AWS, and from there we will take that request to our load balancer, and then that load balancer will point to our EC2 instance. So this is how this name server settings work when you purchase a domain from any other service provider. And here I can show you my Google domain name setting. So here, this is the domain which I have purchased, which is jhook.org from Google domain. And here you will find a DNS setting. So click on this DNS setting, and this DNS setting you will find in any service provider, whether it's a GoDaddy, Namecheap, SiteGround, you will find these settings over there. And here I have used the custom name server setting, which is active right now. And if you go down over here, then you will find the option. So here you can see the same settings which I have been updated over here from AWS. So here, if you go over here, then you will see, I'll just verify for you, NS652 AWS DNS. And here you will see NS652 AWS DNS 17.9. And these are the records which are exactly same from AWS. So this is how you point the name server setting if you have purchased any other domain from any other service provider. Let's get back to the topic. So here we have created a hosted zone inside our Route 53, but this hosted zone is still not pointing to our load balancer. So what we need to do, we just need to create a record inside my hosted zone. So again, go back to your AWS console. I'm just going to close this page. And this is the hosted zone of my jhook.org. So here we need to create a record so that it's point to the load balancer. So click on create record. Click on simple routing. Click on next. And if you don't know about the Route 53, then just check the previous lab session where I have created the whole Route 53 course and how to create your simple weighted geolocation based routing. So I would prefer to check, I would recommend to check you that particular course if you are not familiar with the Route 53. That is more in-depth session. All right. So here now we are pointing our record, or we are just trying to create a record so that it points to the load balancer. So click on define simple record, select the A record over here, and we are going to use the main domain, which is jhook.org. So here we need to choose the endpoint. So here, just from the drop down, we are going to select the application load balancer. So if you take so just select this one first of all. So this is the application load balancer we are pointing. And here you can see, this is our Route 53 and it is going to point to this particular load balancer. So here I have selected the type, which is load balancer. And here we need to choose the region where your load balancer resides. So I'm just going to choose Europe Central 1A. And here from that, you will find a search box where you can search the load balancer. And this is the load balancer which we have created. So select this load balancer and click on define simple record. And our record has been created. Select this and create records over here. And here you can see now, apart from NS and SOA records, now we have one more record which is pointing to our load balancer, which you can see over here. This is the name of my load balancer. And here you can check the status, and here it shows it's pending. So I'll be back when this status has been changed and it is in sync. And here you can see the status has changed and now it is in sync right now. All right, so let's go back to our hosted zone once again, and here you can see all the three records. And now I'm just going to open a new tab over here, and I'm just going to type jhook, and I'm just going to type org over here. And it might take a couple of minutes to activate or propagate those DNS settings. So I'll just wait for a couple of minutes to propagate those changes, and I'll be back once those changes has been reflected over here. And after a couple of minutes, my DNS changes has been propagated, and here you can see now I'm able to access the same home page of my EC2 instance using the domain, which is jhook.org. So if you take a look onto the diagram once again, so here we have completed this setup. Now user is able to access the URL without HTTPS. It is still HTTP, and it is pointing to the Route 53, and then Route 53 is going through the load balancer, which is accessing the EC2 instance. Let's move ahead, and the next thing which we need to set up is the HTTPS and SSL, and for that we need to have our AWS Certificate Manager. We are going to use the AWS Certificate Manager to request the certificate, and once we get those certificates, then we are just going to create those records inside our AWS Route 53. And once we import or create those records inside our Route 53, then we will be able to use the HTTPS URL along with our domain. So let's get back to our AWS console and let's start setting up our certificate manager and create our certificates. Here is my AWS console, and to create a certificate, first you need to type the certificate manager over here. So here you will find the option for a certificate manager. So click on this first link over here. And here you will find an option for a request certificate. So click on request a certificate. Since our domain is into our public area so that anyone can access that particular domain, so I'm just gonna use request public certificate. Click on next. Here we need to enter the fully qualified domain. And since we are working with my own domain, which you can find into the Route 53 hosted zone. So I'll just open it once again over here. So click on hosted zone over here. And jhook.org. So this is the domain for which I need to create the certificate. So I'm just going to copy this name, go to my certificate manager, and here I'm just going to put the name. So this is my fully qualified domain name for which I need certificates. Second, the validation method, I'm just going to use DNS validation because I have already copied my domain name server record into my Google domain from AWS. So I'm just going to stick with the DNS validation, but in case if you don't know, then you can just use the email validation as well. It will send a validation email onto your registered email ID from where you have purchased the domain, and then you can do the email verification from that side. Key algorithm, I'm just going to stick with RSA 2048. And the tags, I'm just not going to create any tags. Click on request. And here you can see successfully requested certificate with the ID. You just need to refresh this page to view the certificate. So refresh this one, and here you can see our certificates are ready. Now, if you take a look onto the diagram once again, then we have created the certificate over here. But now we need to create this record of this certificate into the Route 53. So again, go back to our AWS console over here. So here you can see this is our certificate. If I'm just going to refresh it once again, so here you can see the status is pending validation. So for that, what we need to do, we just need to click on this certificate, and here you will find this particular record. Like this is the record which we need to create the record inside the Route 53, or in another way I can say we need to push this certificate records into the Route 53. And for that you will find the option create records in Route 53 button over here. So just click on this button over here. And here you will find create record. So this you just need to click on this orange button, and you just need to push this record into the Route 53. So click on create records, and here you can see successfully created the DNS records. And if you go to the Route 53 over here, so I have not refreshed this page over here, and these are the 3 records which we have previously created. So what I need to do, I just need to refresh this one, and you will see one more record for our certificates. So I'm just going to refresh this one. And here you can see this is the record which has just been generated over here. And if I open this one a little bit more, then if you copy this ID from here, and if you go to the certificate manager, and if you try to find it over here, then here you can see this is the CNAME record which has been just pushed or just has been created to the Route 53. After we created the Route 53 record, we need to refresh this page so that this status pending validation should go away. So I have waited for a couple of minutes, and after that I have just refreshed this page. And here you can see the status is issued. Now the certificates has been issued, and those records has been updated properly into our hosted zone of my domain. Alright, so before we access the URL with HTTPS, we still need to work on the load balancer still. So if you open the load balancer once again, so I'll just open my AWS console, go to home page, and if I go on to the EC2, because load balancer resides into the EC2 dashboard. So in the left navigation menu, click on the load balancer and click on the test LB, which we have just created for this whole setup. And here you will find listeners and rules. So the listener rule is only for HTTP. It is not for HTTPS. So we need to add one more listeners over here for HTTPS. So what we need to do, we just need to click on add listeners over here. and here you will find a protocol. So HTTP already exists, so we don't need to change that. We just need to use HTTPS. And as soon as you use the HTTPS, then the port will change to 443, which is the default one for HTTPS. And after that, you need to choose the forward to target group, and the target group is test target group over here, because that's the target group where our EC2 instance is present. Moving ahead, the next thing which we need to set up is our certificate manager. So into the secure listener setting, you will find an option from ACM, which is our AWS certificate manager. And here you will find a drop down, and here you will find a certificate which is jhook.org, which we have just requested. So select this certificate, and after that you just need to click on add. So click on add over here. And here you will find the two listener rules. One is for HTTP and another one is for HTTPS. One more thing over here, since we have enabled the HTTPS and port 443, then we need to enable, or we need to open the security group for HTTPS as well. So again, in the same load balancer, which is our test LB, where we have already configured the listeners and rule for HTTP and HTTPS, we need to go to the security. And here you will find the security group. One is the default one, and one is the another one, test SG security group, which we have created. So open the security group, and here we need to add an inbound rule for HTTPS as well. Otherwise your request will not go through. So here you can see, if you click on edit inbound rule, then here you will find the HTTP and SSH, but we have not set the inbound rule for HTTPS. So click on add rule over here. And from the drop down, select HTTPS, and here you need to select from anywhere. So anyone from anywhere can access this particular domain, and that domain will let you through the load balancer, and then load balancer will check these security group to let the request go through. So we have enabled the HTTPS for our load balancer as well into our security group, and then click on save rules. And now you can see our inbound rule is allowing HTTP, HTTPS and SSH requests which are landing on this particular load balancer. Alright, so now we are done with our setup, and let's verify by accessing the URL. So I'll close this one, and I'll close this one also, and I'll open a new tab over here. And first of all, let's try to access jhook.org without HTTPS. So this is a simple URL which I'm putting, and here you can see this is the icon which says connection is not secure, which means I'm just trying to access it with HTTP. So this is accessible. I'm just gonna open one more tab, and here I'm just gonna type HTTP. Sorry, I just need to type HTTPS, and here I will type jhook.org. And here you can see now I am able to access, and that particular error message connection is secured now. So now we are having both the URL open, which is like a non-secured one, and this one is secured. So at least the verification part is good. At least we are able to use the HTTPS inside our URL, and our both the URL patterns are working. But the thing which we need to notice over here is we need to stop the HTTP request, or at least we need to redirect this particular request which is coming without HTTPS to our HTTPS part. So the next thing which we are going to fix is to redirect this particular request where we don't put HTTPS, and we should redirect this request to land on this HTTP URL. So how to fix that redirection? So again, you need to go to your AWS homepage over here, go to your EC2 and go to your load balancer. So in the left navigation menu, you will find a load balancer over here. Click on this particular load balancer and go to the listeners and the rules section. And now we are interested into the request only for HTTP. We want to block that request, not block the request, but at least let go that request and redirect it to the HTTPS. So click on this HTTP over here, and here you will find these rules over here. So click on this default rule, and here we need to click on actions, click on edit rules, and here we need to redirect this particular request. So for that, what I'm just going to do, I'm just not going to forward this request to the target group, but instead I'm just going to use the redirect URL. So here I'm just redirecting this URL to the HTTPS, and the port is 443. And here you will see, I'm just going to deselect this one. I don't want that one. And here you will see a HTTP code, which is 301, which is permanently moved, which means any request which is landing on HTTP will be redirected to HTTPS, so that it's only serving from a HTTPS. So click on the save changes over here. And as you can see, successfully modified the listener, and now you need to wait a couple of minutes or a minute, and then it will start redirecting the normal HTTP request to the HTTPS. Let's open a new tab over here, and here I'm just gonna paste the URL, and here you can see this URL is ending with HTTP. I'm not using HTTPS, and once I hit enter, then it should redirect me to the HTTPS. So click on here, and here you can see it has redirected me to HTTPS, which you can verify from here. Connection is secure. So this is how you are just gonna set up your SSL, and then you can also redirect your normal HTTP request to HTTPS. And in case if you are using some other domain, let's say for example www.jhook.org, then there is again a different name. So you need to request a certificate for that particular domain name as well. So you need to create a new certificate, and there you need to enter the root name as www.jhook.org and request a new certificate for that particular domain as well. And then push those record into again to our Route 53, and then after that you will be able to access the URL or the home page using the www URL pattern as well. So this was a small session on how to handle your SSL with our AWS Certificate Manager, and I hope you like this session. Then please put down into the comment section whatever queries you have, and please consider subscribing to this channel. And also if you are new to this channel, then I have already uploaded 15 sessions on AWS. So if you are just getting started with AWS, then I would highly recommend to go through those sessions as well. Those are also quite in-depth sessions. Also considering subscribing to the membership program of this particular YouTube channel, where I also keep on sharing more in-depth level session only for the members of this particular YouTube channel. So if you are interested, then please check out the membership program as well. So see you into the next session of our DevOps and AWS. Till then, take care and bye-bye.